Okay, is my screen sharing? Yes, fabulous. Okay, right. So today we are doing Introduction to R, as it says, sort of data to insight, and the plan is to try to make it hurt as least amount as possible. So, let me see if I can actually get my slides to go on something. So, quick introductions. My name is Simon Wellesley-Miller. I am a senior analytical manager in the Southwest Intelligence and Insights team for NHS England. I guess very, very briefly, my R journey. I think I started using R about 6 years ago, I guess now. Um, so my analytical journey, I started, my first analytical job was working for a local council doing child protection data. Our entire database was about 6,000 children. So that was our entire database had about 6,000 children in it. So it was tiny on the grand scheme of things. And we would do absolutely everything in Excel and and we use business objects. Our business objects, basically, we would download entire tables, splat them into Excel, and then do like VLOOKUPs on absolutely everything. And it was an awful process. It took us about 3 months to we reported quarterly, and it took us about 3 months to make those reports because everything was just so manual about downloading this data set, copy and paste it, do this VLOOKUP. And we had these most crazy convoluted processes. We would report 3 times a year. The fourth quarter was sent to sort of statutory returns, and looking back on it, frighteningly dreadful process of waste and whatever. I moved on from that job and I got a job in the police, and that was the first time I saw we used ClickView, and that was my first little insight into sort of seeing code and actual sort of BI rather than just Excel. I was only there for a few months for various reasons. Not that they found out about the thing. They did a lovely job evaluation, and it was a nightmare. And then I got my first job as an analyst within the NHS, and actually sort of saw SQL proper for the first time, and just saw how much power in just sort of like coding and automation there was. Still doing a lot of stuff in that sort of SQL and Excel space, but even that sort of moved things on sort of massively. I got really keen. I was always really, really excited about hearing all this like data science stuff, and I was really, really fortunate to get involved with a project with the university where we did a little bit of demand capacity modeling. And I was always really, really interested. When you bought something on Amazon, it says, "You've bought this. Would you also like this?" It's like, how does it know this stuff? Obviously, it must have some crazy clever algorithm in there somewhere. And I always thought there was some of that really clever stuff that we should bring into the NHS and do more clever stuff with. So that sort of thing, a night of passion for me. I was really, really fortunate to, geography wise, to get onto a early iteration of the Health Service Modelling Associates program, or the HSMA, if you've heard of that. Which is really about sort of bringing operational research and data science into the NHS. And then I went on to take my healthcare data science master's at Exeter University, which I completed 3 years ago as a very, very mature student, a good 10 years on anybody else on the course. So yeah, every day's a school day. And I think part of that journey was sort of picking up things like R and Python. Definitely, I'm more of an R person, but actually sort of seeing how powerful that, once you've sort of learned the basics of R, just how amazing it can sort of span out to, more clever things around sort of automation or just data wrangling. And yeah, just the power of it really, and so many convoluted processes that I was again trying to sort of cobble together within SQL or within Excel. R just knocks the socks off of those things. So I think that was sort of my general R journey. As part of that, I was very, very fortunate again to get onto a course to become an R trainer. And I think I've trained like over about 500 odd people or more now. I don't know how many times I've run this course, but it continually evolves, and we add new bits, and we learn from it. So yeah, so really, really part of the big NHS-R community, and I'll talk about that and bits at a later date when we talk about sort of further resources and networks that you can use. Nat check. Do you want to do a quick potted history?
Thank you. Hello, everyone. My name is Maciej Waszak-Hayes. I'm business manager and I'm working at the strategy unit. Unfortunately, I do not have much experience with R, but I'm very, very curious. So that's why I'm here today. So I'm going to support today, Simon. Thank you.
Yep. So Matt is here to sort of put stuff into the, if you put stuff in the chat or whatever, and here we go from that. So let's just get set up. So first thing we want to do is we're all going to use Posit Cloud, which is basically a cloud version of our studio. If we use Posit Cloud, it means we're all using the same versions and we don't have to worry about all those flipping sneaky little local IT issues about getting you set up with our studio. So what we want to do is go to posit.cloud, and that does seem like a very strange URL, but trust me, that is correct. And if you search for Posit Cloud, you can see indeed that is the URL. So we want to go to posit.cloud. I will paste that into the chat as well. And I'll do the intro stuff in a minute. I've got a little mini icebreaker. So yeah, please go onto posit.cloud and get on there. So once you get onto that thing and you go there should be a little button that says get started. Click on the get started button. What we want to do is use the nice free version. So click on the learn more and then sign up. If you already have a Google account, you can just sign in with your Google account, which is nice. Otherwise, go through all this sort of setup process. I've already got one, so I'm going to log in with my existing account. So please shout if I went too fast on any of those steps, or you want me to repeat it. So back to Posit Cloud, get started. Learn more about the free version and then sign up. And like I said, the easiest way is to sign up with Google if you already have a Google account. Otherwise, you go there. I've already got an account, so I'm going to log in and log in with Google. And I'm going to pick my account. And once you sign in, it should take you to a page which looks a little bit like this, but without all the gibberish. You'll have a blank page rather than a load of stuff. Please shout if anybody is getting stuck on that stage. Or actually, if everybody could put a thumb up when they've got to that point, or no, raise your hand for a question. That's what I mean. If you just raise hands once you're kind of there. Not thumbs up because they disappear. Put your hand up. And then we can see if there's anybody who's not got their hand up. Hopefully. Anybody stuck? We've still got a few waiting for. I think if you don't sign up through the Google account, it sort of sends you an email and you've got to click on that and do that, and it takes a little bit longer. That's all. Anybody else? Still got some hands missing. Please put your hand up if you haven't. Oh, sorry, you have achieved that. Oh, so I start picking up. Where we got Louis? What's the problem?
Sorry, I was trying to find my old login. Sorry.
All right, okay. Andrew, you okay?
Yeah, I've just got internet issues, that's all.
Oh, okay.
Sorry, which Andrew? The other one?
I think it was the other one, yeah, the one that hasn't got his hand up. Oh, they've got two Andrews. That's oh, Andrew, yeah.
I've just got login. I've got your content archive and trash, and
yes,
is that right?
Yeah, you should have that. You shouldn't have all of this stuff because obviously you have.
Okay,
so that's fine. Yeah, you'll have a blank screen. Mine's just got loads of stuff in it. So Andrew spoke. So hey, Louis okay. We're still waiting on Andrew B. Is it just being really slow?
No, that was me saying I've done it. Yeah,
you've done it. Okay, right. So everybody put your hands down. So I think we're okay with that. So cool. So once you signed up, it should bring you to that your workspace page, which is great. What we want to do is click on the top right hand side where it says new project. So up here we've got something that says new project, and there's an option down at the bottom that says new project from Git repository. If everybody puts their hands down now, otherwise it gets really confusing. Thank you. And what we're going to do is a new project from Git repository. Okay, that sounds far more complicated than it is, trust me. Basically, all we are doing is just linking to a GitHub repository to download some data into our workspace, just so we've got some data to work with, so we all want the same thing. So if you click on that, it will basically ask you for the URL of our repository, which is this, which I will copy and paste into the chat for you. So yeah, if you copy that link and basically paste it in there. And hopefully that will. And then if you've done that, you can press OK. And again, hands up if you've managed to do that. And then we press OK, and it will say preparing project. Or no, deploying project even. And that will take a little while to chug through. And it should come up with something that looks a little bit like this. Anybody stuck on that? Do shout. So yeah, hands up if you've managed to do it. Otherwise, I assume you haven't. Excellent. Excellent. Andrew S. Any problem? RuPaul?
Can I get the URL again, please?
Yeah, I've popped it in the chat.
Okay.
Right, okay. Just arrived late on the train. We'll catch up. Yeah, so very quick catch up. Let me, oh my goodness me. So yeah, I'm gonna have to go through this very quickly. If you go to, where are we? Posit.cloud. I'll go through the whole process again. Posit.cloud. And click on posit.cloud. Oh, no, because I'm logged in, aren't I? Let me unlog out again a minute. Did it log out? Right, so if you go to posit.cloud, you'll get this screen. You want to click on Get Started. Choose the free one and click Learn More and sign up. Then either sign up with your email, or if you've already got a Google account, click on that one to sign up. I'm going to log in because I'm already there. And then, yeah, log in with Google. The URL to input is, sorry, yeah, I'll choose my account. There's an option on the top right for new project from Git repository. I've put the URL for that into the chat, but it is essentially that one. And then, okay. I'm not going to do it again because I've already done it. So let's go into there. So you'll know it's come through correctly because at the top here, you'll have intro to our data, and then we will explain it a little bit further. But down in the right hand side here in files, you should see there's a bunch of CSV files, beds data, capacity AE, and some stuff, and that's what we're going to be using. So if everybody's cool with that, RuPaul, have you got there? Yeah, excellent, right. Hands down, everybody, please. And we go on to the next bit. So that will get you to there. We've imported the data, and we've just got some data that we can work with. So what we're going to do in the course, very, very quickly, we're going to do a very basic introduction to R. We're going to import some data. We're going to do some wrangling on it, or sort of data manipulation. KO'd, I'm not sure if that's a legacy hand or you've actually got a question. And what we're going to do is create some charts, and hopefully by the end of tomorrow, pull it all together and produce a very, very basic report of some description. This is going to be enough to understand the very, very basics of R and how it works. And, you know, hopefully some of you have signed up to the intermediate course in a couple of weeks. So you'll get some stuff, you'll learn some stuff over the next couple of days, hopefully go away and do a bit of practice. And then we get into a bit more of a a little bit more complex for the next course. So, you know, we're going to start really, really simple. Course rules. Everybody learns by making mistakes. So every time you make a mistake, it's a learning opportunity. So embrace those mistakes, because you're going to make a lot of them. One of the hardest things about R is it's case sensitive, and so if you write the word print with a big P, it will not recognize it. You write it with a small p, it will recognize it. So, you know, unlike SQL where you can write it all in capitals or however you want, R is case sensitive, and believe me, it will. If you're not used to it, it's really challenge. Yes, we will be running some more intermediate courses. We'll also make the materials, and the recordings will be available if you're unable to make it. So yeah, absolutely no problem. So when you do make mistakes, that's an opportunity for the class to learn. So please share your mistake. Hopefully as a class, we can then try to debug it, and, you know, we can all learn from your mistake. Or alternatively, as we're going along, if you find you do a little error and you can't kind of work out what's going on, you know, and then you do fix it, tell us how you've done that. I mean, one of the things I love about R is actually the error messages. 80% of the time are actually really useful. It's not like a SQL where it says you've got an internal 5077 error somewhere near line 24. Quite often, it will actually tell you exactly what you've done wrong and offer a suggestion of how to fix it, which is quite mind-blowing. So yeah, do make mistakes, do think. I mean, without a doubt, one of my best tips is if you have an error message and you can't quite work out what it's trying to say, just read it out loud. You know, you don't have to read it out loud to everybody, but just read it out loud. And the amount of times you go, oh, actually, yeah, that's what it means. Yep, I mean, without a doubt, there is a little bit of syntax and understanding what it's talking about, and obviously we're coming, completely blank, but, you know, it is really, really useful. So more mistakes you make, greater learning opportunities you're setting up for everybody else. So, you know, the person who makes most mistakes and shares them is going to be the best learner. Please feel free to chip in, shout, ask questions, whatever. Obviously, I'm just going to be yabbering away. I've got about 20 screens going on here now. I've got 3, but it's really hard for me to keep an eye on the chat and arms and hands, etc. So just feel free to chip in, shout, or just say, Simon, shut up, I'm stuck on this previous bit. Please don't get left behind. Please don't think, oh, I'm just going to let them go on because I don't want to stop the class, because each of the bits kind of build on top of each other. So if you don't get one of those fundamental bits, it won't work for the rest of it. So, you know, you can get seriously left behind, and I don't want that. And I can't, obviously, it's not a physical thing. I can't see you in your chair rocking backwards and forwards, dribbling. So, you know, do shout, and let me know what's going on. Obviously, this session is being recorded, and we're going to make that available for you. So, you know, let's have this as a, really free, open session rather than me just sort of speaking into the void. So, quick icebreaker while we get a few things set up. Be great if you could just pop in the chat the name, job title, where you work. For me, it'd be really useful to just kind of judge where you are. So, do you have any sort of R knowledge already? Have you used Python or any other sort of programming language? Have you used SQL? Have you used Excel just at like a pivot table and sort of lookup level, or just very, very basic? Or do you not even know what data is? In which case, hopefully we've got nobody at that stage. But, absolutely, just give us a rough idea of where you are. Obviously, if everybody's advanced R users, then why are you here? But yeah, let us know. And then as a final icebreaker, if you haven't done anything else at all, really interested about what your favorite Pokemon is, just because it's a fantastic icebreaker, because if you're into Pokemon, you get really passionate about it and it causes lots of friction there. Or there's the anti-Pokemon people who are like, either I don't even know what they are, dreadful, and yeah, and I don't know, it's a very good one. So cool. I will do that just while I set things up for the next thing. I'll just pop these questions into the chat, just so you do. So if you pop them in there, that will be great. So a little bit of housekeeping. I'm not expecting any fire alarms to go off. Hopefully you know where your toilets are in your appropriate situation. I will do my best to take regular breaks where we have some stuff. I think the course is scheduled to go until 1 o'clock. I probably will do. We'll hopefully get to sort of some natural breaks, and we'll just take breaks. It's very difficult for me to sort of say where that is at this stage, but you know, do feel free if you know you are bursting, just to again shout and say, can we take a comfort break? And I will do my best to accommodate that. And I don't think there's any other bits and pieces we need to do. So I think let's go. Yeah, let us go. So while you're doing that, I will just do a little bit around what is R and R Studio. So quick agenda around what we're going. This is very generic. Obviously, I'm not Zoe, I'm Simon. Agenda. So some of the things that will be covered, not to this time scale, so just so you're aware. We're going to do introduction and getting started, which obviously we are doing at the moment, and then we'll take a break. Then we will import some data and just kind of understand some features of basic features of coding, and also sort of bringing in our data and what it looks like. We will then do some data manipulation, and without a doubt, as I'm sure you are aware in any piece of analysis that you do, that's the hardest bit, you know, without a doubt, is getting your data into the right format, into the right bit that you want it to then, you know, go into your charts and tables, or you know, your sort of analysis in whatever way. So without a doubt, manipulating data is the hardest bit. We're going to do some quite funky bits today, and then in the intermediate course we do a lot more there in that space, but we're going to do some pretty good stuff, which hopefully, if you know, if you are sort of Excel or SQL users, will go, oh wow, yeah, that's really good the way it does that. So that's cool. Then we'll take a break. We'll do some details of, you know, where you can find some further help and sort of what resources are available to you. And then I don't know if it's going to be today or tomorrow, we'll look at ggplot2 for data visualization. So obviously, you know, once we've got some data in, and usual thing we want to do is chuck it into some charts. So we'll do some charting stuff. And then we'll also look at sort of some functions to clean our data, and what else will we do? So yeah, that's basically what we do. And then hopefully by the end of tomorrow, we will pull it all up together, just to do a very, very basic report, so we can show how you do the data ingestion, how we can do some data wrangling, create a chart or two, and then pop them into a report that we can then share, and have that all as one single automated process, which is what we want to do. So the course aims is to introduce R Studio as an integrated development environment, get just the basic concepts of R and how it uses. And what's really nice is once you understand those basic concepts, if you want to then learn, if you want to put in some sort of machine learning, or you want to do some forecasting, or you want to do any sort of further more advanced bits with your R, it all follows that same sort of structure. So once you kind of get the basics of it, it does mean that, you know, when you do want to branch out and do more advanced stuff, it's all in the very similar, familiar syntax. And you know, that is really, really powerful. So yeah, and we'll pull them all together in a Quarto report. So Quarto is just a way of sort of getting your report and sort of publishing it as a standalone thing, whether you sort of publish it into a standalone HTML document, or you can export your data in a Word document or a PowerPoint, whatever you wish. And again, R will allow you to do that. So reasons to use our community, really, really important that, there are really good analytical community out there. So if you do want help, etc., you can go there. Obviously, this whole course is put together by the NHS-R community. So, there are loads of people who within NHS who are trying to use R for good. So that's good. Collaboration. It's really good when you do start learning these programming languages and you start looking at use of sort of GitHub, etc., that you can do this sort of collaboration. And that's really important, that you can do a piece of analysis that you can share with other people. They can write bits of the code and you can integrate it, and you can, you're not so siloed into a piece of work where it's only you. You can actually sort of collaborate on a piece of work, and therefore you get much greater piece of work than the some of its parts. Open coding is, again, really, really important about how we share our code. It is the civil service and government guideline for open code first, that if you've created a piece of analysis, it should be available. You're a public servant, it should be available. And also it means that we can then share and see what you've done. And it's really important as taxpayers to see what other people are doing, how they've come up with stuff. I used to work in a provider. I know how frustrating it is when NHS England or whoever comes up with some numbers that they've calculated and you've got no idea. So, it's really important to sort of show your workings and show you how we've done it, even for just peer review and peer support, and, just for that scrutiny. It's really important. Or to see, has somebody done this before me? Because, the amount of duplication, it's like, I'm sure I'm not the first person to go, calculate this KPI. So where's the code on how to do this? And, can we share that? So that's really, really important. And again, that comes into that whole reproducible analytical pipelines, or RAP, which I'm sure you've heard of, which all the cool kids are doing, is, having that open code and being able to share what we're doing. So that's the very, very basic introductions of what we are going to be up to. There are we are on that one. So what is R and R Studio? So R is the name of the programming language, which sort of sits at the heart of it all. It's a stripped down beast of a thing, which is all just engine, wheels, and just goes. R Studio is, actually, we've got a bit of a shell around this now. It gives us some airbags, it gives us a sat nav, it gives us a speedometer and some indicators, and gives us all those really, really nice things that makes a driving experience much, much more pleasurable and useful and safe. So it's basically an application that sort of sits above R, that does all the things. However, as we're talking along, we're just nobody uses, apart from very, very crazy people, nobody uses R on its own. It's always part of R Studio. So don't think of them separately. When I'm talking about R, I'm talking about R Studio, and I'm just going to use them interchangeably because it's one and the same. And as you see, you've probably got an R Studio instance over, and there's lots of clickable areas which are really, really useful, and it's got some really, really nice tools that we can use to sort of help automate our scripts and go through. R Studio does also work with other languages, not just R. So potentially you can write Python in R Studio if you wish to. Although it's called Posit Studio now, so it's a bit old. So you can use other languages within R Studio. I think you can use Julia, and I can't remember what else. But yeah, potentially you can use R Studio as an IDE over other languages if you so wish. Very easy to set up, as we will show in a moment, and new features are always added. So this is a very, very live piece of software, and it's constantly being updated and improved, which is great. So it might have gone to sleep, but let's just have a look if I can find where is my, it's on this one, isn't it? Yeah, it's fallen asleep. Let's just reconnect if yours has fallen asleep and go back to here. So this is our R Studio. I'm going to do a first thing here, which is go to my global options, and I'm just going to make my text a little bit bigger for everybody because it gets a little bit small there. So hopefully that's a little bit better for you. It is traditional for any new programming languages to do print hello world. as your first command into a new world, into a world. So if we print hello world, ours says hello world back. So there's a couple of things you may have noticed if you type that. So as we type and we do an open bracket, as you can see, our studio has automatically put a close bracket on for us. And likewise, when we've done a speech mark, it's also done a closed speech mark for you. So as you see, our studio's got lots of really nice little features in there to make programming really easy. And also things like and we have multiple believe me, commas and brackets when you start doing programming. It's the same as when you do an Excel formula or whatever, can get quite complicated, and it is important about where you put your brackets are. You know, it does have some nice features that you can sort of go next to a bracket and it will show you where your corresponding bracket is. We can also set up rainbow brackets, and so they're all color coded and go to the appropriate one. I'm not going to do that because it doesn't come across on the screen very well, I am told. But yeah. We can also so we can do we did hello world. We can also do some maths in here, so we can do 1 + 2, and with the power of R we can find out the answer. The answer is 3. Who knew? And so yeah, we can do all that, but that's called the console, this bit here, and that's very much about typing in an individual command and it immediately being executed. Which is, if you can imagine writing a SQL script and you're just writing it one line at a time and it getting executed. Not very helpful. What's actually useful is when you've got a full script and we want to run through everything as we go along. So what we want to do is write some scripts. So if we go up to file up the top, oh no, sorry, not the file, the little new file here, this little green button with the plus on, the green plus button, and new R script, or you can press Control Alt Shift and N, and that will open up as a new window. There's a lot of people not answering the Pokemon question, and a lot of love for Pikachu so far. I can see 0 Pokemon knowledge. My goodness, it looks like it's Pikachu. My goodness me. Anyway, this will open up a new column script for you. Now, if I do 1 + 1 and press enter, nothing happens, because basically that's just it's just a line of script, and I've not told it execute. Again, if you've used SQL, very similar sort of thing. It's not going to run it as you write it as you go along. What you need to do is highlight it and press run, the run button up here. That will set it to run, and then we can see obviously it has now run this as a 2. We can also press Control and enter at the end of the line, and that will also run that specific line. And we can highlight individual parts of our script if we wish to, and we can run that, or we can run that, or if I do the whole lot and run it, it will run both things. And we will do more and more of that as we go along, because sometimes what we want to do is run a script incrementally to see where we've got to, and then we can also do goodness me, I've never remember what run all is. Yeah, there's a run all shortcut, but I never use it. So yeah, I'll find a shortcut for you there for people who like shortcuts. We can also do a little bit more of a setup as well. So we've done that, Control Shift N, and yeah, I kind of showed you the autocomplete. We've got all the normal shortcuts for like Control Shift and Control Z, etc. And yeah, let's go into this. So perhaps the most important thing you will learn is the hash command, and this is a comment. So when you do hash, you'll notice that the text then goes green, and that is just a comment for your code. This is a comment. This is 1 + 1. 1 plus 1. And what that is for, basically, as a reminder or to explain what your code is doing. So good code has lots and lots of comments explaining what it's doing. I always think that future Simon is a complete and utter idiot. He's going to come to this code tomorrow and not have a clue. Even though he wrote it, he's not going to have a clue what it's all about. So I have to write him lots of messages in the future and explain to him in real detail about what is going on with my code. Because, as I said, future Simon is a complete idiot. He's going to come to it and go, wow, what has past Simon done here? I've got no clue. So I would thoroughly recommend that as we do all the processes and we do all these sections, you do a hash and then you write comments about what we're doing. I will try to remember it as we do it, but basically it will go into green and that will not be evaluated within the code. So if I run this is 1 plus 1, doesn't do anything. Obviously, if I didn't have the hash in front of it, this is 1 plus 1. It's going to go unexpected symbol in this is, yeah, it doesn't understand what this is as a command is. Hasn't got a clue what it is. You can also put comments at the end of lines. This, if you actually press hash, this is 1 plus 1. And it will stop evaluating your code as soon as it hits that hash. So really important. And, you know, do comment your code as much as we go, especially when we're doing all this processing, etc. Just so when you come back to it at a later point, you can have a look at it. I'm sure future you isn't such an idiot as me, but, you know, who knows? Oh, I'm showing lots of stuff, which is not what we're after. Right. So that's really important to do in there. You can also you can do Control-Shift-C as well for commenting and uncommenting bits of code as well. So that's good. Where are we? Let's just shut that down because we don't want that open. Right.
Simon.
Hello.
Can I just, sorry, it's Claire. Can I just
Yeah.
check the slides that you're presenting to us? Will you be sharing those afterwards?
I certainly will. Yeah.
Oh, great.
100%.
Thank you.
Yeah, no problem. All the materials, everything will be shared along with the recording. So
Amazing. Thank you.
Couple of important bits which we will do. So if you click on the tools bar and then options and then workspace, and then we'll have a look at the workspace. So if we go back up to our studio, if we go tools and then global options down the bottom, there's an option here for workspace and it says restore R data at workspace at startup. Now, this is very controversial, and I'm going to teach you best practice. And the best practice is to untick that box. So R is really clever. And what it will try, or R Studio is really clever. And what it will try to do is once you finish your work for the day and you close down R Studio, it will try to save a snapshot of all that you've done and all the if you've done, well, it will make more sense when we've talked about it later. But if you created a load of objects in your environment and you've got some data sets loaded in, it will try to keep a snapshot of exactly where you are as at that point, so that when you come back to it tomorrow, you can just carry on from there, which in principle sounds like a really good idea. The problem we have with that, especially when we're writing scripts, is sometimes you can write a script and you've done some bits and you've jiggled it about and your workflow doesn't actually work. It looks like it does because you've got some stuff and it seems to be working, but when you run it as a whole, you've made an error. Quite often you'll sort of go back and retrospectively change something. And so by turning off this option, it means that when you come back to your piece of work, you're always running it through and sort of checking that it does work, because it's really easy just to sort of fudge something, make it work in a specific example and it not work in the future. So it will make more sense when we do it. The other thing that you can have a play with, if you click on the appearance button, and this is what I did very quickly earlier about changing my font size. If you click on the font size, you can also click on these themes if you wish. If you do prefer sort of more of a dark screen, if that makes if that's better for you, please feel free to have a play and find one that looks better for you. Personally, I just like the default because that's what I was taught on. But if you prefer dark mode for your stuff, so that's tool, general appearance, and then it's here. Or if you want to change the size of your font, etc., please do so there. So yeah, just have a couple of minutes or a quick second to see how we go. What's that? Oh wow, you can make it look like an old school 80s green. I don't even know what they keep changing it. Add so many to this all the time. But the main thing that you'll see, even within this example, is that it does things in many different colors. So for instance, if you've got a command, it will put the command or a function into a different color. So it's very, very easy to see when you've made a mistake or what's going on, or if you've got a variable, which are your variables and things like that. So yeah, it's pretty cool at doing those things. So hopefully you'll find a theme that suits you. Obviously we can come back to that at a later date if so is. Let's reconnect to that. Oh, I'm on two different things. That's why it's all going wrong, isn't it? Let's turn that one off. There, that's me there. Right. So yeah, have a mess about with the global options, find something that looks suitable for you. So let's just talk about packages. So R comes obviously as standard with some very, very basic packages. You can also load in additional packages. So to keep the basic language, so R comes with like base R, which is just your basic set of languages or set of commands, which are as standard. What you can do, and if you go on the intermediate course, we'll show you how to do it very briefly, is you can make up your own commands and say, I want a command that takes a number, adds 2 to it, times it by 4, and then divides it by 16. If you want a command that does exactly that, R will allow you to create one, or whatever variation of whatever you want to do. So people kind of create extra packages, and that means you can like have extra bits which you can plug into base R. So if you want to do machine learning, you can pull out a machine learning package. If you want to do a forecasting package, you can plug in a forecasting package. If you want to do some more sort of statsy type stuff, we can set in a statsy package. However, what we're going to use, and like I say, what that means is, so if you're writing a script and you're using some forecasting in it, you can call in the forecasting script. If you're writing a script and it doesn't have the forecasting script, you don't want to do forecasting in it, you don't have to call in that package. So each script will have different packages which it calls in on a sort of case-by-case basis, depending on what that script is doing, which means it just becomes really, 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 really versatile around what we're doing. So packages are a bit like apps for your phone. You can download them and use them as you wish. So what we are going to do is, there's a very, very popular one which is called the tidyverse, and that is essentially what we are going to be doing throughout the project that we're going to be doing today. So there's a couple of ways that we can install it. The quickest and easiest is go to Tools, and then the top option is Install Packages. So packages aren't installed as default. So there's a place called CRAN, which is the Comprehensive R Archive Network, where all these packages are stored. They are all peer reviewed. You have to go through a comprehensive testing process before your package is accepted onto CRAN. So anything that's on CRAN is really, really tested. It's not going to, and trusted. I think that's the main question that I'm looking at. The word I'm looking at is search trusted. So that's really, really powerful. So yeah, if we go to install packages, and again, we're going to install it from CRAN. There are other places that we can get packages from, but CRAN has something like 40,000 packages, so it's probably got things for what we want. And if we start typing out tidyverse, we should have it there. And then once we've got it there and we're all good, we click on the install button, and this might take 2 or 3 minutes, and it will start doing this. So if I just scroll up a little bit, alternatively, if you are, if you don't want to do that, you can actually sort of type it as a command to install it as well. But this will be chugging through for a couple of minutes. So tidyverse basically brings together a load of popular packages that all work together in a very, very sort of unified way, all doing lots and lots of different things, but they all use the same sort of syntax and methodology. And it's pretty much the sort of go-to starter for most things. So hopefully everybody has got that. My organization setup hasn't managed me to install packages. Nice. So I can point you to some resources on that. We might be able to get around it. There are some resources that the NHS-R community has put together, which hopefully will help sort some of that. That's one of the reasons why we're doing it on the cloud, because yeah, cloud obviously makes that not a problem. So what we've done, we've installed the package, or what I've done, you're probably a little bit behind me. So that's installed the packages, and when you obviously on your home version or your work, laptop version of RStudio, it will install it onto your drive somewhere. So you can install as many packages as you want. However, as I said, you can then pick and mix which ones you want to use for this particular instance of script or what we're working on. So what we need to do is our first command basically is call tidyverse library. So if I do, let's try and think of a dplyr command. So mutate at the moment is a command in dplyr, which we're going to be using later on this morning. And if I just run that at the moment, it says object mutate not found. R hasn't got a clue what mutate means. It's not a command as it stands. But what I'm going to do is library tidyverse and run that as a command. So again, I can either highlight it all, or I can press Control and Enter at the end of it. And what it should do, hopefully, is come up with these. So these are all the different packages which are part of the tidyverse set of packages. So there's dplyr, which is all around data manipulation, which is what we're going to be using a lot of today. readr, which is about reading in CSVs, etc., which is what we're going to be using as a first thing. For cats, obviously that's a package for cats. Now that's around a data type which is God, what's it called? Oh God, my brain's gone back. I'll come back to that. stringr is all about using data manipulation in strings. So if you want to calculate, I think again in the intermediate one we do some stuff where we have, Bristol University NHS Hospital Trust or something. So if we wanted to do some string manipulation and remove where it says NHS Hospital or something to shorten the name, we can do that. ggplot is what we'll be using probably possibly later on today or tomorrow around doing plots. Tibble is something that is sort of under the hood around how we have our data frames. Lubridate is all around date manipulation. Dates in R are a little bit alien if you haven't used them before. Dates in any language that isn't SQL or Excel is quite challenging. Excel and SQL use dates in really, really, really weird ways that nobody else in any programming languages use them in that way. Unfortunately, most people are learn and taught and conditioned in Excel ways of using dates. So yeah, dates do get a bit messy to learn. tidyr is a bunch of stuff around sort of helping you to again manipulate sort of types of data, and per is obviously goes with the cats. Now that's around sort of doing loops and sort of more programmatic sort of recursion and sort of stuff, which we not really going to touch on. That's much more advanced stuff. So now once I've run that and I press mutate, oh, that's interesting. Rather than saying I don't know what this means, it now recognizes that it is a command, but obviously I need some further bits for that command. So anyway, so let's just get rid of that. So now hopefully you should have this. Has anybody not got this sort of attaching call products and conflicts stuff come up? Just to talk about what conflicts means. So what you can do, sorry, Diane, is there a problem?
Yeah, I'm not getting to that. I've just got the error object mutate not found.
Okay, so have you run this bit that says library tidyverse?
Yeah, I've just done a screenshot. What I put in, I can't see that I've done any different.
So you installed the package and it did all that churny stuff?
Yeah, just bear with me a second. I'll just screenshot
No problem.
what I've written, and I'm still getting just the error object mutate not found.
I mean, it should still come up with an error because I'm just like using a command out of the blue. Let's have a look. So that's all right. So the mutate shouldn't work on its own. It's just the important bit is, did this bit come up where it said attaching core packages?
No.
Sorry, no.
No, it didn't.
No. Let's just see. So if you just run filter like that, does it come up with, if you just type in filter, does it come up with this, or does it just say not object not recognized? Oh no, filter's not. No, try mutate again. So when you run mutate, does it come up with that, or does it say object not recognized?
So when I type in mutate, it's not bringing up those commands there at all.
It's not coming up with that.
No.
That's interesting. But and you've definitely run library tidyverse.
Yeah.
Let's have a look again. That makes no sense. And you definitely installed it. Assume everybody else is coming is okay. You did the install tidyverse.
Yeah, I've done that. And when I typed in library,
can you share your screen?
It. Yeah, of course.
Let's have a look.
Saying that, my share button's greyed out.
Oh. Is it? I'm unable to run tidyverse. Actually, do you know if we're able to get other people to share their screens?
I'm just trying to have a look. 1 second.
No worries. So some people have got it okay, and some people haven't. So let's just do it this way.
Do I need to just press run here?
No. So if you highlight line 2.
Okay, yeah.
And then run.
Run.
There we go. That's
brilliant.
It.
Thank you.
So
okay, thanks.
Yeah, so you have to select the script and then run it, or Control A and run it all. There is a shortcut for run all script, but I can't remember what it is. So now if you do that mutate, it should come up with that other gibberish rather than not found. There we go. Excellent.
Thank you.
So get rid of where it says mutate now. We don't need that. Okay, we're at 10 past, so hopefully everybody's here again. So what we're going to do now, obviously we can't do much unless we've got some data, so we are going to import some data. And there's loads of different ways we can import data into RStudio, and RStudio comes with a bunch of wizards, which also helps. You know, who doesn't love a wizard? But the first thing we're going to do is import some CSV into our data, and we're going to use the wizard not to import the data, but to get RStudio to write some script for us so we don't have to. And then that makes things easier. We can potentially link up RStudio directly to sort of SQL servers and warehouses. We can link RStudio up to sort of data bricks, and sort of it can deal with Parquet files. We can tell tell RStudio to pull data out of the web. We can do web scraping and sort of do that kind of stuff. And R will pretty much take any bizarre data format that you can think of. So if you've got like XML files or JSON files or Excel files, it can read and do all of those sort of things. So it's really good at, it's got loads of packages which you can read all manner of types of stuff. So if we look on our RStudio, in the bottom right hand side, or no, not the bottom right side, top right hand side, we have a button there that says import dataset. And like I say, we are just going to use the wizard to write some script for us and not use it as a thing, because we want to make it reproducible. And what we want to use is from text, and we're going to use the read R package. As you can see, even just the defaults there, we've got some options for Excel, we've got some stuff for SPSS, we've got some SAS stuff and Strata, but we're going to use read R. Preparing the data imports requires an update of the RCPP package. You should install this now. Yes, we do. It will only do this for the first time, just where we get through, and it will come up then with a little option bit there. So hopefully everybody got that. So now if I say I want to do that again, import dataset from read R, it will just come straight up with that. Everybody got a sort of navigation bar? Import text data. At this point, shout if you haven't. And what we're going to browse to is a file called capacity AE. So if we do browse, hopefully earlier when we set up our environment, we pulled in some data. So if we look at capacity AE, and then we can press open. And it will give us a quick look at the data. Everybody got that? So this is quite a simple data set, which we will be playing with, I think, more tomorrow when we do some plotting, but it will show us sort of various bits. So what we've got in our data set is we can see that we've got a site number, we've got an attendance number, we've got this staff increase, which seems to be a true or a false. We've got this D cubicles column, which has got a number, and we've got this D weight column, which is a number. What's also really interesting, is very useful to have a look at, is this little bit in brackets underneath our data. So this is our data type, and R will do its best to match the data type to the data that you are pulling through. And I'm sure if you've used SQL, data types is quite common. If you've used Excel, it's probably less common, but I guess Excel, the probably easiest way to explain it is sometimes you have, obviously you put a date in, and Excel will recognize that is a date column and deal with it as a date. Sometimes you'll have, obviously most of the times you have numeric in there, and it will calculate things as numeric. Sometimes you have a bit of a mix of a column, or some things go wrong, or sometimes you want to use strings and have it as text in a column, and sometimes you can have that sort of like weird mix where a column in R can only have one format, and so therefore it will go to the one which encompasses most of the data, and it tries to go for the simplest type of data type for that data. So for instance, logical is just true or false. So that's a really, really simple data type. So it can either be true or it can be false. It will not accept anything else. So that's a logical or a Boolean for those. A double would just be like it's an integer or a numeric number. We have strings where we haven't got any strings in this one, and we have sort of dates, etc. And those become sort of more complex data types. But for this instance, we can see, what are our data types and what are our data. And you can also see down here, we've got this little code preview. So basically, what if we want to pull in this data, it's written this code for us. So if we don't do it, but if we press the import, all R is going to run that script for us in the background. However, we want to make this so it's reproducible. So what we can do is highlight that script and copy it in whatever copy where you like to do, and then cancel that. And then where are we? Import data, and then we can paste it in here. And then it's ready. So next time that we wish to sort of run our analysis, it will call in the library that we need. It will read in the data, and if we also do that, it will also run it for us and run a view, or run the view command on it. And if we run the view command, or we run that, will it throw an error if one of the cells has a null value? No, it won't. And we will deal with those a lot more in our intermediate course about how we do that. So no, it will accept nulls and NAs. And we also have a lovely thing called a NaN, which is when it's called not a number. So sometimes if you tell R that this is a numeric column and somebody accidentally has put some text in there, it will convert that text into a NaN, which is not a number, which basically tells you there is some data in there, but it's not a number, so therefore R can't compute it. So you probably want to go back to your source data and actually have a look what it is. But yeah, we do have NAs and we also have nulls, and R does treat those slightly differently, and again, it's kind of getting to the nuance of that. So hopefully everybody's got a view of the data up there. It's popped it into this little script here, and it's got some. It's put it into another tab, and we've got some nice little features that we can do on there. We can click on this button here, which allows us to show it in a new window, which pops just the data set into a new window. We can click on our headings, which allows us to do simple sorting of our data into sort of order, or we can also click on the filter buttons, and we can what can we do? We can filter our data, etc., and also show us little histograms, and if we just want to look at the true, etc. So it does things like that. All that is doing is adjusting the view, that specific view of the data. It's not changing the data in any way. All we're taking is a view of the data, and we can do that. And then we can sort of close that tab after, so that view AE pulls up the data into another little tab, and we can close that tab. And it's there. You'll also notice up in the right hand side here in our global environment, this is called, we now have a new object which is called capacity AE, and that's basically the name of our data frame or our data sheet. So, you know, that's our, in Excel terms, that's just our single sheet of data. If we wanted to do multiple sheets, we would have multiple objects in there. We can also create variables and bits and pieces, and they can go in there. And what we can see here is that we have 68 observations of 5 variables. So 5 variables are our 5 columns, and our 68 observations are our 68 rows of data. It does allow us to do some other little things. So there's a little arrow here next to our capacity AE. We can have a look at that. And that again tells us a little bit more about our data. So it tells us obviously what our column names are, and it tells us what our data types are. So we can see we've got our numerics and we've got our logical. And it also just gives us a sort of the top head of the data. And there's some other bits here as well, just to sort of give the attributes of our data set. But yeah, that's quite useful. And again, if you're just trying to remember what column names are and things like that, that's comes in very handy, which is good. So that's that one. So that's nice and easy, pulling in some data. Let's go to a more real world example of pulling some messy data. So so we've got a CSV that needs some tidying. So we are going to explore mental health inpatient capacity. So this is taken from, I think it's from real data, which is just being muddled about a little bit from some data. And yeah, we're looking at some data, and I think it all comes from sort of KHO3 returns, and then yeah, it's been partially cleaned. Accessible spreadsheet. So this is a great opportunity to say that the government has data standards around how to make spreadsheets accessible, and judging by many of the spreadsheets I've seen over my years, I'm not sure everybody's aware of that. So what we want to do is load in the beds data CSV and do an import of that. So similar sort of process as we did before. So if we click on import datasets and then from text read R, and then we browse, and we've got this one now called beds data, and open. And let's see who can spot some issues with it right from the start. So hopefully that's come up. So I'll just run through that bit again. We're going to use the import dataset function again because it's nice. From text read R, we're going to browse, and we're going to go to beds data and open. So starter for 10, what have we got going on here? Our lovely friends at NHS England have decided to put some metadata right at the top of the chart of their spreadsheet or their CSV, and then we can see here that actually this line here is the actual name of our that should be the correct column that we want, the correct row that we want for our column names. So they've given us this gibberish stuff here, which is not very helpful, if that makes sense. So what we want to do is actually, when we load in our data, we want to load it in, we want to ignore these 3 rows. So that's quite nice and easy. If you look down here, we've got an option here for skip. So obviously this is a very, very common thing that happens a lot. And what we can do is change that to a free and press enter. And what it's done now is a couple of clever things. Is A, it's skipped reading those first 3 rows, but it's also added that to our script over here so that we actually have, so when we copy our code and we write this into our script, we don't have to manually click on all of these things and do it again and again. It's all going to be just within our code, and when we run our code, it's just going to do it for us, which is great. So has everybody managed to get skip free? So you do have to change it, and it won't actually take effect until you click or do something outside of the so if you just change it, it won't do anything. You have to either press return or click outside for it to update. Everybody skip the first 3 rows? Yep, all good. Excellent. As I said, please shout if there's a problem. Otherwise, I will just soldier on. So that's great. Can anybody else see any issues with our data? Date column is a character. Well done, Dan. 5 points to your team. So ours just looked at it, and it's kind of put it as a character. So we want to change that. So if you click on the little drop down next to character, it will give us some options. Just to say down the bottom here, there are some really nice ones. So if you want to load in a data set, but there's some columns that you want to skip and not read in, you can just tell it to skip that column. However, that's not what we want to do here. Actually, we want to tell R that actually this is a date. And I'm sure, I don't know if you have seen, there is a bit of a joke about the Excel where it tries to treat everything as a date. So if you put in like 1-3 into Excel, it will treat that as the 1st of March, and it will treat everything as a date. R does the complete opposite. Nothing is a date unless you tell it to, unless it really, really recognizes it, unless it's in ISO 20 whatever it is format, it's not going to recognize it as a date. If it's in the proper ISO format, it will recognize it as a date, but generally it won't. So we need to tell it that it is a date. and we need to tell it what format our date is in, that this is, because again, it can't read it as a date, so it doesn't know which one is the month and which one is the year. It again assumes sort of American format. However, we're not in American format, we're in English format. So we're saying this is a date and this is the date format it's in. So this is the default it will come up with, but we want to swap the M and the D around. So we want to say, actually, that's the D and that's the M, if that makes sense. So we're telling R that this is the date, and we know that the first bit is the date, day, the second column, the second bit is the month, and the last bit is the year. There are some really amazing packages who have absolutely tackled the date format issue and can read a date out of anything. I'm sure you've all had it where you've sent out an Excel sheet to somebody, so everybody just put the date in there and then your data, and you come back and it's in 25 different formats. Somebody's put like 5-3, and the next person's put 5-3, and the next person's put 5 March, and the next person's put 5th of May and the year of our Lord 1782, and it's come back with all the different date formats you could possibly imagine. There are some really nice packages which deal with that. So yes, is it better practice to set dates during import? Yeah, definitely. I mean, it's better to obviously have them in proper ISO format in your actual main data set, but I would do it during import if you can. However, we can also do it as a separate state if needs be. So I personally think it's best to do it at source, because it just does it as it reads it in, and it just saves a step. However, you can do it as, you know, if you accidentally didn't do this and then you recognize halfway down your script, you can convert it at a later date. Anyway, so please enter the format string, and then press OK. And again, that will preview. And now you can see that if you've done it correctly, it has come through as a date, and it should say September and not the 9th of January. So if you didn't swap those M's and D's rounds, it's going to come through as the 9th of January, but we're not. It's put it into nice ISO format now, and we have actually got our date as a date. We can confirm that again if we if we click on where it says date. I know it's not going to do that on this bit, is it? That's fine. So yes, we can see that that is a date. Were there any other bits that's messy? Nope. So we're cool with that. So let's just copy our code and then cancel, and then paste that in here. And now we have another data object called beds data, and we can see we've got these things again. We can do if we wanted to, we can just click on the date and we can make sure that that is in the right order. Or if we did, yeah, we can see that's all in the right order. And now we've got, obviously we've got the right column names for our data and all our data types. Everybody got that?
No, I've got a bit lost.
Okay, where did you get lost?
I was copying the script, but I didn't have the window to copy it into. I've lost the untitled one, I think.
Have you closed it? Has it disappeared? You can do green arrow and new file, so green plus and new file, and that will create a new R script. And then if I copy that into the chat, that should give you where we are now. You must have closed it by mistake. So when you do this view, it creates a new tab here, and you can close the tab because it's just a view of the data. What you must have done is accidentally also clicked on the script.
So I've got your content, intro, our data. So that's all I've got.
So if you click, I'm just trying to understand what you mean. So have you got new file? So have you got this screen up at all, or?
Oh yeah, yeah. Sorry,
Yeah.
I've gone back to that. Yeah. So yeah, so I've got the green plus now and all that stuff.
Okay. So yeah, if you do the green plus, that should open up a script window for you. And I've just pasted all the code in of where we're up to in the chat.
So I'll select R script, do I?
Yeah.
Green.
Yeah.
Right,
green and R script, top one.
Okay, and all the stuff's in the chat.
And it's all in the chat. You should just be able to copy and paste that. That should get us there. Okay.
Yeah, I probably did shut it down accidentally, actually.
That's fine. That's fine. So now we are going to go into some dplyr and do some data wrangling, which is with any project, anything you're doing is going to be the hardest and the most annoying and frustration bit before you get to do some nice things with your data. So let's going to just explain what wrangling is. So that's reshaping or transforming of your data into a format that's easier to work with. And yeah, as I said, it's usually the biggest part of anything. We're going to be using tidy data, which broadly means that each variable is in its own column and each observation forms a row. And that's what we mean by tidy data. And if that makes sense to you, it means that we usually have long data tables rather than wide data tables, which hopefully will make some sense to you. And that's broadly how that works. We're going to use dplyr, which is part of the tidyverse thing. So we don't have to call it in separately. We've loaded in our tidyverse, and one of those packages is dplyr. And basically, we're going to use, much like you do in SQL, etc., we're going to use a few dplyr verbs or functions in order to do some really clever stuff by the end of this session. Many of these concepts are very, very similar in Excel, in Excel and in SQL. And I say we're just going to be covering some of the real basic sort of dplyr stuff, but those will allow you to do so much. So we are going to do some really key verbs, which is our arrange, our filter, our mutate, and summarize. And yeah, if you wish to be American, you can write it summarize as well with a Z or a Z. It doesn't matter, but obviously we're English here. We're going to write summarize with an S. So building with steps, and this is the real power of dplyr and how R builds up its data flows, is that the verbs aren't used independently, and each can be sort of a step in a code or our recipe, and then can also be repeated as well, which is really important. So for those people who are coming from a SQL background, it will blow your mind that you don't have to have an order of operations, or you don't have to do all that. We will do some group bys and various bits and pieces, and you don't have to do all that repetition, and you can reuse a function within your workflow and do something again, which you're not limited to just one where clause which has to cover everything. You can filter your data with where clause, do some stuff with it, and then use another filter at a later point, which, believe me, when it comes to not having to write crazy amounts of CTEs and subqueries, it will blow your mind. For those more Excel-y people, what I said sounds really complicated. Really not. Let's look at the mashed potato. So we're going to start with our potato, then we're going to peel it, then we're going to slice it into medium pieces, then we're going to boil it, and then we're going to mash it. And voila, we have lovely mashed potato. So in coding terms, we take our potato, which is our object or our data frame, then we apply a function to it, which will be our peel. Then we're going to slice into it, and we can determine what size slices we're going to do. Then we're going to boil it, and we can obviously give it time to boil, and then we're going to apply a mash function to it. And what's probably quite interesting is we're using this little weird symbol here to use then. And that's really powerful piece of R, is this thing called a pipe operator, which is our then. And it's very alien to start with, but will make sense. So if you look down on your keyboard on your bottom left next to your Z with the backslash, so if you do shift and that button, it will give you a line, and then it's the greater than. So if I just pop onto my Where are we? We're over here somewhere. We're into here. So pipe operator. I can't spell. It's close enough. Is so shift that and then that. There's a shortcut for it, but I can't remember what it is off the top of my head, and it's probably longer than is it code? Is now. Because I never use it, I always write it longhand. But yeah, it's that little button, like I say, the next to your Z, and then the greater than sign. And we're going to be using that a lot. And in your head, when you see that, just think of the word then. And that's basically what it means. It means do this, then do that, then do that, then do that, then do that. Cool. So where are we? So that's our recipe. Oh, look at that. Can't remember what the shortcut is. And there it is. I'll tell you one next thing. So yeah, alternatively, you can press Control-Shift-M. If you look at some older code, you might see this symbol as well, which is for all intents and purposes is exactly the same. And it came from another package, but this new pipe operator is just part of base R now, so it's not attached to a package. But yeah, if you look at old code, you might see this, and it's kind of interchangeable. All the cool kids are using the modern style pipe operator, which I just showed you, which looks prettier and definitely looks less scary in your code, which is good. So we're going to do some data wrangling, and just use some basic commands now to get some data and answers out of our data. So question 1, which organization provided the highest number of mental health beds? So let's have a look at our data again. If you remember, we've got our beds data here. So if I just run beds data, we've got this here. And we want to write some script to pull out the highest, or just reorder our data so that it's in a new order. So what we're going to do is, and I'm happy to share my script at the end of it as well, just because obviously I can do very, very quick things like that. We're going to use the arrange. So we're going to start with our beds data. And again, when you start writing stuff, I was very, very clever at looking in the environment and seeing what's there. So as soon as I write bed, it starts realizing, do you mean beds data? And it's even clever. It's obviously come up with that. And it's also given me a little bit of a preview around which one that is. Potentially, I could have 2 data sets there, one called bed data and one called, I don't know, bed monkey or something, and it would then give me the 2 options, and I could click between them. Once it's done that blue highlight there, if I just want to select that, I can just press tab and it will auto complete for me, which means once you get kind of used to how it works, you can write code really, really quickly. And it also means that you are not, my spelling is atrocious. If we get to the bits later when we write the word, I cannot write the word select to save my life. I don't know why. It's just a weird mental block between my head and my paws. So I don't know why, but it doesn't work for me. So it's really, really good at picking out commands for you and sort of finding those data sets for you and doing all those bits for you. So we're going to take our beds data, and then we're going to do a then. And what's good practice is to press return when you do a then, so it puts it onto a new line. And what RStudio will do is indent it slightly, just so you can see that we're doing this beds data, and everything that relates to this beds data is slightly indented. If you've used Python before, Python's really, really, really picky about indentations. R isn't. It will work without indentations. This is just a style thing to make it look nice. And what we want to do is we want to arrange, and again, as I go through, it's going to go through and find all the different commands for me which look like arrange. Arrange seems to be the most popular or the most common, so I can press tab. It will then open up the brackets for me and get that set up for me, which is nice. and I want to have a look at my beds average, which if we look up here again, that's one of my columns which we're looking at. And again, when I start typing, R looks within that beds data and tries to see which variable I'm looking at. So it knows we've got beds, so it's probably that beds average. So again, I can press tab if I want to, and it will auto complete that. And like I said, once you get to know how that works, it means you're not making mistakes around your sort of variable names, etc., or your column names. But it also becomes really, really quick to write your code. So if I run that, let me just scroll that up a little bit and scroll that one down, and I'll just make that a little bit wider. Sorry, I should have showed you can do that. Yeah, you can click on the little bits here and get the little arrows and shift these around a little bit. What it will do is give me the rearranged order of the beds average, which is great. However, that doesn't answer my question, because I have obviously that puts it in lowest to highest. What I want to do is in descending order. Arrange, but in descending order. So what I can do is copy this again, and I want to tell it to do it in descending order, so I can add another function to my data. So I can add descending and put that in there. I just remember it's not showing up in different colors on for me. Let's do that one. Maybe it's this screen. So this is where it all gets a little bit messy around multiple sets of brackets. But now within my descending, with my arrange, I'm adding another function, which is my descending, and then doing my descending bracket area. And now that will put that through in descending order. And now I can see which is my highest. I can as well. And again, this is where it gets in a little bit more pragmatically ways of doing things. And I can say, actually, I want to arrange this based on the minus of the beds average. And if I run that one, that will also come up with that same answer. So basically, we're just taking that beds data and then we're arranging it based on the beds average. So everybody got that? Yep.
Oh, hi. I'm getting beds data not found, error in view.
Have you loaded in this beds data? So have you got it up in here in your environment? Does it say beds data? If not, run that script that loads in the bed data, which I will pop in the chat there. So did you have an object appear here in the beds data? If not, then it's probably that you've spelt beds data wrong. And again, this is where it gets into, have you got an underscore? Have you got a space? Have you done it with a capital B? This is where R gets very, very case sensitive and annoying on those sort of things. Is that working now?
Yeah, thank you.
What was the problem?
Oh, I don't think, yeah, for some reason I haven't got the beds data in, yeah, because remember I closed that window and yeah, so yeah, I think we're on the right track now.
Yeah, no problem. Okay, so so that descending does work for text and also sort of numeric variables, and it will work for dates as well if we wanted to order things by dates, etc. Ordering things by dates does get a little bit messier, but yeah, it will work for that. And again, really, really important to make sure that we've got things in date format in order to arrange things in dates, because obviously if we didn't have it in a date format, it would convert that. It will think, it will try to order your dates sort of alphabetically, because it will come through as a string, that was the default. And then, yeah, it gets really messy when you try to, alphabetically do the dates. It will, and I'm sure people have seen that happen before. So let's have a look at some other bits. So which two organisations provided the highest number of mental health beds in 2018? So let's build on what we've got here. Let me just copy that, because this is my next question, is which two organisations provided the highest number of mental health beds in September 18? So we already know how to do the highest, which is great, but this time we only want observations for September 18. So we're going to do an order, and what we're also going to do is a filter. So this is, let's do this. So let's copy what we've already got, because, let's not start, arrange things as it were. So we can arrange our data, and then we want to filter it. So we've got our data, we've arranged it, and then, so we add in another pipe operator, and we do an arrange, and then we want to do a filter. So again, R will recognize that we've got a filter, and we want to do an open bracket. So every time we give R a command or a function, the variables or the gubbins that goes with that command always sit within brackets. So everything that we do sits within brackets. So even if you look at all the code we've written already, every time we've come up with a command, the stuff goes in the brackets. And so we want to filter it where our date is equal to 2018-09-01. Okay, so this is where you become programmers, because you'll notice what I've done is a double equals, which is interesting. So let's just check if this works to start with. Which is cool. So we can see that our data has been filtered down to 2018, and hopefully we see East London and Nottingham Healthcare as the highest. So let me explain this double equals. So the double equals means it's a test of equality. So we are testing that this equals that. So is it equals to? So when we say double equals, it means is equals to. Sometimes we use equals in a different way, in that sometimes if you set up variables and things, or we set up features within, I don't know if we've done any up here yet. Oh yeah, there we go. We have here. So here we use skip equals 3. So we're feeding the number 3 to our skip function. So we want to skip, and we want to skip 3 rows, so our skips equals 3. So we're not doing a test of equality. We're not testing whether skip is equal to 3. We're just saying that skip is 3. So single equals means is. So format is this. Date is this. Column types, yeah. So skip is 3. And when we use double equals means is, and then the second equals means equals to. So we're saying date is equal to 3. Is equal to September 2018. Does that make sense? What's really nice is if you get it wrong, and believe me, you will get this wrong, and we run it, what we have is one of those really useful error messages where it says we've detected a named invert. This usually means you've used a single equals rather than double equals. Did you mean date equals? And it also tells me how to correct it. So believe me, you will see this so many times, and it's like, yeah, that is exactly what I meant to do. Thanks for telling me. So it's one of those really, really actually useful error messages, which, we love those, especially when it tells you you've made an error and this is how you fix it. So that's really cool. So now what we've done is we've filtered our data, arranged our data and filtered it. Potentially, and again, this is where our little, if we did it the other way around. So if we, that's really messy. If we filtered our data and then arranged it, what's going to happen? is the sky going to fall down, or is it going to come up with exactly the same answer? Because it doesn't matter. It's going to come up with exactly the same answer because it doesn't matter. It's not SQL, and you don't have to do it all in that specific order. So that's really cool, which is really nice. And potentially, again, when I'm talking about being able to reduce, so this is our data here. If we then wanted to filter it to, I don't know, our beds average, whoops, is greater than 700, and we can run that. It will do that. So again, you are not limited in a workflow of you can only use the one command once. And again, I'm looking at uSQL, where doing that kind of stuff really gets really messy. May. I saw her hand.
Sorry, I'm muted. Sorry. The filter date, I've noticed a very specific date. What happens if I want to filter all of the September data in my data set? So not only for the 1st of September, the whole.
Yeah, I mean, in this instance, in our beds data, we've only got everything's calculated to the 1st anyway. So if you wanted to do a range, so you could do again, like in Excel, in SQL, you could do a between. You could say, I want my date to be greater than equals. I'll just remember what the dates are on this. What's going to make sense? And you can do an and dates less than equals 2019, 09, 01. Does that make sense? So you can give it sort of multiple things.
Fantastic.
So you can do ands. That doesn't make sense for this one because I've got the wrong dates. But yeah, you can do ands. You can again use our lovely little line thing to use an or you can type in or you can type in and as well. Just ampersand is generally how I do it. So you can do that. There are filters. You can do. I'd say I'm not gonna. So let's just gonna show off. So you can do things like I want my date to be the maximum of the date. So I'm always just going to bring back the latest data. So for instance, so if we do that, it just happens to be in this instance, it is September still. But you can then write really sort of dynamic code. So this code, if I refreshed the data and we had October data in there, it would automatically filter it to the maximum date. So things like that are, becomes really powerful when you start building these workflows up together. But we're getting massively ahead of ourselves, and we need to go back to some T-plan.
Fantastic. Thanks, Simon. Thank you.
No worries. Do shout out, and then I can go off on random little tangents, and then you can come back to them, which is cool. And like I say, I will share this code, so don't feel like you then have to quickly scrabble that down. And I will go through that. So what we can also do is if we go back to this version, as you can see, our actual exam question, if we go back to it, is which two organisations provided the highest number of beds? So how we've been doing it at the moment has just all we've done is reordered and filtered. If we wanted to absolutely nail that exam question, we can do something like slice head, which sounds really scary, and slice head n equals 2, and hopefully you can work out what that means. It's just going to take our data, it's going to slice it from the head, so from the top, and it's just going to return the top 2 results. So if we run that one, we now have nailed our exam question, and we have actually got, there you go, that's our absolute top 2 results that we've come through. So just to, obviously we've been running code. What we haven't done at any point is changed our beds data all we are doing is creating a little view of it here when we do run this data, and it's appearing within our console. So we're not adjusting the data at all. I will show you later how we can build that into an actual object. It could be its own thing. So if we wanted this to be its own little data set, and up here in our environment, we will do that, because quite a lot of people ask that at this stage, but we will cover that in a minute. So, oh, look at this. We've got another exam question now, and it's going to get more and more complicated. So, which organisations had the highest percentage bed occupancy in September 18? Okay, so let's have a look at what we've got, or what bits we can do easily is probably easiest. So as before, we can use a range to find the highest, so that's quite easy. We can use the filter to restrict it to September 18. We've got that, we've nailed it, we know how to do filters, we've even done some advanced filtering, but we're still going to get it down to September 18, so that's easy. But we don't have the percentage in our data. So, so we've got our occupancy and we've got our beds average, but we haven't got that as a percentage. So what we want to do is mutate our data and create a new variable. And our new variable will be our average occupancy divided by our beds occupancy, which will give us, which will then give us, times by 100 to give us a percentage. So nice. So I always start with what we've got already. So let's get rid of that. We're not going to slice our head off. So some of this is right and some of this is wrong. So our range is not right, because what we want to do is find our find our percentage. So at the moment we've got our filter and we're happy with that. We can do that. That's easy. So that one's in the bag. So now we're going to create our new variable. So we are going to do something called a mutate. So it sounds much more exciting than it is. All it is doing is mutating your data frame and adding in a new variable to it. So we're going to mutate, and we're going to give it, we're going to call it a new variable. So we're going to go perk occ, and we need to tell R what perk occ is, and our perk occ is very simply going to be our average occupancy divided by our beds average. Does that make sense? So, and then we want to, clicked off there. Then we want to do our arrange, because we want to work it into our highest. And we want to do it descending again. But this is where it gets really, really clever. So we want to, in our same pipeline, is arrange it on our percentage occupancy. So we've created a new variable here. And within our pipeline, that new variable is already available for us to use in our next command, which for SQL users, that's pretty mind-blowing around how that works, because normally you'd have to create something within your table, and then if you want to query that new column or whatever, you'd have to do it in the next, you'd have to do it in either in a subquery or as a part of a sort of longer workflow. But now, as soon as we've created this mutate, we can run the whole lot. Ooh, and what have I got? Oh, Simon can't spell. There we go. Occ-av. So as we go, error. So as I said, every single mistake is a learning message. So object occ.ac not underscore ac not found. And as I said, that is true because there isn't a variable called that. So it is occ-av. Let's see if that one works now. Fantastic. So now we can see we've got this new column called perk occ, and we've arranged it by that perk occ. Does that make sense? Everybody got that? And okay. So I think that's, to me, that bit where we can already create a new variable and then use it in our next bit of our workflow was a bit of a aha moment for me, because that's really clever. Okay, so everybody happy with that? Anybody not happy with that? Because we're on question 3. Question 5 you get to do on your own, so you know, just if you're not happy, do shout. Okay, so that's cool. So just to say, and just to confirm again, here we're using a double equals because we're saying date is equal to. Here we're using a single equals because we're just using is. Do we assume NA is not an issue here? Yeah, we're just going to ignore those, because if we did it, I'm assuming if we did it in ascending order, we're gonna, oh, I thought we'd have a load of is everything filled in here? I just don't remember. So where we've got that divided by that, yeah. If one of them was an NA, it would come through. I think they both come through as NAs, so I think it just comes through as zeros, I think, or whatever. Sorry, I had to match up. Are there any slides for me to catch up? Yeah, I'll pop them. We're going to have a break in a minute. Let me just see if I can find them. You can. Where are we? If you go here, and what we're doing is that says link to that, and what we're doing is this one here, data wrangling, selection of main functions. So yeah, if you want to do a bit of catch up, we'll take a break in a minute anyway. So hopefully that'll give you an opportunity. So let's put that back how it was. So has everybody got that? Sorry, Andrew.
No, I've got object occav not found.
Okay, how have
Maybe
you
I've got
spelt it?
A typo error in my. I'm just trying to see where it's different, but
Or do you want to paste your code into the chat and we can have a look?
Yeah, I will do that.
Paste that little bit in there and see where we are.
Okay. I keep looking. I can't. Yeah.
Just paste your code in. Let's have a look. Let's all
Oh,
have a look
sorry. I didn't. Yeah.
Okay. So, aha. Yep, I can see it. So if you kind of read out loud your code, you've got beds data filter that, and then you're missing the pipe operator for your
pipe
next.
Operator. Yeah, I just seen it. Yeah.
Yeah, that's fine.
Yeah.
And also, let's just see. Yeah, so R does get a little bit messy, and it does get a little bit syntaxy about where you put stuff. So if you notice there, that I was quite happy with, no problem. However, if I put my then on a different line, R will evaluate to the end of this line and assume that's the end of your code, because there's nothing telling it needs to look at the next line and evaluate the next line as well. So when I run that one, it's going to tell me, oh, what's this doing here? Well, it's nothing to do with anything. It's out floating on its own. So you always leave that on the end, as it were, to go to the next line. And again, at the end of the next session, we'll do some stuff about how you can do some automatic styling of your code, which tidy code is much easier to read, and there's some automatic add-ins that we can add in that sort of help make it pretty. So okay, let's have a look at our next question. So question 4. Oh, look at this. What is the mean number of beds for the data set? So let's have a look first about how we produce those sort of summary statistics. So obviously what we've done so far is just added a sort of column onto our data set. And I guess the easiest way to explain this is thinking about sometimes you're adding stuff onto your data set and sometimes you're putting stuff like into a pivot table when you're creating that sort of summary statistics. So how do we get this and then create it into a summary? And then we can also see how we can then apply those summary statistics to groups. So for instance, we might just want the mean number of beds for the entire data set. We might want to know the mean number of beds per date or by each of the organizations. So that's when we start doing those sort of like grouping functions. So we will look at that. So simple terms, let's take our beds data. And then we're going to use our summarize with an S. And we're going to create a new column or a new variable within our data set, which we're going to call mean beds. And that is going to be the mean of our beds average or whatever it is. Yeah. And hopefully you will run that and it comes up with a spurious result. If anybody gets that to work, then they've done something wrong. So what's going wrong there then? Any clues? I think somebody touched on it earlier. Sorry, some random little eyes have just popped up. Nice. So anybody can have a think about what the problem is. Yeah, it is Dan. So
Empty
Dan,
data?
you've been dying for those NAs to have a problem, and now they have caused the problem. So when you've got NAs in your data set and you're trying to calculate a mean over them, quite rightly, R doesn't know what to do because do you include those in the numerator or not? And yeah, that gets a little bit confusing. So by default, R will not be happy with it. So we need to tell R what to do with our NAs. So for our mean function. So we're going to add in another feature to our function here. So we separate different features of a function with a comma. And we can have functions that we'll use later where you can have multiple commas and you can do multiple things. If I give you an example here, if I run this one, we've got here, and we did here, yeah, we did up it. What I can do is add in another thing. So I could do org name equals Devon ship. And that will separate those two different filters. There we go. And that will do two things. So we're adding additional things into our filter function, and we're separating by column. In this instance, we've got another feature that we can add in. When everything goes, it's always the NAs. Yes, it is the NAs. So this time we're going to add in an na.rm equals true, which basically just stands for NA removes true. Yeah, we want to remove our NAs from our calculation. And then when we run it, it gives us an answer. So that's given us it properly now. So again, we've got to be crystal clear around what it is. What's really nice about R, and we'll go into it a little bit more in our functions, is that you can like click on a function and press F1, and it will bring up the help help text documentation for that function. And if we look at our mean, which is part of base R, so it's nothing clever, it tells us that it's got three different things. So it takes in X, which is usually our object, which is our our number. What we can do is also add in a trim feature if we wanted to. We could trim our mean, and that's part of our mean function. Or we can also add in this NA remove, which is a logical explaining whether it's true or false. So by default, these are the default features. So if you don't put in an NA remove, it does a false. By default, it doesn't trim it. But if you want to change it, you can explicitly tell our function to do that. So hopefully now we've got an answer by by the whole data set, which will be our 300. And then what we can do is what's really, really nice, and it's one of my absolute bugbears as a statistician, is if we didn't want to do mean and we wanted to do median, we can add that in there. So let's just copy our data. And okay, this does get a little bit messy about where we put our commas. So we want to put a comma in between those. And what we want to do is median. Where are we? Beds equals, guess what? We take that and we copy that and we change that from mean to median. And we run that. And it now gives us both of those summarizing factors. One of my biggest bugbears is SQL and especially Excel pivot tables do not allow you to do a median. And especially when we're working on things like lengths of stay, where we haven't got normally distributed, nice parametric data, explaining them by using a mean is statistically awful. We should definitely use a median. However, if you're stuck in Excel, means the only thing that you can do. So if that's the only tool you can do, that's what you have to do. I remember writing median functions. I think there is a median functions in some of the more recent SQLs, but I definitely remember like 10 years ago writing SQL functions in SQL where you have to like order your data and calculate it in your fingers and try to work out the middle things by that. So yeah, we can do that. We can also do, if we wanted to do a sum of, we want to find the total, we could add in a total beds equals, let's copy that again, and we could put a sum in there, and we can run those. And again, you can just add lots and lots of things. And you like to say you're not limited to one thing. Obviously, at the moment, we've done a summary statistic over the whole data set. What becomes more interesting then is how do we do it by a group? And I'm just trying to think actually, what we can also do is, we've done that. Yeah. So what we can also do is apply our summary to groups, and this is again where it starts getting much more powerful. So say we wanted to produce that same summary value, so we'll get our mean, our median, and our total beds, but for each date of our data set. So if we just have a quick remember of our data set, it's all broken up by different dates. So if we wanted to calculate our mean for each date, let's work out how to do that. So quite nice and simple. Let's just copy that again, because why write code when you can copy it? And again, we just want to add another feature into our summarize. But this time what we could do is a dot by. It's a bit annoying where it's called a dot by, but it will make sense for what we are doing. And we want to dot by is our date, which is our date column. So that is the name of our column. It's not knowing something special that it's a date. It just happens to be the name of our column. If it was period instead of date, we would say dot by period. And if we run that, we get now is those same calculations, but grouped by each of the different dates, which is really cool. If we wanted to if we wanted to do it by each of the organization codes instead of so we want to find the mean number of beds by the organization code rather than the date, we could do org code, and we could run that in there. I think that that comes out with gibberish. Why is that doing that? I think it's because we have some missing values, which is we yeah, it doesn't like it. We've only got a beds average where we've got those missing. It's not going to like it. Sometimes it's divided things by that are not numbers, so which is why we've got this nans coming up, which is not a number. So either it comes through something weird. It can come through. So that's things. If you've done like a divide by 0, it's going to come out with a nan, because you can't divide things by 0. That's an imaginary number, or I can't remember. It's not an imaginary number. It's just not a number. There's no such thing. It's like if you did like square root of -1, that would come out as a nan. If you do by group by first, it works. Is there a fundamental difference? So yeah, so just about to cover that for you old schoolers. So there is another way of doing this, which is have your group by outside of your summarize. So we can have our group by, and we can put it in here. So what were we doing? We're doing date, weren't we? Group by date. And that's our sort of more of a, if you look at sort of older code, that is a way that you can do it. And we can have it not within our summary, and we can have it there. So you can have your group by outside your date, and then everything that sort of follows comes through. So if I run that, that will do exactly the same, which is fine. There are some things, so this doesn't do anything to outline with the data, but that does do something different behind the scenes, which is really, really important to understand. So if you do it old school way, everything that you do from here on in, that data set will be grouped. So if I then try to do a mutate or something, that will be grouped. Or if I did a filter, the filter will not apply, it will apply to every group. And that gets quite complicated. So if I did this and then I wanted to, I don't know, filter it, just trying to think of an example. This probably isn't a good one, but if I wanted to filter it above a certain range, it would still work, but it would filter it on each and every group. Probably not, this data set probably not a good example for that, but it does mean that it can go wrong and it will do some weird, well, I wasn't away, I was here, don't go to sleep. It can do some weird things that you don't expect. So the good practice is if you do a group by outside of your summarize or mutate or filter, you can do that. So where are we? Come on, wiki. So if you do it outside, it's always good practice at the end of your group by is to ungroup and tell it to ungroup your data frame. I'll just show you, like, for the, you can use this dot by. So dot by automatically ungroups at the end of that command, which just makes things much, much nicer. So if I go back up here, just sort of show you what we can do is dot by equals org code. So what this is going to do is take our beds data, filter it to the maximum of the date, but for each organization code. So potentially this is just going to give us the latest submission by each org code. So you can use this grouping function with other functions. If we run that, so that's now brought us back the latest data for each site, because we've grouped it by the site and we've brought back the latest data for each site, which again, becomes really, really powerful to do that kind of stuff in just workflow. I mean, I don't know how you would do that in Excel. I'm just trying to think. Yeah, I guess you could put it into a pivot table and then pull that all through, but yeah, it would get messy. Anyway, right. Got a brain teaser for you now, which is the big question 5. So this is where we look back at all our code that we've just done, and we've got one to do on our own. So this is quite a doozy, and then we'll have a break afterwards because your brains are going to melt. So are we ready for the big question? So here we are, and it looks so simple, but it's not. I'll pop it on the screen over here as well. So which organizations have the highest mean percentage occupancy, bed occupancy. So we've done all the bits of this in various different bits. You just need to pull it all together. So over to you. I'm going to give you, I think it's like, ooh, there we go. There we go. Do you want the help? I'll leave it up on the screen like that. In about 2 minutes, I'll put the help up if you want that. Depends how pure. I'll also put the question in the chat if you want to copy it into your code, just so it's there, so you're not having to revert various other places. You've done all the bits. It's just pulling it all together. And it's just trying to work out, and you obviously do have to do some of this in a certain order for it to make sense. And do shout if you've got a problem. Put your hands up if you have an answer, just so I know where people are. Yeah. Did you even get set up with the initial data set and all of that, or have you not done any of that?
Yeah,
yet?
I have downloaded the zip file, so it's
Okay,
unpacked.
so you have got that much. Okay.
Yeah, thank you.
That's all the codes to date. I don't know which bit you're stuck on. Or you got
Yeah, I just need to load the library and the rest of it.
Right.
So yeah, that's perfect. Thank you.
So yeah, so hands up once you've got an answer. I'll put the helper up. An answer. Well done, Dan. Whether it's the right answer, we will come to see. So I can tell you the right answer, and then you can see whether you've done the right thing or not. So the right answer is Barnet. Your hand hasn't gone down, so hopefully that's a confident, correct answer. Believe me, this is the peak worst bit of the course where everybody goes horribly wrong and their brains fall out of their ears. Don't worry about it. This is definitely the hardest. Oh, it's just crashed. Great. So we're not even sure you have got the right answer. Oh my goodness. So hands up when you're there. We've done all these parts. It is a combination of we want to do a summarize, we want to do a mutate, and we want to do an arrange. Those are the things we want to do. As it says, we want to summarize by our, we want to do that by group. We want to create a mutate, probably on one of the things that we've just created. Taking issue with what they've come up with an answer. I've got any more hands? Anybody else got there? I suppose it sort of does. Okay. Mean might be a bit of a red herring in that question, actually. Okay. Put you out your misery. See how we get to, and see if, I don't know, let's have a bit of a chat about this, because I think they've changed the wording of the question, and I'm not sure it makes that much sense. So, beds data, that would be a good place to start. So, first thing we need to do is work out our bed occupancies by the total beds and the total occupancy, and to get our totals by organization. So total beds, and I apologize, I'm going to go back to the, we think that somebody's changed the question, because I'm sure that's not right. So beds average, beds av na.rm equals true. And what have I done? So I haven't done summarize beds there equals true, and then total true. Can't spell true either. Right. So that gives me the totals, and then I want to do that dot by equals org name. So that's my first bit, which will give me my total beds and my total occupancy. Then if I want to create my, a bit like we did previously, we want to create my average, sorry, percentage, perc occ equals, where are we? Total occupancy divided by total beds. Which will do that. And then if I arrange it by descending perc occ, that'll give us my highest, which gives me Barnet. I don't know why it says mean in there, because it's just the percentage. It is not the highest mean percentage. So if anybody's gone off on a tangent with means, I humbly apologise. But I'd be very interested if anybody's come up with anything weirder and differenter than that. If anybody's willing to share. If anybody did go down the mean route, what did you come up with? And did it work, at least in how you thought it would? Because I'm guessing alternative way you could do it would be, I mean, I guess if you change those to means, because that's what it looks like the question is asking. I'm assuming that comes up with something different though, doesn't it? I know, is that exactly the same? I suppose it would be, because it's still only one result, isn't it? I did mean, but it works itself out, yeah, because it's not including the month, is it? So yeah, that does work out. Yeah, I think the mean's a bit of a red herring. Did anybody else get horribly stuck or confused on that, or don't understand it now that I've shown it? Did anybody get nowhere near there?
I've got
Be brave, shout out. Andrew, go on then.
unexpected symbol in arrange desk
Okay.
perc occ.
Okay, an unexpected symbol. So is that, oh my goodness me. So could you paste your code in the chat again? Let's have a look at it. Again, thank you for making mistakes, because you know it's good learning experience for everybody. Let's have a look. And can anybody spot it? Oh, okay. So let's have a look. Bit up on my screen. Oh my lord. So we have got an extra summarize there. So when we press return there, that one doesn't need to be there. And we're all getting a bit brackety there. So that needs to be more like that one. And then, yeah. This is where it all gets really messy with our brackets. So we should have a bracket there. So again, that bracket links with that bracket because all of this stuff sits within this summarize here.
Okay.
And then this bracket is to do with this sum. So these brackets are together because they sit within the sum function. These brackets here sit within this sum function. And then, yeah, this sits within our summarize function. So that does that. In that there, perc occ equals sum occ divided by sum beds. Yep, that's right. And then arrange perc occ. So yeah, I think you got your summarized bit. So hopefully that. Oh, if we just get rid of that as well. I think that's you there, isn't it? Yeah.
Okay.
Perfect.
Thank you.
So I think you got the logic right. I think you just struggled a bit with brackets and stuff, which I'm sure you will not be the first nor the last to do so. So anybody else got any iffy code that they wish to share. Happy to sort of debug it, because again, it's how you learn. So anybody else struggle with that one? Okay, right, where are we at? We're at 11:35. Let's take a 10-minute break, because I appreciate that was a really horrible bit of a mind melter to try to do on your own when you haven't done these things before. So let's take a 10-minute break and come back at 11:45. That's all right. I'll be here for the next couple of minutes if anybody's got any questions before, yeah, if they need any catch up or any other problems. But otherwise, we're back at 11:45.
Thanks, Simon.
No worries. But Dan, just picking up on your question around processing hospital and patient data, yeah, it was going to be a problem because it's on the cloud. Yeah, it's a bit of a no-go, really. Yeah, not going to work. Not going to work. Because data does get processed externally. So yeah, if IT aren't happy you doing I don't know, installing packages, then that's going to be even worse if they say, yeah, if I can't install a package, can I share my data externally then? And I think they're going to be even less happy with that. Yeah, sorry. Like I said, those resources are really good, and you're definitely not going to be the first trust which has had that problem and those issues with their IT people. So hopefully you can shove that down your I've got to be careful what I say now. You can you can pass on those interesting and insightful tidbits to your IT people to hopefully unblock the blockers there. Cool. Right, let's get back to it. Where was we? So yeah, we did some data, we did some wrangling. Hopefully everybody sort of unpicked what we did there. Sorry about the awful question. I mean, it does say mean, but whether mean is correct or not, I think trying to understand that you can create those summaries and then you can do your mutates and then you can do arrange. I mean, that pipe operator is really, really powerful in workflows and allows you to do some really, really funky and complex things. I mean, I remember somebody was trying to get the data set and they were trying to work out what would be the equivalent in SQL to just run what we've just done there. And it's, yeah, quite bonkers, really. They think they had about 3 subqueries or CT type things in order to do that. So, yeah, it's really, really powerful what you have to do. And not having your group by independent and not having to sort of repeat yourselves, etc. Especially, I mean, we're not going to cover them today, etc. But if you're doing case statements in SQL and you have a group by and then you have to repeat your case statement in your group, oh man, so painful. Don't have to do any of that nonsense here. So yeah, we'll cover case statements and things like that in the intermediate course. But anyway, so what have we done? We've done some importing of some data. We've played with some messy data. We've done some main functions. But let's have a look at some more functions, because what's better than a function is more functions. So some more dplyr. So going to look at some other useful functions and examples of their capabilities and manipulating data. So really, really good one is the select function, which allows us to select certain columns of the data. So for instance, so we can do beds, data, then select, what have we got? Org code, and then org name. And again, I'm putting multiple things into my select statement, into my select function. So I'm going to separate them with a comma and press return. And that will go through. And as you can see now, when it's returned now, it's just brought back these 2 columns. Again, a bit around syntax. So if I run this one, good work. Oh, they fixed it. So, okay. Interesting. Right. Okay. Forget what I'm about to say. always good practice to leave R knowing that it needs to group, needs to carry on and do what it's doing on its next row. So a bit like where somebody had put their then on the next row, always leave sort of R hanging for your next bit and have this sort of comma outstanding, so that it knows to look onto the next row and sort of group that code up together. If I did something like this, and this quite often happens and it really confuses people, it's run, but if you notice down here, we've now got this plus sign. So I was waiting for an additional input. So it does, you know, there's no closing of a bracket here. So it's still waiting for something to come into this thing. And quite often when you get this plus sign, you kind of press return and it just does this, which is a bit of a weird thing. If you want to exit out of it, you can just press escape, and it will escape and leave you back to the normal sort of cursor. Or what you can do, which is obviously absolutely not the way to do it, you could write in org name and then close the bracket, and it would then complete that. It would complete that function. But yeah, if you see that plus sign appear there, it means you kind of haven't finished, or you've left R hanging for something to finish off this command. And yeah, it does get you quite confused first couple of times you see that. So yeah, that's what happens if you see that plus sign. So anyway, that allows us to select a couple of sites. We can also, sorry, let's just do this. Selecting a couple of columns. We can also do some other types of selects. So we can do beds, data, then select, and then do a minus org code. And that will select, that will basically deselect the org code. So it will give us all the columns apart from org code. So it will remove org code. Which is pretty cool. What we can do is use this select as well to reorganize our data. So if we, sorry, so I told you I can't spell select, didn't I? I called my own self out. I hate this section. Select everything apart from org code. Beds data, then select. So what we could do is we want the org name and then org code. So if we do that, beds data not found. There we go. Bed data, and it will reorder our data into the order of our selection. And what we could also do is say I would just want to put my organization first, and then I would just want everything else in the order that it's currently in. So we can use an everything function, and we can run that through there. So it's picked our organization first, and then it's done everything else, which is cool. And obviously what it hasn't done is included within that everything, it hasn't duplicated the org name, which is really, really cool, which is quite nice. Tidy select also comes with some other really nice little features that we can do. So what we could do is more dynamic type selections. So we can do a select, and we can do everything that starts with org. So I just want to select any of my columns that start with org, which, if you can see, we've got an org name and org code, and we've run those, and it just selects those two. There is an ends with as well, which does something similar. So again, when you're sort of setting up variables, you can do some cool stuff with that. And a really nice thing as well we can do is beds data, then select, and we can use contains. which basically does what it says on the tin. So we can give it a string that anything contains. So if we did s.a, if we look at our data, that should bring back our beds average because we're looking at that. Yeah, brought back our beds average. And likewise, I did say we could do starts with, let's pop it in there for reg. Ends with, I can't remember what it's called now. They're called av, isn't it? So I could pull back av, ends with av, and that should bring back those. Hopefully you get the picture there. So using select is really good without having to use lots of wildcards and things like that. You can use wildcards and reprex to, if anybody sort of does that, but I'm not going to go around that rabbit hole now. But yeah, if you wanted to do far more complicated things, you can do that. What we can also do is, so if we go back to our code up here, which one should we do? Where do we have all our means and medians? Yeah, this one here. No, sorry, this one here. Sorry. So if you find your beds data where we did the means and the medians and bits and pieces like that, if we remember, this gave us our organization code, our mean beds, and our median days. If we wanted to do things like a count, that's simply so just a count. There's a very simple, it's just n brackets, and that will give us our count. So it gives us our numerator. So that gives us just how many numerators are within that average. And we can also do things like numbers of distinct. So let's just do n, no, was it distinct organizations? I think because there's a one-to-one relationship between organization codes and names, it's not going to make n. It should all come up with 1, I think, equals n distinct org name. I think there is. Maybe there isn't. I can't remember in the data. Distinct names. Yeah, also it's come out as 1, so I think it does. Let's just double check if there are any. If I do arrange descending, was it distinct names? Are there any? I can't spell arrange. Okay, so it looks like RDE does have 3 different names. Let's just double check that, see whether that is correct. So beds data, and then filter it to RD&E, to org code equals RD&E. How many is that? And then distinct org name. There we go. So we can see that it is correct that code does link to 3 different org names. Sorry, went off on a little bit of a tangent then. Hopefully that's not too bad. But again, as I said, I will share this code. You can have a look at back and have a look at the video, and hopefully make some sense of that. Where are we? We're at 12 o'clock. We are going good, I think. So that was n distinct. That was good. So let's have a look at objects. So previously, we've loaded us some data, And up here, we have our beds data and we've had our capacity AE, and we've just used those as our objects, and those objects appear in our environment. Sometimes what we want to do is, obviously, where we've been running all this analysis so far, we've just been creating in a little sort of tibbles that have just appeared and then poof, they've disappeared. They don't exist in the environment. Sometimes we want to keep that analysis and use it. So what we can do is create objects from our code. Oh, that's weird. Why's it done that? Let's go back down here. So let's do that. So where we have, so create, sorry, let's go objects. So let's just give this an example. So I run this and I get a little tibble that appears, and we can see it's 231 rows. I don't know why we've got this come through so bad. We see it's got 231 rows of 6 things, but it only shows us the header of them. I want that now as my summary data, as my thing. So I can call this, let's create a new object. I'm going to stick it here, beds. Occupancy. There we go. And what we're going to use is another used little funky symbol, which is this one, which is a left arrow and a minus, which is called an assignment. There's a shortcut for that. You can just press Alt and minus if you wish. And that's called an assignment operator. So now when we run this, nothing happens here. It's just run. But who can see what has happened? Something magic has happened. What we have now up in the top right hand side is a new thing called bed occupancy. And a bit before, I don't know if I showed you earlier, if we want to see our beds data, we can just click on it there and it pulls up our beds data. Now, if we click on bed occupancy, we've got a new data frame we've created, and that is, there's a new data frame. And we can use that data frame just like we've created it now. It exists in our environment. We can do anything we want on that. So if we want to do anything further on this data set, so if we want to do beds occupancy and then filter it, then filter median beds. Oh, okay. Let me see. Greater than 0. It's probably easiest. That will run that through. Again, that hasn't changed that view of our data set. So we've still got 231 rows. But if I want to overwrite it, I could do my bed occupancy and then assign it to bed occupancy and then filter to beds greater than 0. So if I run this, I would expecting this to go down to 71 observations, which indeed it does. And I look at that now, and I've got my data set where I've got the observations. So I can create this bed occupancy from this beds data, do my calculations on it, and I now have got a new data frame that I can do other stuff on. And you can create as many as you want. Well, not as many as you want, as many as your computer can handle, which is a lot, believe me. So yeah, millions. And I think the biggest data frame that I've got in ever was just shy of 1 billion data rows. So hopefully you guys are not using anything that ridiculously huge. But yeah, you know, for the most of the standard stuff you're going to use, it's not going to be a problem. That was using a virtual machine, so I don't know. Obviously, when it comes down to using it locally, you are limited to your local computer memory. And obviously, if you're using it on the cloud, you're using it on somebody else's computer, so it depends. Obviously, if you're using RStudio, this version on the cloud, I think we are quite limited, but it's still gigabytes of data that we can use. And I assure you, nothing we're doing today is quite that. Just to be very, very, I don't know why this is coming in here, but there's a note about naming style. This is a bit out of sequence around what we're doing, but there are various different styles of coding. I am a favorite of snake case. Virtually all the stuff I use is in snake case. But it's very, very good to sort of be consistent in your variable names and your sort of and what you're using. So it just makes it really clear for anybody else seeing your code what is a variable name and what is a function. And also, obviously make sure that they are good names that are descriptive of either the object or the variable that you are creating. So yeah, there's various different things there. I'm, as I said, big fan of snake case, and that's what I use across most of my analysis. Well, all of my analysis when I do it, and that's for column headings, that's for variable names, and various bits and pieces. So that is that. What are we on now? We are going to introduce you to some vectors. So all the data that we've done so far has been in data frames. So, and we've been looking at sort of single things. So vectors are another type of data, another type of data format. So we've been using data tables, which is rows and columns. Vectors are sort of more, and obviously that's two-dimensional. Vectors are sort of one-dimensional, and I'm not going to go into it now, but you can also have greater than three-dimensional data sets, which if you ever get into sort of linear algebra, yeah, that kind of blows your mind. But yeah, you can get into greater than 3 dimensions. But I'm going to stick with either 2 dimensions or 1 dimension for what we're doing today. And what we can use is sometimes we want to do sort of multiple things on a data set. So we don't want to just do one thing. We want to say we want to filter our data. Instead of just giving it, I want to filter it to Devon, I want to filter it to Devon, Somerset and Dorset, and I want to give it 3 variables to sort of feed in there. So rather than saying filter org name equals Devon, or it equals Somerset, or it equals thing, you can say data is, and then you can give it like one of these 3, and you can give it sort of multiple things at once. This will make more sense when we start writing it, but basically we can create these vectors by using a small c and open brackets, and then separate our data sets, data with a comma. And what's kind of weird about it is that you can mix strings and numeric variables within the data set, within your vector, and it will understand that's a number, so I'm going to treat that as a number, and that is a character, so I'm going to treat it as a character. So again, R automatically spits out those things, which is cool. So what we can do is, like I said, create a new variable or a new vector called organization lookup. So rather than you guys typing that out, I'm going to copy it in the paste in the chat, because I know my spelling would be dreadful and I'd never get that right. So what we can do is create a vector called organizational lookup. And if we run that, what we can see is that our environment has done something a little bit more funky. It's worked out now that we've got some data sets, but we've also got some values. So for those people who've done more sort of a little bit more advanced SQL stuff where you can write variables, this is basically now setting up some variables. And what's really nice about R is then you don't have to declare them, you don't have to you basically set and declare them in one go. So now I've got this new value called organization lookup, and if I just run org lookup, I can see these are the 2 things that feature within my org lookup. So what I can do is my beds data, and we can do a classic filter, and then we can do org name, and we're going to do something a little bit funkier. We're going to do an in statement, which does look a little bit funky, in that we do this weird sort of percentage signs around our in, and then we can say in our org lookup. And if we run that, it will filter our data to where our org name is in whatever we've put in there. Again, if we were going to do it on a single basis, we could org lookup. So if we just want to do it as a single and not a vector, we could just have a single thing like that without all the brackets, etc. And that creates another variable here, which is just Bradford Care. So you can see that difference. This is telling us that it's a character string and it's got 2 values. This is just telling us a single value. So this is a single variable of org lookup, and we could do a double equals and run that one. And that should just bring us back Bradford District Care. Does that kind of make sense? Vectors will make more sense when you kind of use them more, and it's really, really powerful sort of programmatically what you can do. We can also do, oh goodness me, this is a bit bonkers. So we can also do like a negative and not in if we wanted to. So at the moment on this, so negative, look. Negative in. So at the moment we're doing a positive, so I'll jump back to this one again. So I'm looking at Bradford and Bradford District Trust and Bradford District Care. What I can do is negate my organization name by using the exclamation mark, and that will then do my negative version. So basically that bring back everything except Bradford Care Trust and Bradford. So if we do that one, that will do it that way. And again, if we were doing the single, there's a couple of ways of doing this, but what we could do is a not equals to. So where we previously been using this double equals to say is equals to, we could change that to a not. And that would be filtering everything apart from those, which we can see we've knocked out 10 rows by doing that. So again, depending on what you're doing, it can be very positive, it would be really, really helpful to do the negative if that is the way around to it. Generally, I would, good practice is always go positive, be positive as much as you can. But sometimes you do want to say, actually, I want all the results apart from anything that's coming through as null or anything that's 0 and various bits and pieces and things like that. So you can do that, which is cool. So where are we at? We're good. We are good. So let's have a look at joining data together. So a classic thing, and again, this is either what we would do in SQL, which is a classic join, or I guess the equivalent in Excel would be is a VLOOKUP. So you've got some data in that table, and you've got some data in that table, and you want to join it together based on a key, which is our classic relational data question. So as is, we've got some data that we've got in a lookup table, we've got some data over here, and we want to join it so that the right thing gets pushed together. And obviously any SQL users obviously eat this stuff for breakfast, no problem. So let's have a look at how we do this. And generally, like I said, we were going to matching on various common or key variables. So again, within your VLOOKUP, we have 2 columns that we sort of obviously want to match on or do a fuzzy match on, and same with SQL, and it's 2 or more. So joins, all the joins in SQL are available in R and called mutating joins, and we also have a couple of things called filtering joins, which uses the same concept as exists and where, and we can do those within R. So where are we? So our classic join is our left join, and to be honest, that's our bread and butter join. I would imagine 95% of any joins that we are doing would come up with this type of join, and that is your absolute classic VLOOKUP. So we've got our standard data here, we've got our data here, and we want to join that together to create a data set that looks like that. I hope you've seen this amazing animation. So we've got our left data, which is our X, and then we're going to join it on Y based on our ID and come up with a single data set. Hopefully that kind of makes sense. So we are going to import some data. This data is not messy in any shape or form. It's just there to sort of help to that. So again, going back to like first thing this morning, let's import these 3 data sets. So we want to import the data for TB cases, TB pop, and TB new table. So obviously we've done this so many times now, you've got it absolutely remembered. But let's do that again. Use the wizard to write the script for you. Don't press the OK button, and let's import those. So joining data. Oh, I can't spell. Joining data. So we want to enjoy from Excel. We want to so from read R. We want TB cases, and we want to copy that. These are really, really small files, and there are no tricks. TB cases, TB new table. And whatever the other one was. TB pop. Yeah, so these haven't got any messy dates or anything horrible in them. They are just as is. And hopefully you can start seeing now that from what we've learned, we can see now that we've used this assignment operator. So we'd already used it. And what it's saying is TB cases is going to be this read CSV function. So once we read this CSV, we're going to assign it to TB cases. If we wanted to call it something else, we can call it something else. But hopefully we can run those and we're all good. If you want to be nice and clean and get rid of all the junk that you've done previously in your environment, you can clean it out. So there's a little broom here which says clear objects out from the workspace. So I can click on that if I wish to, which I'm going to, and then just run my TB cases. So I've just got those. Don't have to do that. It's there if you want to do that. Can we have some thumbs up if you've managed to import those 3 data sets? Excellent. Yeah, all good. Sorry, I should have said hands up because then I fingers. Yeah, thank you. Is that hands up because you've done it, or is that hands up because I'm just really confused now? Hands up because you've done it. If you've got a question, shout. Or if it's stuck, can I repost the URL for which the data? Which one are we? Which URL would you like, Diane?
I've got to the import text data, and if I remember rightly, this morning you gave us a URL.
So we've already got that there.
Oh,
so you should have those. That was part of the.
Okay, brilliant.
That was part of the data sets we've already downloaded. So you don't have to do any of that unless you've started a new project, which I don't think you have.
I'm there now.
Yeah,
Thank you.
Got those. Yeah. Now we downloaded them all to start with this morning. Cool. I can pop that in the chat if it makes it easier. I say it's not a test to let me copy all of those. There we go. That should bring them all in for you. So let's have a quick look at them. And again, there's a couple of ways we can do this. So you can click on them up here. And again, we can see our view. So what we can see is we've got this TB cases, which has got our country, our year, and number of TB cases. You put arms down unless you have got a genuine question now. Oh, it's far too confusing. And then we've got a TB pop, which is basically our country and year and our population. And we've got a TB new table, which has got something else we're going to use for a later example, which is our place, our year, and the first letter of our place. And what we want to do is create a table which has got our year, our country, year, cases, and our population. So we're going to create, out of those two tables, we want to create one table, if that is all good. So how do we do that? Right, let's start with our TB cases. And then we want to do a left join, and it's left underscore join. And we want to join it to our TB pop. We want to tell it what we want it to join on, and we want it to join on country. And if we run that, what have we got? We've got several things. So what have we got? We've got duplicates. That's what we've got. And we've also got a warning message. So what have we done? So basically, if we look at our data, we have got country and year and number of cases. And in our data set, we've got country, year, and a population. And if we have done our join purely on the country, so if we look at our countries, we've got 4 different population numbers which we are joining for each country. So we're not just joining it on country, we also want to join it on year. And again, this is obviously something which is SQL bread and butter, but is quite mind-blowing for Excel users who are quite used to sort of giving their VLOOKUPs a single feature to look up. So I'm not only looking at the country, I also want to look at to bring back the population for the right year. So I'm going to do 2 things at once. So how do we do that? I refer you to the thing what we just learned, which was vectors. So maybe a vector is our friend. So in our by, instead of just purely having it by country, let's turn that into a vector, and we can do a vector of country and year, and make sure we close off our brackets. And we can do that. So if we run that one, we should now have we should have a nice join, and it will give us a nice 16 observations. Also, what we can do is also call this, I don't know, TB joined. And what we could do is now create a new object up here, which where we can see we've still got our 16 observations. So it's really nice to know we haven't created duplicates. And we now know that we've got 4 variables. So if we look at our TB joined, we can see that we've got our 4 variables. Everybody happy with that? There is an alternative way of doing this, so I'm just going to show you just in case you see it elsewhere. So you can do, let me see which way is it. You do table joined, and instead of doing this by, there's another thing that you can do now, which is join by, and that doesn't take it gets a bit messy about how it works. And that doesn't take vectors, you can explicitly name each thing. Also gets a little bit confusing around those are in speech marks, these aren't in speech marks. So that should come up with, let's just call that alt. And this gets a very, very confusing about, but Simon, when should I use speech marks and when shouldn't I use speech marks? And also, Simon, sometimes you use double quotes and sometimes you use single quotes. So a couple of rules on those. If you're going to use, doesn't matter if you use single quotes or double quotes, as long as you are consistent in the feature that you are doing. Sometimes, I'm not going to, so a paste command, you can do hello world. And that will do hello world. Oh, and right. Sometimes I want to do speech marks. I actually want to print speech within my actually I can do that with a print statement, can't I? That should work still. So sometimes I want to put speech marks within what I'm printing. So as long as my outer ones are the same and consistent, the inner ones will still be within my thing. Although, however, it has done weird slashes. Let's do just paste work better for that. It does do weird stuff. Yeah, it's put some extra backslashes in there because it's getting a little bit confused. But yeah, you can see that if you have got speech within bits, or you actually want to quote a double speech marks, you can do that. So it doesn't matter if you use single speech marks or double speech marks, as long as you're consistent in whatever specific function that you are doing. That is fine. Normally, when you don't have speech marks, it means you're discussing an actual object, which is generally something that's in the environment up here, or if it's a subpart of a so this is the object, which is my TP pop, and I'm doing a sub-object, a subpart of that, which is one of the variable names, which is here, and that wouldn't need to be going into the speech marks. However, some functions mean that you do have to do it and some that you don't, and it's, I don't know, it's a little bit of trial and error. Generally, R will guide you in what format they need to do, but it's something that does just come with a little bit of experience. I'm just trying to think if I don't think there is a nice easy golden rule to that. But yeah, when we've done things like here and we've said, you know, Bradford District Centre, that's not an object, that is just part of the data. Whereas an object is more the actual table name or the column variable name. That probably makes more sense. So when you're referring to the actual data, normally it's the speech marks. Why this version for the old buy does it in this format is a little bit inconsistent, which is why this newer version, I think is of 23, follows that rule more. But because obviously it's a continually evolving language, it can change. So anyway, right. So dplyr can do joins automatically, which is quite nice as well. So we can just do TP cases, then left join TB pop. So we didn't even, or TB pop even. So we didn't even have to tell it to what to join on. So where it recognizes there are multiple keys, it will do that automatically, which is quite nice. However, being quite old school myself, I think it's quite worth explicitly saying what they are, because at the moment, I mean, that's done the join correctly, but I don't know what on. So I prefer to explicitly say what my join is on rather than trusting R to come up with it. Is that fair to say? So that's that. We can also do things on sometimes obviously we've got a nice thing here where we've got the countries are the same. If we look at our TB new table, oh no, wrong one. Where's our TB new table? Country in this one is called place. It's the same key, but it's called something different in one area than it's called different in the other. So let's join those together. So let's take that one both ways. So actually, let's teach you the new way because that is the correct way. On one side, it's called country, and then on the other side, it's called place. Also, really annoyingly, because, you know, it's R, and this one, it's called year with a capital Y, and in this one, it's called year with a lowercase y. R is not going to spot that those are the same. You have to be explicit. As I said, it's very case sensitive. It's gonna break that. So simply, what I can do is I can say join by country equals place, and year is equal to year. So what I'm doing again is this is equal to. So when you see this double equals, always think in your head the first equals means is, second means equal to. So country is equal to place, year is equal to thing, and this is on the this is on the TB new table. Joined new. And again, if we look up here, we should have that nice new table up here. And on this instance, it's joined it for our first letter. Does that make sense? As ever, running short of time, but do shout if there's anything that nobody doesn't understand on that. So we can also do other types of joins. So let's show some other bits and bobs. So we can do a semi-join. So semi-join retains the data on the left if it matches on the right, but drops the data on the right. So it's not like an inner join which keeps both sides. So only retains the data on the left if it's got a match, not like an inner join where it's going, oh, frozen screen, but you're still listening. Okay, so the semi-join, yeah, does something different. So all of X, but only where there's matching Y as well. Okay, so let's have a look about how to do a semi-join. Oops, where are we? So let's think of this. So let's just say maybe we want to find hospital patients who've had a COVID test, but only bring back on the information of the hospital and nothing about the test. So if we join to the new table and look for only the records where the column first letter is A for whatever reason, but drop data from the new table. So we're going to create ourselves, let's create a lookup table first. So we're going to create a lookup table, which is going to be our table, new table, and then filter. First letter is A. So we've got a lookup table now, and if we look at our lookup table, it's just got those with a letter A. So now if we do a semi-join on our new lookup table, so let's just copy this, change left to a semi, and this is on our lookup table. This has now brought through our, so this is kind of a filtering join. So it's pulled those through. It hasn't actually pulled through the first letter A. It's kind of done a filtering join. I hope that makes sense. Go back to my code. I'll pop that into the chat if anybody was struggling with that one. So what we can also do is an anti-join. So anti-joins are quite good about trying to work out where data is missing. Especially if you've got two data tables and they're supposed to, I've got a list of hospitals on one side, a list of the hospitals on the other. How do I check if I've got any that aren't in both columns or in both bits? So, if my, I don't know, column, my left hand, sorry, my first table is just a table of all my hospitals, and then I've got a table of all my submissions. How do I join them in a way to show me where I haven't got a submission? So it tells me sort of the inverse of what's going on. So where I haven't got a submission, so where stuff's not joining. So this is very much just taking what we just did and actually making it a little bit more useful. So say if we did that and changed it to an anti-join, where are we? Sorry, anti, isn't it? Anti. So now when we do this new anti, what that will return is, where are we? Everything apart from those that started with A. So again, that's where we haven't got matches across the two, which I think is, pretty cool. So yeah, that's quite funky. So yeah, that's quite nice, and that's anti-joins. We can go into a little bit more around those sort of joins, and yeah, you can do sort of like the full sort of inner joins and various other types of joins. You can also do sort of like fuzzy joins as well, which gets quite complicated. And we could also do joins. You can do sort of like dynamic joins where you can say, actually, I want to join the date, but only where it's the maximum of the date. And you can get sort of really complicated down rabbit holes around joins, which I'm not going to go into now because that's not fair. So that's cool. Where are we now? Okay, so let's just do a little bit of something around style, because who doesn't like a bit of style? So we are going to install another package. So I'll pop it in the chat. So there's a couple of ways we can do this. We can either type it in as code and do install package, or we can go tools, install packages, and find it this way. This is generally how I do it. And we're going to install something called styler and install. So installing, you only do once. So once you've installed it, it's there and it's available. If you want to use it, then you have to call it. Apart from styler, which doesn't do that, it works as an add-in, which I will come to in a moment. So yeah, you can either do the tools, install packages, or you can run that code. You can either run it down here and it will run through here, or if you have it as a piece of script, then obviously you'll have to do this and run it here. I'm running it about 5 times now, so hopefully I am definitely which is good. So let me see. What we can do is very messy code. So I can take my messy code, my code here, which is sort of in order. And what I could do is write really joined up clumpy code that all sits like that, and that code is going to work just as well as tidy code. It's just going to be a little bit harder to read. So just to confirm, if I run that through, it's cool. However, what I can do now is go into my add-ins and click on that button, and you can see we've got this extra little thing here that says styler, and I can style selection. So if I click on that, it's asking me to install some stuff, which I need to do again, only for the first time, and only this is a weird cloud thing that it asks you to do. And there we go. Right, then you have to highlight it again and then do add-ins, style selection. And what that does is put all my lovely indents and stuff in there for me to make it look much prettier, which is definitely a really good thing. I don't know if anybody's noticed, there is this sort of grey line here in your code block. So this is the line of doom. Good practice says that no single line of code should cross that line, because it just means that you've got too much going on. So in a single line. So that means break it up in some ways. So for instance, this is, perfectly justified and readable code. And well, not readable, it's workable. That piece of code there will work and it will run. But the good practice would say that's just, that's too much for one line. That's too much for my poor little brain to take in one go. So break it up. So that's what this line is. Don't cross the line. So using spaces is, really, really good to, to make sure that you've got those styles in there. Things like putting spaces around your sort of equals, etc., rather than having everything super clumped up. I'm sure if there's any Python users here, there is a whole sort of PEP8 sort of styling code, which gets really quite detailed, and Python very much works on your indents. R is just all about style, about trying to make it sort of readable, and it's not quite so as picky in there. So that's quite useful. So where are we at? We are very nearly lunchtime, so that's good. So just a little bit of thing around, I think this is off the old slide. So what does this function do? I think I touched on it very briefly with that mean function. So, you've got various different ways of calling up sort of help and understanding what functions do. And as I talked about that CRAN library, one of the things that you need to do if you wish to write a package that's available to everybody is write really good documentation for your code, so that and for your function, so that other people can see it and can use it. And quite often, if you look at the sort of help screens, it will also give you a working example of how you can do this. So base R comes with some built-in mini data sets. Quite often you'll see MT cars or the petal data set, and it's just like a basic data set that's inbuilt in R, just so that here's an example of this function working, and we can both use it on the same just inbuilt data. So just on that, if I show you, if we do MT cars, it's just this tiny little data set that's in there. But if I want to show you, on a reproducible way, how do I do a mean MT cars and then the MPG, I can show you how to do a mean function without having to do a thing. Don't worry about the $ and stuff that I just used there. I just appreciate that was a little bit, well, it's not advanced, it's the opposite of advanced, but yeah. We're not going to go there for now. So yeah, there's a help function, and you can click on the sort of the help bar on that top and bottom right hand side, which allows you to bring up sort of help functions and sort of see stuff. You can also put a question mark in front of your function. So I can just type in, usually best to do it on the console actually, it's just question mark mean, and that will call up the help for the mean function, which is really helpful. We can do 2 question marks in front of it, which will, what will that tell us? I'm trying to remember. That will tell us at a higher level where mean sits. So mean is part of base R, so that's probably not a good answer. So mean mutate. It should pick us that, yeah, that is part of dplyr, and that's where it sort of sits. So that's good to know. But if we just wanted to do purely mutate, it will tell us what we want to do. So we use mutate, we use the .data, so we knew we'd put data in there. We know we can put sort of several things in there. We use the .by, there is some other features that we haven't done. So when we did that create mutate, when we created that new column, it automatically put it just on the end. If we want to create a new column and we want to fit it in the middle somewhere, we can tell it where we want to create that new column. So there are some extra features which we haven't used, which is before and after, to tell us where we want to put that column, which is quite nice. And there's also the keep function, which, what does that do? Controls data. So what we can do is just do the mutate, and then it removes all the other stuff. So anything that's not being mutated gets like removed from the data set if we so wish. But yeah, so it will tell you basically what are the defaults for the or the function, how to use it, and then if we go down further, I'm hoping it will give us various examples of how to do it. And the geek in me is very pleased that Tidyverse comes with a Star Wars data set as well as its default. So again, if I want to work out how mutate works, I can have a look at mutate. Just so you're not too scared, as I said earlier, this is the old style pipe operator, just because this is a bit of an older vignette. But it works exactly the same as the pipes that we've been using all the way along. And if we run this one through, hopefully we can see that we've now got a mass 2 and a mass squared, which is there. So hopefully that's cool. So you now know the mass squared of Luke Skywalker is 23,716. Go away. Sorry, phone call just made me jump out my skin. Cool. Right. Other places to get help, which is really, really important. Stack Overflow is your friend, and also a really, really scary place to go. It's a brilliant place. If you've got any sort of coding problems, you can stick them up there and you'll get some answers. They are very, very sort of professional, and it's very much a case of you need to be able to answer your question and make sure that nobody's answered, come up with a new question, because people will get very annoyed if you've asked a question that's been answered 500 times already. So without a doubt, do a lot of search and also try to understand the syntax and stuff around Stack Overflow, around asking questions. They would want a reproducible version of whatever your error is so they can copy it and do it. However, I think I've only ever posted 2 questions onto Stack Overflow in the last 6 years. Most of the other times I've searched for a question, searched for an answer, and I found it without having to put my own up there, which is great. There is also obviously the wider NHS-R community, and we do have a Slack group, which is fantastic if you've got R questions, especially if it's like NHS-y type questions as well. Quite often somebody will have come across the same sort of issues and problems that you've got, and it and understands the problem and the question that you're trying to talk to, because talking to somebody about lengths of stay or something like that, people haven't got a clue what you're talking about. So it's really, really good to have help from your peers. There's some really nice cheat sheets available. So within R, it's just like, if you can print these out, and it will give you some really, really common ways of how things work. I think within, I think you can just access them here, can you? I'm just trying to remember now. Trying to remember where they are. Is there a cheat sheet? Or maybe it's in the R Studio. Trying to remember which cheat sheets. Oh yeah, here we go. So you can go, what have we got? What have we done? Data transformations with dplyr. So you can go there, and there are some links. And where's that gone? Open file. And there we go. It's given us some sort of basic ideas of how we do arranging and adding, and also comes across some sort of more advanced stuff, which we haven't touched, which we will do on our next session if you're in that one. Where are we? So cheat sheets are really, really good. They're great to sort of print out and sort of have to your side if you're doing anything specifically. Save your script. So yeah, we haven't done that, which is very, very poor. Let's go back to our script, and we can do file, save as, and then we just obviously give it a file name, intro. Ooh. Sorry, I clicked on something, didn't I? Intro script, and save that. and then we've got an R script now, and then obviously that's saved. If we then want to rerun it, that's all there. If you want to download that script to your own machine, what you can do is, where do we do it? We do it as, I'm trying to remember. Oh yeah, more. Is it more? Yeah, export. Oh, sorry. Click on your script, and then more, export. Is that working? Oh, tick the little box. That's what I'm doing. Export, and then I can download that to a specific place if I so wish. I think that's just downloaded into my downloads folder. So that's now on my personal machine, so I can access that script. And obviously, if I want to run that in my own machine, I can load that up and run it. Oh no, we've done all that already. That's the wrong one. Where are we at? Save your script. So yeah, saving that. And obviously it's a good idea to save your script regularly. There are some really great books out there which are constantly updated, and obviously I'll share the links to these. If you want to go into sort of much more sort of data visualization stuff, we're going to do some charts and stuff tomorrow. So today has been unfortunately a bit more real life, where we're doing a lot of wrangling and just fudging the data into the way that we want it. Tomorrow we're going to play with pretty charts, which will be much more fun. But there's some really great books and recommendations there that are for data science stuff. Sounds data sciencey, but the first couple of chapters are really basic data wrangling stuff, which is, you know, really good. Written by Hapley Rickham, who's basically one of the authors of the tidyverse. So, you know, if he doesn't know how the tidyverse works, nobody does. And there's links to those. You can buy those books as physical copies, or they're available as free and open source on online, so you can see them there. Art interlude. What's this? I don't even know what this is. Let's have a look what that is. Does Twittercom even work? We don't go to Twitter. This is how old this is. Oh, go away. No, I'm not going to sign into X. No, right, anyway, let's ignore that and pretend it doesn't happen. And there's some really nice sort of examples of art and bits and pieces, or at least I don't know what these are. Yeah, anyway, bits around art. There's Our Ladies as a group, which is really nice. Sort of shows lots of obviously supporting women within group. Obviously, I have to shout out about the R community generally, because, you know, we are awesome and, you know, just very inclusive and supportive group. And you know, there are various sort of webinars and support there. I run a coffee and coding session, which is once every 2 weeks. It's just an hour drop-in session. We have people show off what they've been doing, and it's a real mixture of people who are very much in a similar position of you guys, and like, oh, I've come up with this error, how do I fix this? And somebody can just say, yeah, you've just done that. Or, you know, just seeing the art of the possible and seeing some of the stuff that people have done outside, and seeing what's going on. Only heard great things about coffee and cars. Too kind. So yeah, you know, that's just an open session there to you know, come and ask silly questions, find out what people are up to, and again, just see the art of the possible. I think, where are we to now? Oh, ongoing learning resources. Have we got those? So yeah, I mean, I guess obviously we haven't finished, but you know, ours not unlike learning a spoken language. It takes a lot of time to learn up that, you know, vocab and syntax. There are lots and lots of different ways of doing things. Even today, you know, that order operations is, you know, really interested that you can do things in different ways. And you know, without a doubt, you're going to look at a piece of work and go, well, I could write this in R, but it's going to be so much thing, and I'm going to have so many errors, and it's going to go wrong. And I know I can just go to Excel and I can click and drag a few things, and it's going to work. And I feel your pain. I have been there. Much like when I was talking about, you know, my history, when I look back at what I used to have to do in SQL, and, you know, when I saw SQL after coming from Excel only, going, oh, wow, that's amazing. How could I possibly ever do something like that? You know, I feel that with R now. I look back at stuff in SQL or Excel, and it's like, who would do something in such a convoluted way? That's absolutely bonkers. So, you know, it is an investment. It is a steep learning curve. Hopefully today we've kind of got a bit of a feel of it. Tomorrow we're going to do some pretty graphs, and it'll be lovely, and it will be much mellower. Believe me, trying to calculate question 5 is horrible, but yeah, you will get out of it, and it will make things. Yeah, what do you do if you get stuck? Obviously, Google is your friend. Yes, there's a good bit of that Stack Overflow strategy. Some of the things is obviously you're not aware of R and you don't know the syntax to know even what you're asking. It's like, am I asking about a problem with my vector or my tibble? I have no idea. So, you know, some of that does get quite tricky. And also that last question, that last point there about be aware of the data of the answer, because again, R is continually evolving. So, you know, it's quite often that you might look at a question and you get an answer and it's like from 7 years ago, and it's like, there's probably a more recent, more useful way of doing those things now. So yeah, you can look at Stack Overflow and that will come to those. I think we've covered those books. I think this is a bit of a duplicate. So yeah, we've looked at those books, and obviously we'll send out those stuffs. There's some really nice blogs. Obviously there's the NHS-R community site as well, which is really good. Mr. Park, can I save the code? Yeah, I'll show you in a second about how to do that. Base R versus tidyverse solutions. Yeah, really tricky. So I do cover a little bit. So we've been using tidyverse, which is really nice. And, you know, again, when we're looking at sort of, you know, it's got the GPS, it's got the airbags, it's got some really nice stuff, and it's got a nice similar syntax. A lot of people do poo-poo that and go, oh no, you must use pure base R, which uses a completely different syntax. And don't get me wrong, there's pros and cons from both, but if you just see some base R, you might get, this doesn't look like any of the R that Simon's just showed me, and it won't do. I do cover a little bit of it in the intermediate stuff. I do generally, you know, most people, 90% of people will point you towards the tidyverse, but sometimes you will get some sort of base R solutions. So it's kind of a very good point to be aware of that. I say there are Slack channels, which are great. Do get on the NHS-R channel. There's also a government data science channel, which is again sort of some great resources there. We're not going to go massively into projects, although I will explain that a little bit more tail end of tomorrow. I think that is today with a whole 5 minutes to spare. So let me just run through that quick question. Somebody wanted to know how to save their code. So basically click on, go to your files and click on the thing that you want to save, and then export. And then you can just click on download, and that will save the code on your local machine. And that will be fine. Again, what we have done and is used a project. So something I'll go through a little bit more tomorrow, but when we've loaded in the data, etc., it's been really nice, because all we've had to do is we've got this, you know, we've just used read CSV from this folder, and when you create a project, it puts everything in the same folder and it just uses that as default. I'll show you a little bit more tomorrow about that, but if you are going to take this code and use it and try to use it on your home machine without setting up a project, you will have to explicitly give it the full file path to your CSV, for instance, which is a little bit more messy, but I'll show you how to set up those. Right, we've got 4 minutes if there are any last sort of bits or questions or comments. And then you can have some very well-deserved lunch and see how many people come back for tomorrow. Tomorrow would be lovely. I mean, that data wrangling task, question 5, just ramps up so quickly. Pretty charts, honestly, pretty stuff tomorrow. Back to day 2. So congratulations for being brave enough to come back to day 2, which is awesome. So that's great. What I'm going to do is just run through very quickly yesterday's stuff. I have gone through and just tidied up my code slightly, and I've also just written a little comment against each one. So if anybody, I will save that at the end of the day, and I will share it as well if there were still bits that I did that you didn't have a chance to sort of catch up on or whatever. So first things first, if I share my screen, that would be good, and I want to share that screen there. So first thing I want to do is go back to Posit Cloud and I'm already a user, so I can just use the login button. I log in with Google because it's just easier, so I don't have to fluff about with passwords, etc. And I pick me, and that should then take me to my screen. You'll probably just have the one. I've obviously got loads of projects where I've done loads of different bits of training and whatever. And I've got my introduction to R here. What I should do for my own sanity is put a date on there and call it something else. So if I run very quickly what we so first thing we did was call in the first library session, install the library, and then call in the library. So yesterday we installed the library. Today we do not have to install it. That is installed. All we have to do is import it. Sorry, not import it, is call the library with here. Then we wrote in some data. Then we read in some data, which is our capacity AE data, and we looked at it. We then, this was, sorry, I didn't do this. Import messy data. So this was some data which was a little bit messier. If you remember, the data at the top, and we skipped the first 3 lines. And the date format was a little bit funky, so we the import wizard to just adjust those within the import wizard, and then we copied the code from there and we pasted it in here, so we didn't have to do it again. So that was really good. I mean, you don't have to use the import wizard. You could write that code directly if you so wished, but whatever. We then had a little chat about the pipe operator, which is this thing. Let me just change this. So those are both the pipe operators, and the big thing is this means then. And see that with a pipe operator, just thinking ahead then. Then we went through and we started to do stuff with our beds data. So we started using some dplyr verbs. So first of all, we looked at our question 1, which was the highest beds, and we used an arrange function. And then we did the same again. So we added a little descending function to our arrange. Also showed how we could do that with maths and to do it as an arrange and minus. We then had sort of the next step, which was looking at the highest number of beds for a certain date. So again, function, and then we also used that sort of filter function to filter the date to a specific date, and that's where we brought in our is equals to, our double equals, so we'll chuck that there. So I think my example here was also could do a filter with another feature, just that you're not limited to those commands once within your pipeline. We can do it several times. So when I talk about pipeline, I'm talking about individual bits of stuff here. Let me just load in tidyverse just so I've got it. And there we go. So what is quite useful as well, so when we have got a longish pipeline like this, beds data not found, because I haven't actually loaded in the beds data. Let's try again. One thing I didn't show yesterday, but is quite useful. So when you've got, let's try this one actually. Yeah, when we've got a longish pipe like this one, and we run it, obviously we go through there. What is quite useful is that we can sort of just select bits of our pipe and we can run it to a certain bit, so we can sort of run it where our errors are, and it's very useful sort of debugging doing it that way. So we can just run it section by section up to just before the pipe operator to see what that bit does, and then see the next bit, and then see the next bit, and we can see our data transforming as we go along. And that's a really good way to check that we're not actually duplicating, so we're not doing anything funky as we go. So that was that. This one we added in a slice head just to bring back the actual 2 to give us our actual question. Then we had the free organized. This is where we started thinking actually we haven't got a certain feature at this point, so we were going to do a mutate onto our data set and create a new column. So we're going to mutate our data set and add a new column, which was our percentage occupancy. And then what was really interesting is once we'd created that bed occupancy, we can immediately use it in the next part of the pipe to do sort of further calculations on. So if we wanted to do a percentage, so we did a percentage, in this instance we did a range. If we said we wanted to do a filter to percentage occupancy to only show those above 85% or something like that, we could instantly use that percentage occupancy variable that we've created within our pipeline, and that's really, really powerful. So that's cool. We started looking at some summary statistics. So again, when we're doing mutating, we are using the sort of the core data sheet, as it were, and creating new columns on there. If I think in my Excel brain, and then when I use a summarize, that's more creating a pivot table or sort of summaries of the data. So I'm creating sort of different bits of summary for those. So again, that's where we brought in this mean beds, and also showed you how within our data set we had some nulls, and if we didn't remove those nulls, it could again give us some results which were, well, wrong, because it came up with a null. Sorry, just suddenly got hiccups. Hope that's all right. Next section was just to show that we can add additional summaries to our summarize, so we don't have to sort of repeat ourselves, and we don't have to repeat summarize over and over again. We can put different bits of a summary separated by commas into our summarize into our summarize function. So we could do a mean beds and we could do a median beds. We could also do a mean, a median, and a total. Which was really, really good, but that was across the entire data set as one. Then we brought in the dot by, which was a sort of grouping variable, so we could then calculate our mean, our median, and our total across each of the dates, which again, becomes much more useful. Also showed that we could use that. So yeah, we could do it by the organization code if we wanted to, so we can group by different things. We could also group by multiple things, so if we wanted to get an average of the organization code by each date, we can do that. So you're not limited to just one grouping feature, you can do multiple. I showed you this, which was the sort of the more old school method of doing a group by, which was having a group by as a command, as its own separate thing. So you group by, you group your pipeline, and then do what you want that's grouped, and then ungroup it at the end. The ungrouping at the end is very, very important, because your data set will stay grouped, and if you try to do stuff on it in a later pipeline, it will still act as if it's grouped, and you might not have remembered that, and that can cause some issues. So always good practice to ungroup. The dot by feature, if you do it within the summarize, just does the grouping within that feature, and it doesn't add in sort of elsewhere. So really, really good to know that that's there. Which is good. So that was the old school method. Also showed how we could do sort of more dynamic sort of filters and sort of various bits and pieces. So in this instance, I was filtering the date to the maximum of the date, but grouping it by the organization code. So it gave us, in effect, the greatest date by each organization code, which kind of gives us the latest data per organization, as it says there, which is again really, really useful, sort of a little thing to do. Then we got into the joy of question 5, which was which organization has the highest mean percentage bed occupancy. So we started with a summarize, because we need to find our total beds and our total occupancy, and we needed to do that by each of our org names. Or I don't know about org name, I should have perhaps done about org code, because I know there's an issue with org name in that there's multiples, aren't there? Okay, that's good to look back on and possibly debug for a later session. But yeah, I brought back the total beds, created that as a sum. We also worked out we could do it as a mean. It didn't make any difference in this instance, and a total occupancy. And then once I had that summary, I could then create a new column, which was the percentage, which was the occupancy divided by the beds. And then I could arrange it by my new column again, which is my percentage occupancy. So very much showing how you can create these new variables in your pipeline and then instantly use them. And that, you know, you can do a summarize, you can do a mutate, and all those type of things all in one single pipeline, which is good. Mentioned that it does, question was a little bit ambiguous, but it doesn't do there. I can't remember what this one was. I'll have to have a look at that. I think this is where I was just playing with tidy data. So anyway, then went into the select features about how do we select certain columns. So this was just selecting a couple of columns, how to select everything apart from a column. So we did this sort of negative select. We also showed how we could, when we use our select, that then explicitly reorders our columns in our new little data frame, and then showed some of the other verbs that we can use within our tidy select, which is things like everything, things like starts with, things like ends with, and also sort of contains as well. So again, really, really useful if you've got those big long data sets, and especially when you are creating those new variables. If you created, you know, so for instance, up here, if we created several variables which were percentages of different things, down here when we actually want to you know, select certain things, we could then say, oh, select everything which has got perk at the start. So if you're really good with your naming conventions and, you know, are consistent, really helps you later on when you start doing these sort of tidy select things. These tidy select things can also be used for other more advanced functions later on. So I could say, actually, I want to do something across everything that says total. I don't know, I want to find all my columns that say total or tot or something and times them by 2. And then I can select just the columns that have got tot in their name or contains this and times them by 2, or whatever I want to do with them, which is, yeah, again, really, really useful. So again, be really, really descriptive about your column names when you are creating these things, and, you know, try to keep them consistent, because when you get into the sort of more advanced techniques, it will pay off massively. So that's really cool. What do we do here? We added in a few extra bits and pieces. We showed the count function, and also we did a distinct names, which was quite nice. So we could calculate the you know, our numerators for these. And then I think that threw up a strange issue that it looked like the org code RDE had different organization names. So again, just ran a little bit of script here to bring back all the distinct names for the organization code RDE. And it does, in fact, show that RDE does have several organization names. Then we went into creating objects, where we can use the assignment operator to create objects, which is basically creating a new data frame in this instance. So where we'd created our bed occupancy data frame, we now had a new data frame, which was our summary data frame. And again, that's now its own separate entity that we can do whatever we want to it going forward. So, you know, quite often I create, you know, I'll create the master data set, and then I'll do, well, actually, I want to just do something with this KPI and pop it into a chart. So I'll do a filter and I'll create a new data frame that's just got that data in it, and pull it through into the chart, etc. So, you know, really see what's going on. And then showed that once you created that data frame, you could also do additional things to it, and you can sort of overwrite it if you want to. So you can assign it to itself, and it will then sort of filter through and do bits and pieces. We then created a vector, which is basically a variable with multiple values. If you've used Python before, it's kind of the equivalent to a series, except it will accept different types of data types. So you can mix text and values, which Python doesn't allow you to do in that format. So again, becomes really powerful about what you can do with things. So we created a little vector, which was a couple of sites, and then we used that within our filter to look at some specific values. to filter our data. We also showed how you can just create a single variable and then use that within our sort of our filter or whatever, which was, again, really, really powerful in that you can create a value outside of your sort of workflow and then bring it into your workflow, or you can, it just becomes really, really powerful around what you can do, and that you can, you can create them on the fly. So, for SQL users, you don't have to declare them, and you don't have to sort of set, you set and declare them all in one go, and it's just dynamic on the fly. And I will just cope with that as best it can. So we can use that in the filter. We can also, we looked at sort of negative filters. So we looked at using the exclamation mark, which in plain language is the not feature. So we're saying filter not the organization names that are in this organization lookup table. So that brought back everything that wasn't in that lookup table. Or rather than using the double equals, we did the not equals to as a way of doing it. So that's, again, really, really good way of doing a not equals to. Where did we get to then? We then read in some data, and we did some data joins, where we looked at joining on a single feature. So we started off with a deliberate mistake because our data set was a little bit complex, and we created something that had duplicates. We then realized that there were two features that we needed to join in. So we showed how to do old school way of doing the joins, and then this sort of newer version where we use this join underscore by within our left join, which is much, much neater. Although I must admit, I still use the old school version, so I need to update my my brain. And we showed how we could do that. Also showed how R can just look for matching keys and do it automatically where it can. But again, I prefer to be explicit, just because it means when you come back to look through, you know exactly what's going on. And also, if something happens to change in the naming conventions or whatever, it will, it can throw you without you realizing it. So that's good to know. And then we looked at a join where the variables matched, but they had different names across the different tables. So we showed you this how to do a join by, and did that. Then we looked at some other weirder joins. So we looked at semi-joins and anti-joins. So created a data table which just had those with the first letter of A, and then did this semi-join. So that, oh my goodness me, joins, and so it does a filtering join. So it joins them, but only returns those that matched, which is that sort of semi-join. And then we did an anti-join, which is the opposite of a semi-join. So it did a filtering join, but only returns those that don't match. And that's really useful when we have things where we're expecting certain responses to come in for submissions, and it's very easy to say, well, here's the list of the submitters, here's the people who have submitted, do an anti-join, and then it will give you the list of those people who haven't submitted, which is really, really quick and useful. Or see what data you're missing. You can do it on dates and things. So again, you say, well, this is the list of dates that I'm expecting in this data set, do an anti-join, and then it will tell you if you've got any missing dates, for instance. So anti-join, a little bit complicated to get your head around, but actually is really, really useful to to do that kind of thing, and does it really, really simply. Then we looked at some style. So we looked at the styler package. So we installed the styler package, and then saw how this uses this add-in feature, and then how we can sort of highlight some messy code and style the selection, which is really, really useful. Then looked at some sort of the help features. So showed how R's got some built-in data sets. So empty cars is one of the classics. Showed that you can do a question mark in front of a function. It will come up with the function library. If you do 2 question marks in front of it, it will show you the library help as a whole. You can also click on a function and press F1, and that will also bring up the help function, or you can just click on the help function here and search for something manually to try to find it that way. And then showed how, for instance, the mutate function has this specific how a lot of the functions have sort of workable and usable examples of how they work, which is, yeah, down here. So for instance, I know that's mutate. So if we look at mean, yeah, there you go. It's got some examples there of how to use mean function. Blimey. And then we went I think I then shared some extra resources and bits and pieces which are off there, and I will share out all the code. And that's where we got to yesterday. Blimey, that was a busy day. And so glad to see so many people back for more today. Any questions on anything we've just gone over there? Is everybody happy with that? Does anybody got any of that stuff missing? I mean, I can share that code now with people if they really want it. What we're going to be building on today, we'll cover some of that stuff, but we're going to look much more prettier and go into some plottage stuff today. Any questions on yesterday apart from, oh my goodness, Simon, you've just given me hideous flashbacks of my brain melting yesterday. Please share the code, thanks. Do you need it now or is afterwards okay? Or I can send it out during the next break or something if needs be. After, okay, yeah. So what I'll do after the session is I will put all my code onto a separate little GitHub repo, and I'll send you the link to that, and you can just download it from there, and it will be available for all to see. So right then, yeah. So yesterday was very, very data heavy in sort of wrangling. You know, as I keep said many times, unfortunately that is the bread and butter of our jobs, really, is getting it into that bit. But you know, occasionally we do get to do stuff a little bit more nicer and to do some pretty charts and bits and pieces. So that is what we are going to do. So here we go. We're going to do some ggplot2. So this is, so yeah, if you can go back to your workspace from yesterday and load that up in Posit. If anybody wants me to go over how to do that again, do shout, and I can show you again. Otherwise, hopefully you've got it there and you can just log back in and it should ping you back to where we were. So introduction to ggplot2, and thanks to Alison for some lovely little charts, some lovely little cutesy graphics which we'll be using. So this, I think I showed this book yesterday, the R for Data Science book. So this section very much shadows a lot of the stuff that's in there. That goes into a lot more detail. So if we do some stuff here and you want to go, oh, how do I find out a little bit more on that? Definitely would recommend that. Obviously, I will share the slides and you'll be able to click on that link and you'll be able to go there. So yeah, don't worry about that. So ggplot2. ggplot2 is one of several plotting systems in R. So there are lots of different ones. So base R comes with some plots, and I use some base R plots when I'm just doing my very initial exploratory data analysis. If you want a really quick and dirty plot that, you know, I just want to see the distribution of my data or something like that, and I want to do a histogram, literally you can use base R and it will ping something up in no time at all, and it's amazing for that. I mean, it's an ugly chart, but it will come up, you know, in like one line of code with one command, super quick. So most people use ggplot2. ggplot1 doesn't really exist. It's a bit of a weird thing. It's a very old package, as in it's been around for a very long time. That's not to say it hasn't been updated. It's been updated countless times, but it was so old that when they first did the updates to it, they did a massive change to it and basically broke everything that ggplot1 did. So everything's all in ggplot2 now. I mean, maybe they could have called it something else entirely, but anyway, it's part of the tidyverse, and it is the majority of charts are done in ggplot2. There are other plotting systems available. So we do have something called Plotly. If anybody's used Python, Plotly is a library that's also in Python. If you want to do sort of more interactive charting and things with like hoverovers and drill downs and stuff and things like that, Plotly is quite one to go to. There's things like HiCharter, and there's various other plotting bits available. But ggplot2 is your bread and butter, and it is used mainly across the board, and it allows you to create some really, really beautiful graphics. So if people like the BBC use it, the Financial Times, the Economist, and lots of very, very high graphically good people use it, and it's quite interesting. Once you kind of get to know the style, you can sort of see them, and it's really nice when you see out in the wild, oh, that's an R plot. I recognize that, much like you do when you see an Excel sheet, an Excel plot, and go, ugh, that was an Excel plot. Anyway, that's just me. Anyway, so why is it popular? Obviously it's very well designed and supported. It is part of the tidyverse, so it uses those same sort of tidy principles, although does use it slightly differently. And you can, what's really nice about it is it's really, really customizable. I mean, the minutiae of stuff that you can change on a plot is untrue. Basically everything is up for grabs that you could change, absolutely anything within your plot. You might, if you're coming from an Excel background, you're thinking, well, what do you mean, like, change anything? It's like you'll see in a minute about just having that versatility. And it means that once you've, and you go, well, that's great, but in Excel I can just click and drag and press buttons and do stuff. But R allows you to sort of set that up within code. You're not having to manually adjust things over and over and over again. And once you've got it set up perfectly how you like it, you can just lift and shift that and just copy that code and pop it somewhere else, and just reuse it again without having to go through all that pain. So yeah, sometimes if you've got a really, really nice plot with loads of different things, the code, don't get me wrong, it can get quite lengthy and it can get quite complicated, but the beauty of it is it's absolutely reproducible, that you can then take that and just lift and shift it and pop it elsewhere, and you don't have to go through all that pain over and over and over again. And it means that if you've got things around consistency, or if you've got like a team theme that you want to use around a look and style, if NHS England uses specific colors for specific regions, so if you just want to set those, you can then share that code with other people, and then other people can just lift and shift that code into their ggplots, and then everybody's consistent. So really, really useful for that kind of thing. So yeah, there's a couple of arguments there about whether we should teach our ggplot to beginners or not, and we as a community decided yes, we are. So there you go. So there's lots of bits and pieces. There's a couple of examples of some very pretty little plots there, and that kind of level of stuff, really, really simple to to do. Well, not really simple, but yeah, it will be once you kind of get to the end of what we're doing, and just the versatility around the amount of plots and how much of it is built in. So again, sort of statistical plots and things. I remember building a what's it called, a box plot in Excel. To be fair, this was an older version of Excel, but you'd had to calculate all your quantiles separately, and then you had to kind of make a stacked bar chart and then like hide some of the bits and make them white in order to show the lines, etc. And it was absolute nightmare. I think more modern Excel does cover some of those things, but I mean, the amount of different plots that you can do is astounding. And just what is featured within there is just phenomenal. And yeah, yeah. Anyway, so what we are going to do is write some code. So let's start on a new, is that me? Yeah, let's start on a new project, because no, not a new project, a new script, just to keep it separate. I mean, you can keep it all in one if you want, but it might get messy. So I'm just going to create a new script, and this will be my plot script. And the first thing we want to do is load in tidyverse. So we don't need to install it, we just need to call it. Oh, I've already ran it this morning, so that's not going to thing. You should have that little thing that comes up with the warnings, etc. In fact, if I do, I restart my R. clear all my junk. And I run that. Yeah, it should come up with this stuff again. So I just restarted my R session, which basically wipes the memory from it all. So you should have a nice clean environment. Make sure that's empty. If it's not, you can click on the little brush here and that cleans it up. And load in the tidyverse. As I don't need to reinstall it. It should already be there as part of our environment, and you should have this. Hopefully there, hands up if you haven't got that or you got any problems, or just shout. We all good. It's fun. Yeah, I was scared. I thought it was going to be a hand there, Dan. We're all good. RuPaul.
It hasn't run.
Not for me either.
It hasn't run. What's it doing? So did you do like control and enter, or run over it and run, or has it come up with an error message? Yeah, when you
it's saying session restored from your last saved.
There we go. Right, so remember when, oh my goodness me, we went back to a previous thing, and I must admit I'm very naughty. I talked about this workspace button and how we should remove it. It looks like you probably didn't, which means it saved a snapshot of where you are, so it's hopefully lifting off from where you were. So I didn't do the good practice. It looks like you didn't either, so that's fine. So when we go into our global options, we should make sure that we untick that box and OK, which means when I reload, it's not going to save a snapshot now, and when I reload it in, I will have to load it in again. But that's fine. If you run library tidyverse and it just does that, that's fine. It means you've got it there. As long as you've run tidyverse and it's not run. Amal.
Yeah, it says similar for me, but I did uncheck that. I just double checked it again and it was unchecked.
Okay. And what happens when you run library tidyverse? Does it work?
Yeah, it works. It works fine. It's
fine.
just about that message, yeah.
Weird. Okay. I'm not quite sure why that is, but we will go. So we've called in tidyverse. So we are going to have a look at a bit of a problem and do a little bit of analysis using some charts, and we're having a look. So let's look at a problem, a perennial challenge for the NHS. So pressures in A&E. So I mean, this was written about 6 years ago, and strange, I think even longer than that ago. Strangely, we still do have pressures within A&E, all around our demand and our capacity. So we are going to load in the capacity AE data. So let's see if we can remember how to do that. So let's go to our import dataset from text, and then browse through to our AE data, capacity AE. Open. This hasn't got anything bonkers in it. So all we need to do is, copy this lot and paste it in. Yeah, could just be a weird cloud thing. No, that's fine. That's very strange that it remembered that. Maybe it sets it up for the environment and the project. Don't know. So if we run that, we should have that. So I'm going to whiz through. If anybody gets stuck, please shout, rather than, because I can't see. Obviously, if I was in person, I can see you rocking backwards and forwards with your head in the hands, but I can't hear. So let's have a look at our data and have a look what we've got. So hopefully everybody's got the data in. If not, put your hand up or whatever. So we've created an object called capacity AE, which we can see in our environment up here. And that's our data frame. So just talk very, very briefly about what a data frame is. And yeah, I think we've covered all this massively already. So a data frame is stores tabular data. It's a way of mapping data against its structure. So in tidy data, each variable calls a column, each observation forms a row, and each cell contains a single measurement. That kind of makes sense, and generally we that kind of makes sense. And each column is its own separate variable, each row is an observation of our data, and then each cell contains a single measurement. Not all data is tidy, and you can break every one of those rules with different data types and different ways of doing it. I'm not going to go into that now massively, because that does come into multiple more complex data types. But yeah, you can have column or a cell with more than one thing in it, which is a bit mind-blowing, but it is possible to do that. Likewise, you can have sort of data sort of split out into sort of really wide format. So you might have things like all the names as separate columns and details of what's in that column, yes or no. When we come to the intermediate course, we do a lot more about how we split our data. How do we convert wide data into long data, and how do we convert long data into wide data, and the reasons that we would like to do that. So that's coming soon, but far too complicated to go into detail around that. We talked about the term tibble. Again, that's just text speak, nothing you need to worry about. Essentially, it's the same as a data frame. And again, not going to talk too much about lazy and surly and complaining. Again, this is sort of more data-y stuff, but basically they don't change variable names or types, and they don't do partial matching. So yeah, don't worry about that too much, about what all that means. It will become apparent through experience and getting through there. But generally, it's just good practice to make sure that you try to keep your data as clean as possible, and also write very expressive code. And obviously remember to chuck those comments in there, which is good. Somebody did say to me yesterday that that was the most important lesson that they learned yesterday, was commenting, and I said yep, 100%, that is what we're looking at. So we should have some data in our global environment. If you click on the text up there, it will come up. I will just do something else as well very quick, although I don't know whether it works in the cloud or not. I'm sure I had problems with it before. So if I close this one down, I'm going to close my initial script down and just close it. So I'm going to get rid of my capacity AE. As I said yesterday you can run in your capacity AE. You can click up it up on the right hand side up here, or you can do yeah, this is, does it work? It's not working. Yes, it does. It just doesn't flip to the screen. Okay, so sometimes I might want to know what this capacity AE is, because I've written it in a bit of code somewhere. If you press Control and click on an object, it will view that object. So even though it hasn't flicked to it, it has opened that object up for me. So if I do, I don't know, empty cars, which we know is an object, it's one of the built-in ones, and I press and hold Control and click on it, it will open up here an empty cars for me and show me what's in there. So that's another way of viewing what's going on with your data sets. And you can use that on variables and on vectors. So any object that you've created, any sort of data object, you can create that. So it's a really good way of seeing what your data is. Amal.
Yeah, a quick one. It's pretty strange when you click on capacity_AE.csv. It shows you. It doesn't show you in a structured way, but it shows you like in yeah.
It shows you the raw data basically.
Yeah, the raw data.
Yeah. So that's quite nice.
Yep.
Yeah, shows you what's there. So yeah, just a really nice little thing that you can do to explore your data and just see what it's done. And obviously that's showing you literally that raw data, and then obviously here it's put it into that, it's done that whole, well, obviously that is comma separated values, isn't it? Literally, because it's a CSV, so it shows you literal the the comma separated data. Obviously that's going to work with Excel because it's got weird formatting and stuff in there. It's going to look weird. JSON file is going to look weird, and yeah, if you start bringing in like HTML stuff and things, it's going to look even weirder. So yeah, that's going to have, I don't know, CSV is probably the simplest data set to kind of see and understand. Anyway, let's go back and look at our capacity AE data and just explain what it is, because it's a pretty weird old data set. So it's got several columns. It's got 5 columns, so it's not huge. I think I showed you yesterday that you can click on that little button and it pops it out into another window, which is quite useful. Doesn't work so well with the cloud version because you can't use multiple monitors. But obviously, when you're at home, or when you're at your work setup, you can click on that and then you can have your data on another screen and work somewhere else. So it's quite nice for doing that. And yeah, we can also show that how we can do other bits and pieces. So yeah, likewise, if we run, if we type capacity AE and then just run capacity AE, pretty much like we were doing yesterday on our initial bits. So we do capacity AE and then just run that, very much like yesterday when we were just in that initial stuff. It just shows us the sort of the head of our tibble within the console, which is quite useful. Just to say that stuff you do in the console you can affect this object by stuff that you write in the console. So for instance, let me just do capacity AE attendance. So if we look at our attendance for row 1 is 81,600. I'm just going to use a bit of base R, so don't worry about this too much. I can assign it a new value within the console, and then when I look at it up here, you can see now that my data has got a 0 in it. So doing stuff in the console is really good sometimes if you want to do sort of just quick and dirty looking at your data. One of the things I like doing is I can never remember the column names of my data. So if I look at sort of capacity AE, that just brings back a list of my column names, and then quite often I will click on those and paste them in somewhere else, which is quite helpful, especially when you've got really big long data sets, etc. We'll go into more of that kind of stuff later, but just to show you that you can affect the main data from your console, which means that's where we get into that danger of saving the snapshot of the data. So if I save now with my where are we, global options, if I save this now with my R data and reopened it, it would reopen it and it would still have that 0 in there because I've changed it in the console. However, if I ran the script, it's going to give me a different result because it hasn't got that bit of stuff within the console. So that's one of the reasons why it's good practice to make sure you unticked that, because sometimes you can affect, you're just doing, quite often I do some exploratory stuff within the console just to check whether something works, and then if it does work, I'll chuck it into the main script. But again, really important that you make sure that you run through your entire script and that you haven't done something in the console that you're not replicating it elsewhere. So my capacity AE has still got a 0 in it. I am going to reload in my data, which should then fix it in again, which is good. So let's go back there. Sorry, bit of a tangent there. So we can run it there. So do we understand the variable names? No, we don't. So let's go through them. So what we have is a site, which is basically our site code or our organization code. So it's just a number of different sites. Then we have the number of attendances that they had in 2018. So purely, number of attendances that they had in 2018. Then we've got the staff numbers, and did their staff numbers increase between 2017 and 2018? Then we look at the number of cubicles that they've got. And then we also look at the waiting time. So it's the change in the number of cubicles that they had, and also the difference in the sort of average wait times, whether that's gone up or whether that's gone down. It's a bit of a weird data set, but obviously once we start visualizing it, hopefully it'll make more sense. So basically we're trying to compare last year to this year, assuming that this year's 2018, and seeing whether that staff increase has made a change, has made a difference to our waiting times. So and our sort of our cubicles, etc. So let's have a look at seeing how we can analyze that and come up with an answer. So beautiful phrase there. The simple graph has brought more information to data analyst's mind than any other device. Obviously, you know, we do love a bit of John Turkey, and we do love the old Turkey test, which is great. Although I always call it Turkey, and he hasn't got an R in his name, is Tukey, but I always get it wrong. Yeah, and obviously, you know, going back to the data visualizations of Florence Nightingale and the sort of Napoleonic ones, you know, there's some, and the cholera outbreak. Obviously, data visualization really important and something we really want to get as right as possible. So, our exam question is this: is a change in the number of cubicles available in A&E associated with the change in the length of attendance? So let's begin our code and our plot. So we're going to start with calling ggplot, which is our plot code. So we want to do ggplot, and we just want to open close brackets and then a plus sign. So where we were in the tidyverse, when we're wrangling data, we use the pipe operator to do additional things to our data, or then. In ggplot, we use the plus operator to say that we're going to add another layer to our plot, and essentially that's what we're doing. We're creating a base plot, and then we're just adding layer upon layer upon layer upon layer to it, and adjusting the layers as we go. So there are some sort of default layers, and then we will sort of give it very sort of specific things that we are doing. And as I said, we tell ggplot that we're adding another layer by using this add plus. So what we can do is, inside our ggplot, we need to specify what data set we're using, because obviously ggplot doesn't know what data set we're using. So we want to tell it that our data is the capacity AE data. So that's a great start. So if we do ggplot and data equals capacity AE, let me catch up. Data equals capacity AE. And as I said, if it starts doing that, if it recognizes it from then, you can just press tab, and that will finish off your line for you. So that's great. That's a start. Now we need to add another layer to it. So we're going to add a plus at the end, and we're going to use this geonPoint. So basically, a geonPoint is literally that. It's a dot. So we're going to make a scatter chart, a scatter plot. And what we want to use on our x-axis is the number of cubicles, and then our y-axis, we're going to do the change in the weight. And what we do, we need to put that within a separate part of our geonPoint, which is our AES, which stands for aesthetics. So aesthetics are very, very difficult to understand, but it will make sense once we do more of it. So we do a geonPoint and then our aesthetics. Our aesthetics are essentially the properties of our geonPoint. So if we wanted to do it different colors, we would tell our geonPoint to change the color. If we want to change the size of our point, we'd change the aesthetics. If we wanted to change the various different things of the actual point itself, we would put that in the aesthetics. Obviously, at the bare minimum, we want to tell where to put the point, so we need to give them its x and y coordinates, and so that's the absolute bare minimum of our plot. So let me do that. plus geom point. And as you can see, if you write geom, you get this massively long list of different points, geoms that we can use, which is basically different chart types, which are just the default ones from R. And then we want to put our aesthetics. So the aesthetics, the AES is another function. So we put that within there, and that needs another set of brackets. And we're going to do our D cubicles, and then separate our features with a comma, and then y equals d weight. Be nicer if I could spell. And then we can run that. So we can either press Control and Enter at the end, or we can highlight that and run it. And hopefully everybody's got a very simple scatter plot. Anybody not got a very simple scatter plot? We're all good, Dan. Anybody got any errors? Thank you, Richard. Thank you, Andrew. Thank you, Elaine.
I did initially get an error, but I fixed it. So
what did you do?
Put the X in capital. So
yeah, fair enough. So yeah, really, again, when we get into stupid things, not stupid things, picky things like that. Yeah, doesn't know, ignoring unknown aesthetics, X and Y, doesn't know what X is. Lovely case sensitivity there. And yeah, you get used to it because yeah, you have to. So there we go. Anyway, if I get back to that, so yeah, we can see there does seem to be, you know, some broad sort of correlation between our our wait times and our numbers of cubicles. So the change in the wait times from 2017 to 2018, so where we've had a positive change in the wait time, an increase in our wait time correlates with a reduction in the number of cubicles, and where we've seen there's been more cubicles in 2018 to 2017, we can see that correlates with a lesser wait time. So it does appear that there is a correlation between our wait times and our D cubicles just by eyeballing it. But you know, we're analysts, we're going to do better than just eyeballing it, aren't we? We're going to do some actual proper analysis. So let's have a look at what we can do. So choices, oh my goodness me. So yes, there are loads of choices we can make about our chart and what we're going to do with it and how we make it look. Obviously that was like a couple of lines of code to come up with the most basic, but as I said, everything is up for grabs. So some of the choices can be, you know, what shape to do the data points. So obviously by default it's put little round dots. Do we want to make them square? What shape we want to do them? So yeah, that's one of our choices. What other visual aesthetics do we wish to give to our geom? So we could change the size of it. So obviously it's given a dot at the moment of that sort of size. Do we want to make them bigger? We can do that. Obviously we've got choices around our x-axis and our y-axis. We've got that in by default. Potentially, if we wanted to, we could, where's my R gone? Oh, it's here, isn't it? What we could do is do random things like D cubicles plus 100. And then that should shift everything by 100 as we go along. Yeah, so you can see that's shifted my shift here. Not sure why you would want to do that, but there are, you know, there sometimes you can do that, which is useful. So you know, everything is sort of dynamic and you can change things as you know, as you wish. We could change the color of things. Obviously it's come through in a very dull color scheme at the moment, but we can change that. So so at the moment, our size, shape, color, and size is just using the default or all positions. So where are we? We're just going a random tangent about functions now. So yeah, so running a function does something, and we've used loads of functions. So that's all our little commands that we've used where we've used brackets, and functions can use from no functions, no sort of inputs to many, and they are separated by commas. So I think in some of the stuff we did yesterday, I'm just trying to think if we used something that didn't. Yeah, I think when I showed you the ungroup function, that just had ungroup and it was just open close brackets and it just ran the defaults. Just trying to remember if there was anything else we ran yesterday that had any. I can't think. But yeah, there are certain defaults in there, and it will have different arguments in there, and I said each of those arguments are separated by a comma. So likewise, when we did those filter functions, we're filtering on two things. We could say filter date equals such and such, comma, organization code equals such and such, and we could do that. So you can explicitly name arguments. So in our example here, we've done ggplot data equals capacity AE. Or we don't have to explicitly name functions, and there's like an order of functions within ggplot, and ggplot will know that the first thing that you feed into it is data. I always think it's good to explicitly name your functions, and we'll come to that in a minute, just because it makes things so much more readable, especially when you come back to it later. But if you are feeling really clever, you don't have to, but I would definitely recommend it. Likewise, you can do things like this. You could possibly write y first and then d cubicles x afterwards, and do y and x if you wished to. I wouldn't recommend it. Can you rename the x and y axis? As I said, absolutely everything is up for grabs, and we will go through that in some detail in a minute. So literally everything within that plot you can change, as into the color of the background, let's go back to the plot a minute. Oh, where's my plot? You see it's got these sort of tick lines. You can change those. You can change the scale of the graph. You can change the format. You can change the color. We're going to add some titles and some subtitles. We can make those titles dynamic, so we can add captions to say data downloaded today, and we can put the sort of today so that when you run the report, it automatically date stamps things. Data covers such and everything, but everything is up to grabs. So if we wanted the scale to go by tens, for instance, we could change that if we wanted to. So let's say we've just done the most basic start off a 10 default, but we can change that. Anyway, going back to this, yes, you can alter the order of things, and you could also, if you wanted to, we could write our code like this, where we have got a G on point, capacity AE, and because the AES function accepts X and Y as our first features, you could write it like that. Personally, I don't recommend that. I prefer to be very explicit, because I know when I come back to read it at a later stage, it's much easier if you are doing it longhand. However, if you feel very confident, that is possible, and it's also worth being aware of that, because somebody else might have written some code and they write it in that style, and you'll look at it and go, that's great, but which one's X, which one's Y, how do that, blah, 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 and at least you're sort of aware that is concerned. So geoms, we talked about geoms very briefly, and there's lots of different geoms, and we're going to do some experiments on some of those in a minute. But obviously we could do all the manner of charts you can possibly imagine, and I will send some links to, there's some beautiful data viz libraries where you can go, this is the type of data I've got some categorical data, and I want to change at a time, I want to do this, and it will run you sort of a flow chart and it'll say, brilliant, you want to use this type of chart, and then we'll give you some code and some examples of that type of chart, and yeah, that's really cool. So I'll give you some examples of that. So what we want to do is add in another layer to our geom. So within our code, we eyeballed it and we think we can see that there is a correlation. So what we want to do is add in a trending line or a regression line. So R comes with some basic, oh well, it's very annoying that the basic one it comes up with is a very complicated one. So but we'll do that. So what we're going to do is this: we're going to add in a geom smooth line to our plot. So make sure you put a plus at the end of your geom point, and then we're going to do a geom smooth, and then we're going to copy those same bits. So to be honest, you can do this and just copy that and change that to geom smooth and just tidy that up slightly. And that will add a smooth line to our data. Run that one. So this adds a trend line using a LOES method, which is least ordinary. No, I can't remember what it stands for now. Oh my goodness me. My stats credentials are LOES. So it is a local regression or local polynomial regression, which is a non-linear regression technique, and does something called, yeah, it's least ordinary. Let me see, how do I explain it? It uses a multiple regression technique in order to calculate the sort of the nearest fit it possibly can on data. However, we have got a pretty straight line, so actually I think a nice, simple and easier to understand linear regression is going to be absolutely suitable for this data set. So by default it does come out with this more complicated method, but we can tell it that we want to do a linear regression. So let's do that. So got to be a little bit careful about where we put our commas and we put our thing. So basically I want to add an extra feature to my geom smooth to tell it that I want to use a linear method or a linear model. So I need to put a comma in between my two end brackets and tell it method equals, and then speech marks, LM. And then that should give me a nice straight linear model. So not going to go massively into the stats of it now, but do shout if we don't. So doing this linear model, so we can see that it's a really quite good fit to our model here. R allows us, and I'll pop that into the chat if anybody wants to have a play with it. If you have done sort of linear regressions and you understand linear regressions, this is using just a base bit of R to create a summary of a linear model. So we can see we have called a summary of a linear model looking at the impact of cubicles on D weight, and we told it what data we've got. And we can see we've got, what have we got? We have got an intercept of 30, which is down around about here. So that's our intercept. And we can see the estimate for every additional cubicle that we add, it reduces our wait time by 1.16. And we've got a nice free star here that we have calculated our p-value to be. That is a statistically significant relationship between those two things. So looks like, yeah, we've got a really good thing that shows, you know, statistically we can show that the number of cubicles increases numbers of weights goes down, numbers of cubicles decreases, weights go up. Who'd could have imagined such a thing? And yeah, so we can show that nicely on the chart here, and we can also actually pull the stats up here for anybody who wants to get more into the stats side of things. I would thoroughly recommend never using a linear regression line on a chart if you don't know what it means. And it's one of my real bugbears. It's one of those things that people press on Excel and they go, oh, look, linear trend, press that button. If you don't know how to explain a linear model and you don't know what it means, it will draw a line for you no matter what. Whether that line is statistically significant or not is an entirely different story. And if you're using it on a time series, give your hands a slap, because you should never use it. Well, you can use it on a time series, but generally do not use it on a time series. It's not a trend in that sense of the word. Anyway, right, rant over. So that gives us a little bit of a point. However, we do have a couple of instances that possibly aren't looking like the others. So we do have these little dots down here, and they do appear to be a bit of an outlier. I mean, these guys a little bit, but definitely these two. So what's happening there? So we know if we look at back at our data, two of our sites, if we look at it here, where are we? A couple of our sites have had staffing increases. So how can we identify which of those sites have had staffing increases as well? Because you would assume if they've had not much of a change in their cubicles, but their waiting times have gone down, then perhaps that's because they've had a staff increase and it's not necessarily the effect of the cubicle. It could be the effect of the extra staff. If that makes sense. Everybody kind of clear with the hypothesis we're trying to put through there? So we're trying to add in another feature to our model, really, or our analysis. So we know that cubicles definitely does have an impact on weights, but actually does the staffing increase have an effect on those weights as well? So what we're going to do is go back to our code, and we've got our geom point here, and we're going to add in another aesthetics to our geom point. So we can add a comma in at the end, and we're going to do a color equals staff increase. And what that's going to do, well, we'll see what it does when we run it. Is a couple of things. It basically then highlights or colors in differently the staff, adds in an extra sort of layer to our geom. No, not an extra layer. That's not what it's doing. It's adding an extra feature to our aesthetics of our points. So it's now coloring them based on whether the value is true or false. So we can clearly see that these guys down here, where we have seen that staff increase, looks like that's why they are that outlier. Again, we could look into a more mixed model approach and go into the sort of the stats again, but I'm not going to do that because this isn't a stats course, it's an R course. But yeah, hopefully we can see that. While we have got that chart up, we can do things like press the zoom button if you want, and that will come through onto another window. Likewise, we can stretch it as well, and ours quite nice at sort of then doing what we want to make it sort of the size that we want, and it's very good at sort of resizing based on what we've done there. So that's really nice. We've changed the color. If we wanted to, we could change the size. So we could say size equals staff increase and run that. It's given us a little bit of a warning message. Again, using size for a discrete variable is not advised. Yeah, that kind of makes sense. And we can obviously see our big blobs there. And likewise, we can add in multiple. So if we wanted to do size and color, we can do that. And we can color those in, which is good. We could choose a shape. We can do things like, again, have our color based on our, I don't know, changing on our waiting times. So again, we can mix and match. So what I would expect to see is as our color goes across, no, as color goes up, as our D weights go up, the color will change. Yeah, which we can kind of see. So it's dark when it's quite low, and then it gets lower. So again, it's trying to give us, and as you can see, ggplot has automatically given us another legend to try to explain what the colors are. Not sure that's a very useful chart, but you know, you can do that kind of stuff. Obviously, again, we've just done defaults, and it's automatically it's created this sort of default color scheme where it's done these blues, etc. If you wanted to do it so that it got redder when it was higher and it got more, I don't know, got more green when it was lower, or more yellow, you can absolutely mess about and change all those color schemes and make your own sort of palettes of color and choose what you want. There's lots of people who've built specific color palettes. There's a lot of color palettes that have been built to be accessible, especially for sort of colorblind people, etc. So if you are sort of trying to make your charts more accessible to people, that's probably not a very good example of an accessible chart. There are also we can also add themes to our chart. So I'm going to do my favorite, which is theme minimal, and we can add that into there, and that just gets rid of the gray and does some other bits and pieces, gets rid of some of those lines, and just tries to concentrate on the data. Obviously, you know, there's lots of design principles. I'm not going to go into a huge amount of design principles. You know, we've got to work out what is that data to ink ratio. You know, we want as much insight with as little ink as possible. So let's not make really fussy charts. What we can do, and I can give you some examples at a later date, you can also sort of, you know, add annotations to your chart, and that's something I really recommend. I mean, I think I did a copy and code session on the other day, which is available on YouTube, so go and have a look at that. But you know, if I wanted to say, you know, if I wanted to put an arrow and a little caption here that said, you know, outliers or something like that, absolutely you can do that kind of thing, and you can build it so that those are created dynamically on your data. So if it recognizes there's an outlier, automatically points at it. I'm a great fan of sort of annotating charts. I think as analysts, we expect people, you know, we can come up with really, you know, complicated or chart like that and hand it over to our users and expect them just to look at it and understand it. Whereas actually, you know, if you look at most charts which are out in sort of publications, they are annotated. If you look at a chart that's in a newspaper, it's usually got big arrows telling you these are the bits that you need to be looking at. And I think it's really important that we do that as analysts. That, you know, that's a part of our job to analyze that data and provide that. But as I said, you can write that within the code, and you can have that. So, you know, even if there's a report that you know, the data is changing on a weekly basis, you can set up code that, you know, looks at the code, looks at the data, and automatically adjusts and does all those types of things for you. Okie dokie. Yeah, likewise, there are several different themes, so we can do I don't know, being dark. Let me guess what that does. Oh, it makes your chart hideous and dark, but obviously you can do that. You can also manually set up your own chart themes to do what you want them to do. So again, if you've got like a team look and feel or an organization look and feel, you can set up a, you know, a theme for your team and then just ask everybody to use it. And then, you know, if for whatever reason you want your axes labels to come out in Comic Sans, you can absolutely do that, and then just apply it as a theme and it will do that. So yeah, the answer to our question is, yeah, we have seen that those two sites have had an increase in staff levels, which has had an effect on the waiting times, even though the number of cubicles was relatively low. So again, really good sort of explanation of our data set. So important distinction time. So where we did our color, let's just do a nice simple one. Let's get rid of my theme dark because that's hideous. And I'm very sorry, I realized I've just used the same bit of code and I've adjusted it over and over again, which is really bad practice. I should have done new copies for each one, but that's fine. If you go back to the actual notes and the bits for the course, it will have it step by step. So my apologies, I should have done it separately, but I've started, so I finished. If I wanted to be more implicit with my, I can do size equals red. I don't think, let's just get rid of that. Color equals red. But if I wanted everything to be red, I can stick it outside of my aesthetics. And this gets a little bit more complicated. Where I had my color defined within my aesthetics, I was saying that that was going to be based on a variable. It's based on the data or something like that. If I just want to set a sort of a global feature, I can do it outside of my aesthetics and then set up my color as being red. I'll copy that into the chat for you because I guarantee you're going to get in a muddle with your commas and brackets with that one. And if I run that one, as you can see, it's changed all my dots to red, and that is sort of very specific. However, I can also have that within my aesthetics. And get rid of that one. I think it gets really messy with me. There we go. I could also have it in my aesthetics, and that will also work exactly the same because you know, it's just a global thing and it's just generically applied to everything. So that's fine. However, sometimes, you know, you can get in a muddle about where you put things. So if I wanted, you know, size equals 4, that's going to apply it everywhere and everything's going to be a big blob. But if I put it inside my aesthetics, it changes it on a base by base level. Size equals D weight. I don't know, I think that's going to come out with something really horrible. Try to scale it. Yeah, that's pretty horrible. And we can also do things like alpha equals 5. And we can make our points like translucent, which is really quite nice when you have, let's do yeah, so when you have got sort of like overlapping plots, you start getting those, you know, you can see where you've got concentrations and things like that. So where we've got these overlaps, you know, doing things like changing the translucency of your graph is really cool. And there's a really nice way of, quite often if you've got spaghetti charts and you've got lots of different things that you're showing on a chart, and again, I'm not going to go into data viz practice, but you shouldn't, please don't make spaghetti charts with like, you know, 50 traces or 10 lines going across them. What you can do is you can color in the line that you want everybody to see, the one that's important, and make all the others like really translucent in the background. So you've got that comparison to everybody else, but you're not then just, you know, wound up in spaghetti and can't, you know, see what on earth is going on. So anyway, I'm very mindful of time, so I just see where we are about whether we can do a break. Yeah, we can also write this a little bit code a little bit cleverer. So general big R principle is don't repeat yourself unless you have to. So are there any packages that apply that doesn't match the data as No, I don't think there are. I don't think it's going to prevent you from doing it. I guess R is going to say the question is just for the recording, because I know the meeting chat doesn't show up. Are there any packages which prevent you from applying a trend line that doesn't match the data, such as the example I showed earlier? Now, R will allow you to do pretty much any sort of nonsense that you like. Generally, as I said, I think it would be good practice if you are applying a trend line that you understand what that trend line means and that you understand, is it statistically significant or not? Because you can apply a trend line to anything and it will give you a line. The important bit is that you understand that linear model and understand, is that actual a significant trend, or is it just a noisy line that doesn't mean anything? So yeah, you can get some completely uncorrelated data and it will still give you a line whether you ask for one or not. If you've asked for one. Anyway, so I was just going to show how we can pull the data into a much not repeat ourselves. So at the moment we've repeated ourselves. Let's just get rid of this to make it easier. What's going on here? I lost contact. Backing up our session.
Yeah, quick one, Simon. Sorry.
Yeah.
Can we assign different shapes to different variables, like access? Yeah. Okay.
Yeah. Absolutely. There we go. Yeah. So if you again, like we changed the size based on the staffing, if you wanted to have X's for the staff or whatever, you can change all of those. Potentially, there is an input where basically you can import your own images into a chart. So if you wanted a literal chart of the scatter plot and each point was, I don't know, a picture of your face, you could do that. Or if you had a specific sort of shape or something you wanted to put in there, you can do that. So I wouldn't recommend doing that. Nobody wants to see a chart of my face, but potentially you can kind of do that kind of stuff. There we go, my R's woken up again. So if I go back to this kind of point, obviously at this point we are absolutely duplicating this AES function. What we can do is have that as a separate function that sits outside and then remove it from here and remove it from here. And then that will get applied globally. I've got an extra bracket there, haven't I? And that plus needs to be there. And that will then be applied globally to what's going on going forward. So that will work, I hope, exactly the same. So it just means you don't have to put your AES in each and every thing, assuming that your AES is the same throughout your chart. Sometimes you might want to do things differently, and when you get into more complicated charting you might have different aesthetics for different things. Quite often when you have when you're doing like labels and things, you'll have to have aesthetics. You might want to put your label slightly to the right, so your X axis might be X plus 5 or something, because you want to shift your label 5 points to the right of your D cubicles or something like that. So sometimes you do want to put your aesthetics in each individual point. So that's that. Okay, let's do a little bit of magic now. So facet wrap. Actually, so we're at past 10 now. Should we take a quick 5-minute break? Is that okay? And then we'll try to take another break at about 12-ish. Yeah. Cool. So let's come back at 10:45 and let's have a little comfort break.
So the real world examples that you showing here on your YouTube platform, where you also introduce the intermediary and immediate session, are they on the same examples, or they're different data sets?
The intermediate course, we use a different data set
for the introduction.
Yeah, so the intermediate one, we use a different data set throughout. Yeah, we don't use the same ones.
So like your already pre-recorded sessions on YouTube.
Yeah.
Whatever we've been discussing today and yesterday, are they?
Yeah. So the introduction courses that are on YouTube, yeah, will be the same. Yeah.
Okay.
So they will be the same. So the introduction always stays. So that we will make this recording available for everybody. And then yeah, we will also, yeah. So but the intermediate course uses a different data set. We do a lot of time series stuff within that data set. So yeah, I think that's what people were after.
Would we also be covering, so apparently we are covering offline datasets, connection of offline datasets, picking up offline, importing offline datasets. Would this session also include connecting our R Studio with the UDAL or other environments?
Not specifically, mainly because this course is open to everybody, so it's not very specific around that. However, for NHS England people, if you do want, there are some separate tutorials around how to connect to UDAL, and I can sort of send out links to those. For non-NHS people, if you want to know how to use your DBC connector to connect to your warehouse, I can show you how to do that. Obviously, I don't know how your warehouses are set up or what your warehouse is called, but if you've got access to it, Management Studio, you can copy the credentials from there into R, and then R will connect up, and yeah, that's totally possible. And I think there are some demos of how to do that. It's not complicated, and it does work really nicely actually in that very much once you've connected up directly to your data warehouse, it shows up in a connection very much like our SQL Management Studio does, so you can see all your folders, etc. And also you can actually query the database, so you can either tell R to run SQL scripts that you've already run from the SQL scripts, or there is a package called dbplyr, which is a sister of what we've been using, and you can use dbplyr to literally query the database directly, so you don't have to necessarily even learn SQL. You can use dbplyr and query your database using dbplyr, which is really nice. So I wish I'd learned that one at SQL, to be honest, because it works really well. And some of those complex things which get really messy in SQL, again, you're using dbplyr and it just eats those for breakfast, which is fabulous. So anyway. So what we're going to do, we're going to do some small multiple magic. So we have got, what have we got? We've got our little plot here. And at the moment, I think what we did our, let's go back to here. We did our start. Let's get back to a sort of a reasonable looking color equals staff increase. Ooh, what have I done there? I've got two geoms, that's why. Let's get rid of my geom smooth, because it's fitted a line across. Because I've set them as separate things as a universal, it's using them universally now, and therefore it's giving me 2 lines. So let's not do that. Let's just start with a nice simple plot that we had before. Yeah, because I'm not going to go into that. So we've got our geom plot there, and we've got our stuff within our. What would be quite nice is if we could plot our staff increase on one plot and our staff increase yes on one plot and our staff increase no on another plot, so we could compare them. So what we can do is add another feature to our plots, and we can do a thing called facet wrap. So this does utilize the thing called the tilde. So if you look on your hash key next to your enter key above your right hand shift key, so shift and hash, you'll get this little thing there called a tilde, which is using our thought for the life of me, and somebody did come up with one, but I've totally forgotten it. So all my other things, I said, yeah, that's the equivalent of saying such and such. This equivalent of saying such and such. I haven't quite worked out a nice, simple explanation of what it means. It's kind of like it's a little bit of a wild card in some ways, and it is used in strange places. You may have noticed that when I did my linear modeling, wherever that's gone, back here, yeah, when I ran my model here, I used a tilde to sort of my interactions between my weights and cubicles. So yeah, it's a bit of an odd one. So we're going to do a tilde, and we're going to do staff increase, and we're going to run that. And what that does is a little bit of small multiple magic, in that now it's plotted our trues on one side and our falses on the other. So if you can imagine, you've got a big long data set and it's broken up by teams or by regions or by hospitals or whatever it is you did, and you wanted to plot each hospital separately or each feature separately, you can use this facet wrap. And then instead of having everything all smushed onto, you know, our lovely spaghetti example, you can use this facet wrap to split them out. So I've just written a little bit of monkey code here, which I'm happy to share. I don't know if monkey code is the right answer. Anyway, iffy, dodgy code. And what that does, if you run that, it's just creating a random a new row, which has just got a random number in it between 1 and 5. So it's absolutely meaningless. But now if I say, just as an example, if I did my ggplot, and instead of my facet wrap and the staff increase, I did that on my new row, that is now going to create facets for each of my sets. So again, if you want to do those multiple, you know, good practice is use small multiples of charts, not chuck everything onto a single chart. So if you want to see the trend of what's going on over time, don't put all your teams onto one chart. Do small multiples, put them next to each other so that you can easily compare and see the trends across each of those things. And yeah, facet wrap is really powerful to do that kind of stuff. So, you know, pull out multiple charts from a single thing. We can, if we want, we can add in extra bits to our facet wrap. So we could do ncol equals 2, and what that will do is change the format of it slightly. So if we want only 2 columns of charts, we could do that. Obviously, if we did ncol equals 1, it would put them all in one big row, or we could make them wider or whatever we wish to. So again, each of those things is really massively useful around what we can do. Did everybody get facets working? Obviously I did it here with this new, I did pop this line of absolutely junk code into the chat. Oh, RuPaul, let's see what you've got. What's going wrong with you? Did it work with staff increase, or what's the problem, or what's your error message? Can I copy the facet into the chat? I'll do the one which is the staff increase, which is that one. And the one which is this extra one is that one. That will work then. Probably something to do with commas and brackets, I would have thought. It usually is. Okay. Any other problems from anybody? Have we got some pretty multiple charts? Yep, I hope so. Okay. So let's have a look at some different charts. So obviously we've done very, very basic beginners for start for one, and we've looked at a geom plot. So one of my favorite charts is the old histogram, which is very, very classic. So let's have a look how are the weight values distributed. And again, I go back to my lovely old Excel days, I don't know if you can do them now, where you had to sort of calculate all your bins and everything, pre-process it before you could then chuck it into a histogram. So let's do a new plot. Histogram. So we're going to do much as we did before. We've got a GG plot. Our data equals AE underscore capacity. And then we want to add in a geom underscore histogram. And this times we're going to do our AES and our X equals D weight. Obviously histogram, so we've only got an X for this because there is no Y. We're only looking at the distributions of our capacity. That's why it's not capacity AE. That will make more sense. That's given us a very, very different, very, very basic sort of histogram. Again, just based on some sort of default values. Everybody got a histogram working? Any problems? No. Yeah, I'm seeing lots of ticks. Diane. Was that a hand? Oh, was that a hand up to say you have done it rather than I've got a problem? I need to try to be consistent. Sorry about that. Yeah, hands up if you've got a problem. All right, no hands up. Fantastic. And also, hopefully, we can notice that ours come up with stat bins equals 30. Pick a better value with bin width. So ours suggesting it's come up with it's just using a default value, and it's suggesting that we might be able to do a better chart with a better bin width. So let's do what ours is telling us. So again, we want to do this outside of our aesthetics because it's not. So our aesthetics are about the actual plot bit itself, like the dot. If we want to change the color of those bars or something like that, we would put that inside our aesthetics. Our bin width is something that sits outside of those. So we're going to add in outside of our aesthetics. So that's one section of our aesthetics, which is our aesthetics and then an open and closed brackets. And now we're going to add in another value, which is our bin width, and we give it a value of 10. And if we run that, gives us a little bit more of a uniform spread, but yeah, a little bit of a flat. And likewise, you know, if we wanted to do much sort of wider bins or sort of look at those, we can do that. Or if we wanted to do, I don't know, very, very small bins, obviously we can change that depending on quite how granular we want to go with the data. But you know, really, really simple and quick and easy to see that sort of distribution of our data. And again, you know, from an eyeball, whether we think that's normally distributed or not, I don't know. I'm not convinced either way, to be honest. I don't think it really is. I think I would struggle describing what the distribution of that is. But because we also know that there are several features in play, and it's because there was that whole staff increase, etc. So yeah, that's a very, very simple histogram. Obviously, another thing that we do a lot of is a bar plot. So let's do a bar plot. So we'll do GG plot data equals capacity AE and would it help if I could spell? And then we're going to do geom col. And this time we do need an X and a Y. So we'll do X will be our site. And let's do our Y is our attendance 2018. I'm not sure I always get cols and bars and thing. I worked out the difference. So yes, there is a big difference between cols and bars. And it's very much about how much R does the work for you. So if you've got data where it's already grouped up and you want to do sort of calculation, I'm just trying to remember which way round is which, and you've already got an explicit value for what you want to plot, then geom col is the one that you want to use. If you are okay, let me come back to it on the break and I'll try to explain the difference. But there is a very difference, and one of them you can do much more things around if you want to do like stacked bar charts and things like that. And then geom col does something slightly different. But anyway, I guess get the one that works for you is the one that makes sense. So, what's going on there? Site not found. What have I done? Why is site not found? It's called site, isn't it? Same error, re-site. Is capacity AE? It's really weird. Let's try the old load the data back in. You're getting an error saying attendance 2018 not found. What? Does that change it? What have I done there? That makes... Has everybody got it working? Is everybody getting an error?
Same for me, site not found.
Site not found?
Yes, and for me.
What? What have I done?
I had a similar issue with the column D weight earlier, but then it seems to resolve itself afterwards.
Ah, I know what I've done. I didn't put AES in there, did I? Oh, it's a me issue. There we go. Oh, didn't put it in the aesthetics function. Sorry. There we go. Hopefully that's got it all working for you now. So we've got a chart. Yeah. Okay. Yeah. All okay now. See, I said, deliberate mistake. Very, very good to show. That people make mistakes and then work out what it was. So that makes sense. So that's quite good. But if we're looking at a categorical piece of information, so we're looking at our site, and our site is just a category of our site. It's not something that's sort of going over time or whatever. So actually showing it in, again, sort of spaghetti format like that isn't very useful, because what I want to know is, how do the sites compare to one another? That's what I'm really interested in. So what I want to do is have a mess about with my chart, and let's reorder our sites so that they are actually in site or in order by the attendances. So let's take this, and I'm going to start trying to get reorder by attendance. That'd be better if I could spell. So we start off with our data, but this time I want my X. I still want it to be the site, but I want to reorder my reorder my sites. So I can actually add in a reorder, and I want to reorder my sites based on their attendance in 2018, and add that in there. So from this one now, I get a much prettier, useful. If it's going to get it bigger, it would probably make more sense. More useful chart. We could also think about, actually, do we want it that way around, or do we want it? Let's do it. I prefer a swap mate. Oh my goodness me, I've got an alright muddle here. That one. I think I prefer a. Oh, I've definitely missed. What have I missed? Missed a bracket. Yeah, that needs 3 brackets at the end of there. So yeah, you see I missed the bracket because I've got this plus left over. If I run that one, that then gives me a little bit more of a, yeah, if I wanted to actually see who were my highest down to my lowest, that will be quite nice. I could also make it a little bit prettier by, oh no, not that one. So I've got to be very careful about where I put my commas. So I could add in color equal attendance. Oh, no, not color equals attendance. See, fill equals attendance. And then that gives me a bit of a thing. Actually, maybe I want to fill it so it's the other way around, so it's darker at the top. Okay, that's beginning to look, yeah, not too bad. Let's add a bit of a theme minimal to that as well. Yeah, that's beginning to look less shabby than it was previously. And again, oh sorry, I just noticed, will you be able to copy that into the chat? I'm getting error in, I can't see the rest of that error message. Yeah, but let me pop that into the chat. So yeah, it's beginning to look like a bit of a more useful chart. Does do some weird things, and it's done this weird color scheme, and we could can adjust all of that and do various bits and pieces to make it prettier. Again, not going into massive amounts of detail on that right now. But kind of give you the so that gives us an order by attendance. We've done a histogram. Maybe we want to look at the number of attendances by site and do it by sort of a box plot. So let's have a look at that. And again, we can do it by the staff. So let's have a look at the distributions of the wait times for those that had a staff increase and compare it to those who didn't have a staff increase. So let's do some box plots. So the ggplot and data equals capacity AE plus geom box plot, and don't forget to put in your AES this time. Now x equals staff increase of the sort of distributions across those waiting times where they had a staff increase compared to where they didn't have a staff increase. And again, just looking at our sort of interquartile ranges, we can see that we have got an increase, the average wait time has gone down, and we can also see that obviously the distributions has also considerably reduced as well. We can also do things like, obviously at the moment this is pretty cronky. Let's add some extra bits on there. So let's add some labels to our chart, because it's pretty messy, and you know we should label our things. So we can add labels. Title equals change in weights by staff increase groups. I think that sort of makes sense-ish. Our X label is staff increase, but let's make that actually staff increase, so that it's not that staff underscore increase. It's messy. We want to change our Y to be change in waiting time. Waiting time, and then data taken from, I don't know, AE, I don't know, from study X, I don't know where the data came from, wherever the data came from. And if we wanted to, and I'll do it in the next step, we could add a dynamic data or data downloaded as that. So let's just have a look at what that does. So yeah, we're beginning to put things up, and yeah, let's also add in our theme minimal, because I like that. And then yeah, we're starting to a little bit of a reasonable chart. Let me add in the dynamic dates to my chart. Let's do that. So we can add in a paste statement, data taken from study, and then this.date. No, data downloaded. And then we run that one. I have messed up on my brackets again. I need another bracket there. So there we go, and yeah, we've got this nice little startings of a sort of a dynamic chart. What we could do if our data covered a time series, we could create those sort of like, I'll pop that into the chat if anybody wants to copy and paste it. What we could do is sort of create some dynamic titles based on the time period that the data covers. So we could say, this is our, this is our name of our chart, and then we could do a subtitle that says data covers period, min data period to max data period. And again, that kind of stuff would just update automatically when we refreshed our code. I think that's really important that we sort of add those bits in there, that we've got our source of our data, and we can tell when it's done. Obviously, I've just used the sys date there, which is just taking today's date. Let's put it in ISO format. If we wanted to change it around and have it in sort of pretty format, we can do that and adjust the format of the date, etc. But hopefully you can see that we can start sort of building up different types of plots. We can also do simple things like, if we don't like a box plot, we can change that to a violin plot, if I can spell violin. I don't know if you've seen a violin plot. It's very similar to a box plot, but it shows the sort of the shape of the distributions, and where you've got the sort of the bulges. And if we wanted to, we could have a violin and the box plot. So we could add the violin and also have our box plot on top of it. But obviously, depending on which way we layer things, yeah, we can do it either way. And we could also, if we wanted to, a bit like I did, could do alpha was 0.5, and we could make our box plot a little bit more translucent, so we can see what's underneath it. So yeah, you can really getting into sort of playing with the art of the possible. And you know, you can, if I wanted to fill them in and color them, I think we can do that. We can do fill equals I don't know, staff increase. Is that gonna do anything? Let's have a look. Yeah, there we go. And just start to start, you know, absolutely messing things. If I don't like the legends on the right hand side, I can put it to the bottom. I can put it to, if I don't like the legend at all, I can remove it. So, you know, everything within that little that space there is up for grabs and can be altered and adjusted, and is sort of user defined as far and as much detail as you want to go into, which is really cool. Let me just pop that one into the chat as well if you want to play with that one. But as I said, I will tidy up my code at the end of this, and I'll make sure that it's available, although I should have done incremental steps, but I didn't, because I was very naughty. Sorry. Okay, what have we got next? So if we want to save a plot, there's a couple of ways that we can do this. One really nice thing is that we can adjust our window here to the size and format that we want it. I put it in a really weird place now. There we go. And then I can click on this export button, and I can save it as an image. I can save as a PDF. I can copy it to clipboard. I'm going to click on save as an image, and it would automatically use those sort of dimensions, those aspect ratios to save it as. So, you know, you don't have to sort of be specific. You can do it by eyeball and clicky drag type stuff if you want an idea. Conversely, we can also, you know, literally change the number of pixels here to what we want. I think 200 pixels wide is not going to make that much. It's going to be horrible, isn't it? That's not going to be very helpful. Let's do 700, update preview. And then if you wanted to, you can obviously maintain the aspect ratio and do that. And then you could just save it as a PNG if you wanted to. If you want to, you can also do something like here. We can do a GG save, and we can give it a plot name. So box plot, what have we got? Staff increase. Give it a name and a .png. And then when we run that, it will say, oh, there we go. What's it? I can't add. That's interesting. What's it doing there? Saving there, cannot add to ggplot object. Not sure what it's done. What have I done there? I will come back to that. That should have worked. I don't quite understand why it didn't. Anyway, you can add a GG save into that if you wish to, and you can save it. I'll double check what's going on there. However, you know, that's again looking at a very manual process of creating all your charts, popping them into images, and then I'm guessing manually importing them in some shape or form into another document, which is not what we want to be doing. We want to be making everything as dynamic as possible and creating sort of a nice dynamic report, which I believe we are going to do. So yeah, likewise within that GG save, we can give it a specific height and width, and you know, change all the bits and pieces if we wish to. So I think that's all the major stuff we're going to cover for plotting for now. Hopefully that's enough for you to understand basically how it works. believe me, there's a whole rabbit trail of stuff to explore in the sort of ggplot arena. And yeah, there's, you know, you can get really detailed into that, and like I said, I can give some examples at the end of some other bits and bobs, but yeah, you know, that is a huge area to explore, and there are tons of examples out there that you can go and have a look at and see what people are up to. But hopefully you've got enough to understand, you know, you do your data, you set up your geoms, you give them sort of attributes, and then you can add in things like the labels. If you want to, you can, like say, you can adjust the scales, you can you know, do things like change your scales so that they show percentage marks. You can like I said, really good at sort of adding annotations to charts. You know, we should try to make data as accessible as possible. So if you want to put, like, you know, comma marks in your scales, etc., you know, all of that kind of stuff is 100% possible. So any questions on the stuff that we've done around charting now? Otherwise we will crack on and start building a report. So yeah, any questions on plots or whatever at this stage? No, that's a thumb, that's not a hand. Okay, cool. No? Okay, right. So what we're going to do now is basically try to pull some of this all together and build a report. We are again going to on the table and I don't know, get on and do the next report. Yeah, just have it nicely automated and all sorted and ready to go. So I'm going to introduce you to Quarto. So Quarto sits alongside R Studio and R. It uses something called Markdown, which is its own sort of, there's sort of Markdown language. I'm trying to work out the best way to explain it. It's like I don't know, I was just trying, what is a little bit like HTML, but it's not HTML. It's far simpler from HTML around sort of text sort of manipulation and sort of formatting. So imagine if you had Word and you were kind of trying to code Word, and especially people who have used very old things like WordPerfect and things like that from the very old days, where you would set up you know, if you wanted to do a bold, you'd have the sort of like start bold, blah blah blah, end bold, and things like that. So it works very much like those old school ways of things. Obviously nobody uses WordPerfect anymore, and probably most of you are looking blankly at me going, what the heck is WordPerfect? Showing my age. Does anybody know WordPerfect? Please put your hand up if you know WordPerfect. Brilliant, thank you, Elaine, and obviously I'm assuming you're of an age as well. So basically it's a language where we can code text documents and WordStar. Yeah, I go back to my first office job, being allowed to smoke in the office, bad old days, but we had one floppy disk which had the dictionary in, and if somebody wanted to do a spell check on the document, you had to shout around the office and say who's got the dictionary, and we'd be flinging this floppy disk across the office. Good old days. You kids today, you don't know what you're missing. And also we only had one floppy disk of the dictionary, so if anybody wanted to add a new word in there, we had to like sort out some old words to remove from it because it was full. Anyway, oh dear. Right, let's go on. Create a document which is going to be a mix of our analysis and some wrangling and some output. So we are going to create a new script. This time, rather than doing an R script, we see we've got a whole bunch of options there. And what we're going to do is a Quarto document. So that is the second one down. We can do things like Quarto presentations, which allows us to sort of output directly as a presentation format, so that each thing is in its own sort of slide. We're not going to do that because that has a little bit more complicated syntax. But yeah, we are going to create a Quarto document, and it will ask us for new things. So it will ask us for a title. I don't know. I'm just going to call it Simon's Intro R Quarto. Whatever you want. Obviously, don't call it Simon's thing because that'd be weird, but yeah, call it whatever you want. Again, it gives us a couple of options around how we want to output it. We're going to output it into HTML. So the final report which we will produce will be a HTML document. That doesn't mean it's connected to the internet. It means it's a standalone HTML document that's readable by Firefox, Explorer. It's not Explorer, Edge, that's what it's called these days. Again, showing my age. Netscape, what was the one that AOL? Safari, but anyway, it uses a web browser to open, or a normal sort of browser, which means it's really, really accessible. It means that you can send this document to somebody on their phone and they can open it on their phone and it will all resize perfectly to them. But it doesn't, it is a standalone document. It does not connect up to the internet. And you know, that's really quite amazing. We can put into a PDF if we want to. That does require a little bit more of an installation because PDFs are really picky, but that's fine. And we can also output into a sort of Word format, and those are just the absolutely standard ones that we can do. Here that we can sort of also output into sort of PowerPoint format, or we can use as Reveal.js or Beamer. Again, Reveal.js is HTML based, so again, I could send it to somebody. It would come through as a presentation, but it would be a standalone document. They wouldn't need to have PowerPoint installed or anything like that. It's all built within the document, which is really, really cool. And then we do also have the options for Shiny and Observable.js. Not sure if you've heard of Shiny, but that's more of a sort of a server base where you create a script that runs on a server, and then that allows you to sort of build sort of more sort of interactive dashboards, things where you can have the data set and then run our code on it. You can build a front end to something, and then people can click on buttons and they can sort of run your code or run bits of analysis based on the code. The code runs on the server rather than the pre-processed runs on the server. However, you do need a Shiny server in order for that to work. And for those people having problems getting R installed, yeah, you try getting Shiny installed. Yeah, anyway, we're not going to go down that route. We're going to go for the very, very basic document, which has got HTML. And again, some of the really nice things about HTML, it's a really standard format that anybody's got access to. It works on, let's say, works on your phone, and it also has fantastic things that you can use. As I said, you can use HTML tags in there, which means you can set up things like alternative text and things like that, which is, again, really, really good around accessibility. Not going to go massively down that rabbit hole now, but, you know, if you did want to go down that route and make your document and your report as accessible as possible, it's there. Anyway, we now can press the Create button, and it will wobble through. And it will come up with something. I'm just going to move this over here. And I'm also going to press the clear object. So I'm just going to clear my data set just so I know I've got a clear section here. Likewise, if I go to my plots here, each time I created a plot, they were here. And if I sort of flick through, I can see all my previous plots as well, which is good to know. So they're sort of stored in memory. My goodness me, I did a lot of plots in mine. There we go. But I'm going to, again, wipe those and just get rid of them, just so I know that I'm starting with a nice clean canvas. So this is Quarto, and it comes in sort of several different bits. Let's just show you very, very quickly how this works. So we get a new button up here, which is called this render button up here, which is called rendering. So if we press the render button, it will ask us to save the file. So every time you render, it automatically saves the file. The first time you render it, it will ask you to give it a name. So which is this Simon's Quarto report. Quarto report. And then save. I think it also comes up with because we're on the net, it might come. Yeah. There we go. That's fine. That looks really scary when it does that. It's absolutely fine. It's just telling us that it might not have happened for everybody, but it's telling us it's going to do a pop-up because it's going to create a new window with our report in. If it doesn't come up with that, that's fine. But if it does, just press try again and we're all good. And it will show us what our report looks like. So basically, it also, when you start a document, it comes up with a sort of a basic report as a sort of an example of how it works. So it's come up with a title. We can see we've got some sort of subtitles. It's got an internet link there, which is again sort of like clickable, and then it's got some bits and pieces where it's got some basic code. This has actually showed the R code, so somebody has written some R code that says 1 + 1 and it's shown the answers. Or we can also code invisible and just show the results, which is generally what we want to do. You know, people don't want to see our code, they just want to see the results of it. And as you can see, that's opened up with a separate window, so let's close that. When we write sort of quarto documents, there's also two different ways of doing it. There's the source way and there's the visual way. So visual is quite nice because it kind of shows you what the end document looks like, although it gets a little, which is great when it comes to sort of doing your formatting. And if you wanted to change the format of the data, etc., it's got some really nice sort of helper bits here for you about if you want to, you know, make your text higher or you want to bolden your text or whatever. It's really good at that. However, I'm quite old school, so I always go back to the sort of source, and that just shows me it in code format. And to be honest, I find it much easier to see it in code format because it separates it much easier, and then you actually want to mess about with your sort of final formatting. Okay, so a quarto document is made up of 3 main sections. The first section is this little bit here, which is called the YAML, with a YAML. And there are various different, if you Google what YAML stands for, you'll get 500 different answers. I don't know, it's some sort of weird programmer joke as far as I'm aware, and that nobody really knows what it means apart from the person who created it. So yeah, I don't know, it's just called the YAML and I don't know why. It's YAML, and that basically just sets up the basic parameters for the rest of the report. So you only have one YAML and you can do some really nice in that, but that's fine. Yeah, don't need to worry about that right now. Obviously, that's where we've put the title. We can add some extra bits into that once we get a little bit more funky, and we'll do that. And then the rest of the report is broken up into 2 different types of sections. So we have, depending on what color scheme you've chosen, we have white sections, which is here, which actually, if I render this again, so I've got a version to show you. So the white sections are the actual sort of text bits of your report and your sort of your headings and all your blurb, etc. And then what we have is some R code, which is in a grey section. And then we can sort of separate chunks, and we call them chunks of code and chunks of markdown. And we can separate them by doing this weird 3 backticks, and the backtick again is up on the top left hand side of your keyboard next to your 1 key. There's a little funky key, and if you just press that, that gives you the 3 backticks, and then you do a curly brackets in R, and that will tell the markdown document now when it renders it together that this bit is R code. So run this grey stuff is R code, and then the white stuff is text, and that will just get just pulled through as text. So let's write a report. So let's just get rid of this stuff here. And what we want to do, and again, if we look at our report, do we want to show people our code? And that's up to you. So it's your report, you decide how you want to do it. If you do want to show your code in the report, so we'll have the code and then it will show the outcome, you can do echo is true. And if you want it not to show your code as you run it and have it as a separate thing, you can do echo is false. You can also do fenced, which I'm just trying to remember what that does. If that does, I think that allows you to do roll up, but I'm not sure if it works in the cloud. Huh? Once it done that, cannot save. Oh no, it's here. No, that's not done that. What is nice about if you do have this R script, it does create this copy to clipboard, so you can copy your R script from a markdown document and yeah, just paste it straight into whatever you're doing, which is nice. So anyway, I pressed that by mistake. So I'm going to do echo equals true, just so that my script has got, it will have the code and the script, and then I know which script is running which bits of my report. And then when I'm happy with it, I'm going to hide it all and change it all to false, so it's not there. We can also adjust some other things. So we know for a fact that when we load in our no, we'll cover that in a minute. It's just that simple. So first thing we want to do is, this is a standalone document, and when we run it, it will be a standalone piece of script. So if we're going to call in any libraries or anything, we need to call them in here. So that's usually the first thing that we do. So the first thing we're going to do is call in our tidyverse. So that will come through, and that will be our first bit of our script. So load in libraries. And everybody, please shout if I am going too fast. Second thing we want to do, because we have got an empty environment, is load in some data. So let's have a look at from our report yesterday. What was a good bit of data set? That was our bed occupancy. Let's do some stuff with our bed occupancy. So right up here somewhere. What have we got? That's our capacity AE, isn't it? Is that right? No, beds data. Yeah, so import data. So let's copy that, put that into our report. Yeah, and we can see that that has worked. We don't want the report to view the beds data, so I'm just going to get rid of that. So again, I can run this bit and it will go through. Or if I just want to run this chunk of data, chunk of R code, there's a little button here, and that just runs that entire chunk. Yeah, if I cleared that, I'll just show you that what that will do is load in my data. Everybody got some data now? We've got some beds data. So what do we do with the beds data? I'm trying to remember what we did with it. We did loads of stuff with our lovely beds data, didn't we? So let's think of a chart. So can I paste that piece? Yes, of course. So that's the entire chunk. So you need those 3 backticks and the open curly brackets and with the R in it to show that it's a an R chunk. And oh, let's do some good practice. Let's also give it a label. Load libs data and data. And that's just giving that chunk a label so that we know what our little chunk is doing, which is quite good. So let's keep that chunk independent and make that sort of its own thing. And let's create another chunk now. So we're just going to copy that. And we're going to do data wrangle. So we don't need to load in that. So you cannot have two chunks called the same things. Quarto will throw a wobble if you do that. So each time you do a chunk, you have to call it something else. You can do things in one great big chunk if you so wish. However, when we come to render it, it's less forgiving around its error messages, and it will tell you that this chunk has failed. And obviously, if you've got everything all in one chunk, it will just tell you your one chunk has failed. It will try to give you some more detail to that, and it will tell you sort of what line number is, but it's not as useful. If you chunk things up into separate bits, it will tell you there's an error in data wrangle, and then you know to go and have a look there, and then you can run data wrangle and yeah, help debugging it. So good practice to sort of split things out a little bit. So let's have a look at do you ever write your code in external scripts? Not sure what you mean by that. Oh, yes, I do know what you mean. So yes, literally, as we were talking earlier, is what we can do is pull in some data from another script and put it in here. So yes, you can write external scripts. If you are getting into your really fancy pants programming, you can basically write separate scripts for different things. So if you wanted all your data wrangling in one script, all your code for plotting, you can write that in a separate script. If we get into sort of like writing functions and things, you can have those in a separate script and then pull them all together. And that's called much more sort of like modular programming. That's a lot more advanced because it does get a little bit more complicated. However, it does mean that if you then want to, it means that you might make your code much more generic. And if you want to organize your code and take your function and apply it to another piece of work, it's much easier because it's in a separate place. Or actually, I made that really nice plot in this report and I want to use it in a different report. You can lift and shift it because you know exactly where it is and where it is. So yeah, there are different ways. There are some sort of good practice guides on how you can do it. There is a there are some templates which you can use as well, which are sort of set up. There is a sort of a governmental one as well, if you want to go down that route around sort of a cookie cutter template of how you should organize your R code. Definitely not going to go down that rabbit hole with you guys today. Just something you can be aware of and strive to one day to get to. I would imagine for 99% of the things and other people here don't need to worry about stuff at that level. So let's just, I don't know, take a bit of our code. So what were we doing here? We were, just remember what this, so what does this one do? This takes our beds data and, yeah, just to show you, it does do quite things. We've got 207 rows and we've created an average occupancy for date. Actually, so if I did bring that in, what does that look like? I know that's only giving us an average for one. If I do that, sorry, I'm just trying to work out some data that we can actually plot. Ah, there we go. So that's given us 21 rows of a bit of a time series. So we haven't done a time series chart, so it's again be good experience to do that. So let me just show that again, and I'll copy that into the chat. And what we want to do is have that as a new object as well. So we're going to do Devon partnership OC. And what we're also going to do is our org is Devon partnership. I'm going to have that separately and then have that as a variable that we can change. Because what we want to be able to do is potentially run our report now for Devon partnership, but potentially we want to run it for a different site. So yeah, let's have it so we can make it dynamic as we go along, which will make sense. Let me copy and paste that into the, I'll copy that entire chunk and I'll paste that into the chat. Obviously, if you can sort of type along as we go along, that would be really helpful. I'm just kind of be mindful of time, that we've got like an hour and a half left, and I would like to have a little break around about 12, just to see where we are. And I would like, obviously, a little bit of time for questions at the end. So if we run this chunk now, what do we get? We've created a new variable, which is Devon Partnership, and we've also got this new data object, which is our Devon Partnership occupation. Although I shouldn't call it DP, because obviously I made it dynamic. So let's just call it occupancy. Time occupancy. So it just shows us our occupancy over time. So we've got a data set now. So let's make a plot. So again, create a new chunk. Get rid of that. I'm going to give it a new label of time plot. Okay, let's do it right simple. So we have got, what have we got? We want to do a GG plot. Our data equals time occupancy. I haven't actually run that, have I? So our data equals time occupancy. And then we want to do a geom line X is going to be, what's it called? Date. Y equals, well, we're going to do the percentage, yeah, because we created the percentage up there earlier, so we'll do a percentage of our perk occ. So if we run that little chunk, perk occ not found. Oh, I haven't put my AES in there again. Good grief, Simon. Right, there we go. But at least we know what that is now. Yeah, AES, thanks, Dan. Yes, and now we've got a nice little blinky plunky chart. Let's put some points on there as well. Oh, I didn't. Oh, I did it bad, didn't I? Let's do that. Sorry, I am showing you such bad rubbish. But it's good to see that there are multiple ways of doing these things. So we're going to do a line. And then we are going to do a geom point. And then we are going to do theme minimal, just because that's what I like. So now, there we go. We've got a little chart, which is nice. So got a little bit of a workflow starting there where we are loading the data. I'll pop that into the chat as well. So we've got a little bit of a workflow now where we have got we're loading in the data, we are selecting an organization name, we are creating a plot, and then we are showing it. So let's just give it in our white space here. So this is our text. Let's pull some stuff through. So we can do, I don't know, was it bed occupancy report? This report shows bed occupancy over time, blah, 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 whatever you want to write in there. And you can obviously write very descriptive stuff around your thing. So that hash bed occupancy. So hashes in Markdown do different things. So previously we've used hashes to do commentary. Hashes within Markdown denote titles and subtitles. So a hash would be the highest level, And then if we do a double hash, it does a subheading. So, and this is our plot. So this is our plot for, oh, let's just get rid of all this stuff because this is old. Plot showing bed occupancy over time. Okay, and like I say, we're going to build up on this report and make it really, really swanky and dynamic as we go. But let's just start with the most basic. So there we go. We've got a report. So if we render that now, we should have something appear. So if you've got your report open already, it will show that. And as you can see, it's quite messy at the moment, but we can see that we've got our plot and we've got our thing. So everybody got that, or I can paste the entire bit of code into the chat. Everybody get it to render. Yeah. Please paste. Yep, just done that. So let's have a look at this and see if we can tidy it up a bit. So got is, as we know, when tidyverse loads in, it gives us a whole chunk of warnings, which is great when we're writing R. Not so good for the end user. They probably don't want to see that. So let's fix that one first, which is up here. And we can add another feature into our bit here, and we can do warning is false. And now if I render that, you can see it's rendering it here. Ooh, copy the code. Time occupancy not found. Is that what it said? Can't. Did I? Did you run this bit? So did you render it all and it worked? Amal?
I copied the whole thing and tried to run. So the code that I had,
sorry, you're breaking up again.
So code that you've shared,
Yep.
I've copied and pasted, and this is what I got. Let me just. And do we have to run selected lines or run current
No.
chunk, or
press the render button?
okay,
and that will run everything. However, as we go along, yeah, you will have to run it chunk by chunk. So if you run it chunk by chunk, it just runs the code sort of locally, and just puts the charts and bits and pieces here. When you do the render button, that's where it actually pulls it all together. So, and then that should pull through there. So by putting that warning equals false has now got rid of my warnings. And then if I wanted to, I could change all my echoes to false. It'd be better if I could spell. R has got a really nice find and replace feature as well. So you can do Control F to do Control Echo true and change that to echo false. And replace all. There we go. So now when I render my report, and we'd have a look at it, it's just the data and it's just a blurb, and that's starting to look like a little bit of a report. It's the start. It's good. Right, so let's just see if we can make it a little bit more dynamic and funky. So what have we got? We don't know which provider this is for, do we? Because we don't know. So what we want to do is do a little bit of mixing and matching in our data, which is really nice. So obviously what we can do is obviously we can show charts within our report. What's really nice is also we can pull in variables or numbers or other bits and pieces from our data set, and we can mix them into our markdown. So what we're going to do is bed occupancy report, and we're going to write 4, and then we're going to do a backtick R. And again, when we do the backtick R, it should do an open and closing backtick. And what we want to bring in is our org variable. And all we want to do is print out our org variable. Yeah, so that doesn't look like that's a massive change. But if we render that now, watching for changes, and we click over to our plot when that's all finished, now we have something that's a little bit more funky in that it's now giving us a bed occupancy report for Devon Partnership. So again, if we wanted to change our report and do a report for different sites or whatever, we just need to change one thing, and instead of having to update everything everywhere, we can we can do that. So we can be a little bit clever. So we can say things like this report covers the period, and we can do an R min of the time what did I call it? Time occupancy. And then I'm going to use a bit of base R because I'm a bit cheeky like that. And we're going to use the minimum of the time occupancy date. And would be even better and more useful if I actually spelt it correctly. So when we call I'll just show you a little bit of base R. So when we call an entire data frame, we can obviously see that pulls through the entire data frame. If we do a time can't spell time occupancy and then a $sign, we can select a single column of the data. So in this instance, I'm going to do date and then return, and all that will return then is just a vector of those dates. So when we get under the hood of R a little bit more, all a data frame is a collection of vectors shoved together. And then that's how sort of R does a lot of its work in sort of vectors. If people have done Python before and have got into sort of vectorization around Python, around how you do evaluations, R is vectorized by standard. So everything is a vector unless you tell it it isn't. If that doesn't mean anything to you, that's absolutely fine. Don't worry about it. But obviously what we can then do is we can write this minimum date. So this covers the minimum, so it will find the minimum of that to even better, all right, to, and then we can add a maximum, our max of that as well. And again, that should be fine. It's just because I've got it over here. So this report, blah, 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 covers that period. So again, if we render that and we look at Simon's report, we can see now that we have got those dates in there. And if we refresh the data and put new data in there, rather than again having to sort of refresh all of that manually, we can build that up to be dynamic to feed in there. Does that make sense? So let's I'll put that back up in there again so you can see that, and I also copy and paste that line in there if you had any issues with that. Obviously, good practice would be a bit like when we did the means yesterday, would be a min NARM equals true and the max NARM equals true as well, just in case there were any NAs within that data set, because that would throw it and cause that min function to fail. However, I probably in this instance wouldn't do that, because if it comes through as an NA, I want to know about it rather than ignoring it. So horses for courses, isn't it, I guess? So yeah, I would like to know. However, that does involve obviously having a quick eyeball over my report, and you know, no matter how automated your report is, somebody's always going to mess about with the data slightly, and you know, something's going to go wrong, or you're going to have some weird edge case, or I don't know, somebody's going to change one of the column titles or something ever so slightly, or I don't know, I've had it things where people have just changed date formats, or they've just suddenly put a leading space into something, or to be honest, the one that got me the most is, and it took me so long to debug, is that in a data table they changed, I work in the Southwest, so they changed Cornwall and the Isles of Scilly, and they changed the and to an ampersand. And oh my goodness me, I was comparing these two data sets over and over and over again. I was going, why don't they match? Why isn't it working? And my brain just could not see that, you know, because I just read it, you know, when I saw it, I just still read it as and oh, it's so long. But because R was, you know, it's case sensitive, it's not going to recognize an and an ampersand to be the same thing. So stuff like that can really throw you. Okay, so we've got a nice little report now that covers that period. We've got a bed occupancy, it's showing over time. That's quite nice. Let's do a little bit more of another plot. So where we did here, we had bed occupancy for one place. Let's try to do it across, I don't know, let's do it across 3. And also we could do that nice little faceting thing and show so, you know, 3 at once. So let's just copy this code and see if we can convert that into to be able to do it as a facet. In fact, have a go at doing that. So yeah, at the moment we've got it set up so it works on one organization. See if you can have a look. No problem, Louise. Catch up with you later. Yeah, instead of working on one organization, can you get it so that it works on 3 organizations at once? So you'll have to mess about with your variable. Remember to change that into a vector, and how do you tell it to be a vector? Feed that into your organization, your filter, and then adjust your plot so that instead of plotting them all on one, can we have a facet of each time series? Does that make sense? And then hopefully that would then take us to a sort of 12 o'clock and we'll have a quick break. So I'll give you about 2 minutes to 5, and then we'll see where we get to. If you want to stick your hand up if you've managed to achieve that. Ooh, what have we got? Warning, remove missing values or blah, blah, blah. Okay, that's fine. So I think what you've got there, Dan, is I don't think the data is very consistent in that some of the values are possibly missing for some of the areas. So R is trying to create a consistent chart across each of those 3 areas. So you've picked, I don't know which sites you've picked, but it looks like you've managed to pick a couple of sites where they've got inconsistent data. So one might have 10 dates in it, and the other one's only got 5. So it's trying to come up with the most common, as it were. So it's a data issue. It will still work. Obviously, it's still a warning. It's just telling you that there are some issues with it, and yeah, just trying to explain what that is. So let's have a look at doing this myself. So where have we got? Which one are we on? We're on this one here, aren't we? Yeah. So decided not to draw GG line because of it. Yeah, that could be because again, it might be because you've got multiple. You might have multiple points for a date time series as well. So you might have multiple dates on the line, and it won't like that. Let's have a look, see if I can replicate it and debug it, I guess. So what have we got? We've got beds data. So let's just pick a couple of random ones. I'm going to go for that one. University Hospital is Bristol, and the Royal National Orthopaedic Hospital. So where are we? So we need to make our orgs because we're doing a vector this time, and remember to put them in a nice little C to denote that this is going to be a vector, and we put those within brackets. So that now gives us orgs, and if we run that, we now have got a vector with our orgs, so that's looking good. Change that to orgs. Oh no, change that to orgs, and I want to do that my funky in, although I think a double equal still does work. So that's time occupancy, and yeah, let's just have a quick look at that. Well, yeah, those guys in there, so that's all good. Let's change that to orgs, time occupancy. I should call that a different data frame because it isn't. If you haven't, it will be fine, because the way that our code works is it runs from the top to the bottom. So it will run this and it will plot this first plot based on the time occupancy, and then if I make a new time occupancy here, it will overwrite it, and it will have a new one. However, just for consistency, I'm going to put an M in there just so that I am creating a different data frame. Also makes it a little bit easier to debug because I can see the differences across them, which is fine. So let's change that to data occupancy M and data occupancy M. That's going to be data occupancy M, and then I'm going to do a geom facet. Ooh, hey, I'm not going to do a geom facet. I'm going to do a facet wrap, and my little tilde and my it's org code. I think that org name. So if I run that one and just double check that this looks like it's working. Oh, there we go. I've got something very funky here. Why have I got that? Oh, because I've got a bunch of NAs on mine, which is not very good. Let's pick some different sites then that have actually got some data. Yeah, that should have given me let's say Royal Free London has got some data. But that makes sense. I think this is probably where we have that just issue in the underlying data, that we've got lots of gaps. So these guys have got some data as well. Let's pick them. I run that one now, and I look at my time occupancy M. Yeah, I haven't got a load of NAs, but that's good. And if I look at my plot, and we run that through, yeah, it's a little bit funky, but it's there. And then if I render it, it's going to cause me a problem. And if I read it through, processing file, error in pass block, blah, 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 blah. But this is the one that's a problem. Duplicate chunk label. And then, yeah, looks like I've obviously not changed my chunk label. I told you we can have the same thing. So I've got a time plot, data wrangle, multi, and let's call that one time plot multi, and render that. And now if we look into this, we've updated now, and now look, we've got a nice, oh, it has done that. Why has it done that? I don't know. It is weird. Anyway, I'll come back to why is that. So yes, we have got now we've got a report that shows occupancy for Devon Partnership, Royal Free London, North Staffordshire Combined Healthcare. This report shows occupancy of compliant, blah, 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 and also shows our time period, which is quite nice. Obviously, we could do a lot more around getting that chart looking nice. What we can do is we've got a bit of a gap here. It's not coming through very wide. We can tell it that we want it to go wider and squish it out a bit. Maybe we want each one, we just want one column, so we have one on top of each other so that they have sort of the full width. That might be a way of looking at it. Obviously, I haven't put a fee minimal on that yet. I could definitely change this perk oct and be something nicer. We've got a scale from 0 to 1. We could convert that into percentages, and we could do all manner of different things. But anyway, we are at 5 minutes past 12. Should we take a quick 10-minute break? I will pop the code, the entire code for all of that into the chat if anybody was having issues. Just so you can see that it, paste that into a separate thing, run it, and then you can have a look at it. But yeah, let's take a quick 10-minute break now and come back at 1:15. Okay, I think we're back in the room. Oops. So let's just add a couple of little touches of Christmas to our quarter report. And I'll also show you a bit of here's one I prepared earlier around some of the other bits and pieces that you can do with it. So let's do a really simple one-line touch of Christmas to our report. So up in our YAML, we are going to add another line, and we're going to write TOC, and we are going to say true, which sounds like really interesting. And then, yeah, re-render and see what that does. So 5 points to see who spotted what it does. Assuming everybody is back. I didn't say 20 past, did I? There we go.
Table of content.
Table of contents. And what can we see about this table of contents is that as we scroll through our document, I don't know why that has happened to me. I hope that hasn't happened to you. I've got no idea what is going on there. It's doing
it happened to us as well.
It has happened to you as well. What have I done there? That makes no sense. I've done something weird. What have I done that's weird? I see what I've done. I didn't put a plus there. That's what I haven't done. Oh, yeah, there we go. Have I done it on this one as well? No, that one's fine. So now if I render it, sorry, anybody who's following my code, on that last little bit after the facet rat, it should have a plus. There we go. Silly Simon. As you can see, as you scroll through the report, this dynamically updates, but you can also click on here and you can get to different parts of your different parts of your report, and it follows that same hierarchy that you make with your code. Sorry, with your bits here. So we've had plot showing occupancy over time. If we, I don't know, we did sub blurb or something. Blurb goes here, blah blah blah, and then third sub blurb or table or whatever we want goes here, and then some more blah blah blah, and we rendered that. What's really nice is that our report, again, dynamically updates. So I've got my top heading, and then I've got my next layer of heading, and then when I go into that, it then goes into my subheadings, and I can sort of have a look at that. And what's really nice is that sort of sits there and it sort of floats above the to the side of the report, but it stays there. And again, if I emailed this report to somebody, all that functionality would just work for them. It wouldn't be like an extra thing that they connect up or anything else like that. So there we go. We've added a little bit of a touch of Christmas to our report just in one line. Let's add some more. Let's add something else. So Quarto allows us to do these things called spans, and we can do some quite interesting things with our spans. So let's do, what can we do? We can do an information, but we're going to make a little information box. So we do 3 colons and curly brackets and a dot, call out, dash, note. And I'll pop this in the chat afterwards. Please note this data may be subject to noodles, or something possibly a little bit more useful than that. And then we close off our span. So a bit like we do with our free backticks, we can do these interesting things within spans to do stuff. And we can also do information. So let's have a look at what that looks like. So if we render that, let me just pop it into the chat, sorry. We have now made a really funky, nice looking information bar into our little report. So again, nice little touch of Christmas. We can do other things to that. So we can add some, if we can put a space there, and we can do collapse equals true. And we'll put some more. Also may be sharks. I don't know. Whatever you want, obviously, hopefully something a little bit more meaningful than that. Let me copy that one into the thing, and feel free to pop that wherever you wish. And then we can render this. Where are we? Render. And we go there. And now we have a nice little information box, which we can then click on, and it expands out to give us a little sort of explanation. So again, it means we can keep our, we can keep our report looking small, but containing a lot of data. And I'll show you some other tips around how we can do that briefly now. Because I think there is something about showing people as much data as possible, but not necessarily bombarding them with it all at once. So yeah, we can look at how we can do that. So let me just show you one I prepared earlier, and like I say, more than happy I can share the URL where this is. This is sort of publicly. Oh, there we go. Got rid of it. That was silly. This is publicly available, and this is a tutorial I wrote. Oh my goodness me. 2 years ago now, blimey. And this has got lots of details, and use it like a cheat sheet. The code for it is all available here in this GitHub repo, which is linked to right at the top of this. But basically what this shows you is some of the things that are possible within Quarto and how to do those things. So obviously we've done a lot of our stuff. I'm just going to show you a resource of what's possible to do in Quarto, and then if you want to learn how to do it, go to here, and it's got examples of how to do things. But again, it's just kind of showing you the art of the possible. We've done a lot of this stuff before, where we've just sort of like run code, and we've got this echo of what's going on. There's a little bit of discussion here around what the YAML looks like, and some of the sort of things that we've done there. So we've done things like the table of contents, etc. You can make a floating table of contents, and you can do various things like that. Talked about using the hashes for the different levels of subheadings, so you can have so if we look here within the thing, we've got a subheading 1, we've got to have subheading 2. Subheading 2 has separate subheadings underneath it, so you can really make this hierarchy of stuff. You can also tell it tell R to number your subheadings as well, and it will do that automatically. So it will create, you know, if you've got everything under one hash, it will go, that'll be 1, and then 2, and then 1.1, 1.1, 1.1, 1.2, and then if you've got subheadings under that, it will be 1.2.1, 1.2.2, and it will dynamically do that for you without you having to, you know, try to remember where you are, which is really useful. So it's really cool for that. You can do things like, let's just go back to here. Oh no, where's my report gone? Simple things like, where are we here? Back to here. So if I wanted my dates, for instance, to be in bold or italics, you can do these kind of a little bit like HTML tags. There are sort of shortcuts that you can use around bits of text in order to either make them bold or italics. So if I look at, hopefully that will run through pretty quick, and look in here, I can now see that, you know, one of my dates has come through as bold and the other one's come through as italics. And so there's lots of sort of formatting type stuff that you can do, which is quite nice. You can also create these like little blocks of stuff. And you can also make lists, which are really useful to sort of, if you want to do like bullet points, etc., and sort of like numbered lists, it can render all of those really quite nicely. You can, if you want to, you can use HTML tags to sort of format your code. So literally, if you want to, you know, add a bit of Comic Sans and change your, the HTML to change it to a different format, you can do that. Or if you want to change the size, the color, or the background, etc., you can do all of that. Or if you want to do like blocks of color in a report, you know, information blocks, etc., those are really good. Obviously, I showed you just now that we can do these little call outs, and again, these are really nice little tiny little snippets of code, but add such a touch of, you know, magic to a report. You know, if you want to put like a little warning sign saying, you know, warning, data may contain nuts or whatever, you know, really nice in there. And again, having these sort of like collapsible type bits are really nice as well. And again, you can decide whether it's you know, it's all optimizable or all customizable, so you can do things. Is it expanded by default, or is it contracted by default? So, you know, really good. You can import images from outside. So where I said that the HTML document isn't linked up to the internet, you can tell it to pull in stuff from elsewhere. So it's quite interesting how you can do that. So you can pull in images from elsewhere. You can also sort of do things like, obviously a lot of people say, oh well, this report's great, but it's really narrow and in the middle of the screen. You can make things wider if you so wish. Obviously we've done sort of basic plots before, which is really nice. If you want to sort of format your report so that you've got some, you know, you've got a plot on one side and you've got some data, some text next to it explaining it. Again, it's really quite easy to sort of set up columns within your data set and within your report and do things like that. So again, that's sort of explained how to do that. And again, if you want to do sort of charts next to one another rather than sort of doing facets, you can do individual charts next to each other. So, you know, if you had two different types of charts, you can sort of merge them together. And you can also then, you know, this text is for this chart and this text is for this chart. So you can do some really nice things like that. Hopefully some of you will recognize this as a plot the dots SPC chart. So we've written an R library called plot the dots, NHS-R plot the dots. And if you want to run SPC at scale, it's phenomenal. You just chuck your data in there and it will do all the coloring and everything for you. If anybody's used that old SPC Excel nightmare of a template, you know, we've just written a package where you pop your data in there and give it all the appropriate parameters, and we do that. I will run through how to use that within the intermediate course, but yeah, just to show you that it is out there and there is some details of how to find that here. You can also set up things like tab sets within your report. So if I've got a report here for provider RQX, I can also set up a tab here where I can look at some other data. And you can, again, really useful if you want to show, here's the plot and here's the I don't know, here's the table, and you can have different things within the tab sets, which is really nice. So you can sort of, again, try to minimize the size of your report, but have lots of information in there. And again, I think having people being able to click on things and sort of drill down into that just gets them a little bit more interactive in their, you know, what they're doing and what they've got. Obviously, we've done a lot of charting. What I haven't done is tables, because I guess that is the other big way of sort of showing data. I am running a workshop on tables apparently in July, where I'll use the GT package, which is kind of the equivalent of ggplot but for tables, and you can create some really beautiful tables. And I think there's a lot to be said about having a table. You can actually get across some really good stuff, and I'm not talking about conditional formatting. So we can do some nice things. Obviously we can do our conditional formatting, but we can also do things like add in bars into our, you know, our report. So, you know, if I was going to glance at that report and want to know, you know, who's got the highest attendances or when were the highest attendances, really clear and easy to see in that table where that is. And again, you know, a few lines of code creates that sort of bar chart, etc., within your table. So yeah, that's really nice. You can also make these sort of like interactive tables. And as I said, even though it's a standalone document, which I can email to you and it's attached, you can have it with these sort of like interactive features. So for instance, this is our data table at the moment. We're showing obviously just page 1. I can click onto other pages. If I want to, I can add in a filter and just look at the data for AAH, or I can pick multiple. Well, that's not very useful, is it? Let's have a look at type other. Yep, and pull those through. If I want to, I can sort of filter my data to a sort of specific time. And again, with my breaches, I can add in these sort of slidey type areas. And then once I've got to the data that I want, I can press copy, and that will copy it to the clipboard. Or if I wanted to, I can press the CSV button, and that will download a CSV cut of my data. So yeah, absolutely, you can download those data tables, and you can set it to do that. So answered you in advance, Dan. And you can also make more sort of interactive tables, which are reactive. So this is not a great example, but we're looking at the mean attendances for this period, and we can see the maximum number of breaches and the mean, so the median attendances and the mean admissions. And this is across this date. We can then drill down into it, and we can see how this is broken down by each of the different types. And then if we want to drill down even further, we can then look at it at a sort of site-by-site level. So you can create tables that have sort of hierarchies, which you can sort of then drill into or whatever, which is really nice. But without having to pre-process all the calculations at all the different levels, that's just dealt with within this sort of piece of code here, which is quite nice. Plotting. So again, we've done a lot of ggplot. Talking about Plotly, we can make these sort of more interactive plots. So you know, we can make these plots that have sort of hover overs. We can obviously sort of click on a point and see what it is. We can also sort of turn on and off traces of our plot if we wanted to. So if we want to just concentrate on a specific area, we can do that. We can also sort of click and drag. I'm really interested in what's going on there, and we can sort of pull it back there. We can also, how do we go back home? Yeah, home button, that's right. We can also, at the moment, obviously that's just looking at one. If I wanted to compare it across each of them all at the same time, I can sort of like press buttons that do that. And if I wanted to, I can press the camera button, and that will download by plot as an image. And again, that's all just built in. I can send that to you as an attachment on email. It's standalone. You don't have to be attached, you know, apart from receiving the email or whatever, or you can post it up into Futures or wherever you put your reports, and then somebody can use that. And again, all this functionality I can send to you. You can open it on your phone and it will work on your phone because it's using HTML. It's not using anything sort of super clever at all. So, you know, that's amazing. I've had people look at reports on their, you know, iPads, etc., and, you know, really pull out information and have a play with some of the interactive features, which is really nice. So yeah, Plotly, like I say, the zoom function is really good. This doesn't look very nice chart until we sort of zoom into it a little bit more, and then we can see how those attendances are changed. We've got a whole load of box plots across all these different sites. And again, when we click on or hover over our box plots, it again gives us our sort of interquartile ranges for our box plots, which is, you know, really nice little feature. And again, the code to create this chart with all this functionality is just this, which is, you know, quite crazy. So that's nice. If you really want to, I'm not sure whether this is a great example, you can create these lovely animated charts, and you can have it so that you can sort of go backwards and forwards and see where we are over time. That's not a great example. I think the best example I did is creating a population pyramid and showing that over time. I think it was over COVID, and I was working in the mental health trust at the time, and we were looking at our referrals, and we could see there was a real shift in the age and gender of the people who were being referred over COVID. And yeah, by having that sort of as an animation and changing, it was really visible, rather than just looking at a single sort of static and then comparing it to another single static. It really brought it to life. So I would recommend that. What I don't recommend is 3D plots, but yeah, we've got a nice 3D scatter chart here that we can even sort of zoom in and out of and have a look around. Some people may have done sort of 3D density charts in some really clever stuff and come up with something insightful. I'm not convinced that's particularly insightful, but it is very pretty, and you know, it's quite interesting that you can still hover over those, and it gives you the your X, Y, and Z formats. Some other charting types are things like digraphs, which are more for sort of dynamic graphs. Again, this is looking at sort of a time series over time, so it's really good that you can sort of like click and look at sort of the windows of stuff. What you can also do is, this chart is add in a rolling average, and again calculate that on the fly. So I can say I want a 3-month rolling average, and then it will show me what that looks like. And obviously, as I go up to a larger and larger rolling average, it gets flatter and flatter, but it just calculates it on the fly, which is really nice. What have we got here? We've got some nice little Likert charts if we're doing what we're doing surveys, so that's really nice to have a look at. You know, how to do sort of survey type charts, which is nice. We've got tree maps, which is kind of an alternative to a pie chart. And again, this is kind of interactive, so we can click on sort of specific areas, and we can sort of drill down into them and sort of go up and down and sort of see those comparisons. It has got a hover over, which sort of tells you the numbers. You can sort of point them on the actual document itself and have those, and that's really nice. I think I'm just showing off with various different chart types now of what you can do, and again, really interesting about what you can make interactive. So this is a collapsible tree, which is really good for sort of showing pathways and sort of flow as an alternative to like a Sankey diagram. So we've got our base data, which then goes into other areas, and then we can sort of click and see where that goes. And again, that's really, really nice, and you can sort of see those proportions of how many patients started there, went through to this area, and then sort of came through there. Obviously, this is just based up on basic data, so it's probably not that effective, but yeah, really interesting to sort of build those up. And again, these are sort of all really, really interactive to see what's going on around what's going on and exploring your data. What have we got next? Not going to go massively into heat maps, but this is quite a classic one around measles and the introduction of measles vaccine. So we've got cases of measles, and again, we've got plots within plots here where we've got side plots and sort of, so if I just zoom in a little bit on this, we can see we've got, oh, that's probably not good enough. Let's try and find another bit of an area. Is that going to be better? So yeah, we've got a sort of a heat map which shows us our number of cases over time, and it's all broken down by loads of different states. But I think, you know, what is quite clear of when was the vaccine introduced and then what happened to the number of cases. And again, that's all built using Plotly, the code for that. So all of this nonsense is just within this bit of code here. So it does all these sort of interactive side plots, etc., and the individual bits that we can look in and everything. You can also set up plots with sort of drop-down lists. So if you want to swap from one provider to a different one, we can just create a plot, and you know, we can see the plots for different areas, which is quite nice. Again, adding that little bit of interactivity. So yeah, that's all built with Plotly. We can do maps, so this is a little bit more complicated, but we can do maps, and what's really nice, we can obviously set up areas. We can also sort of zoom in and out, which will be great. We can also set up layers within our maps as well. So if I just want to see team A, I can just make sure it's showing team A. You may notice that our little man for team C is rotating, mainly because when I was running it, where is it? Where's it gone? Yeah, there's an option for spin, and I didn't know what on earth that meant. So icon is male, the icon color, the marker color, and spin equals true. And I just wanted to know what spin equals true is. And yeah, it makes it, literally makes the little icon spin, which is nice. But yeah, I can sort of click around and do stuff for that. There's our packages, which let's have a look at, see if you can work at this, where you can do like word clouds. And again, it does all the sort of tokenization and everything around sort of stop words. So hopefully you can see where that's come from. That's sort of obviously a little bit from Alice in Wonderland. I downloaded some free and open source non-copyright material. But, you know, to do a word cloud, you've got to do things like remove all your stop words. So you don't want things like and the and things like that going, because, you know, if you look at a normal piece of text and do just frequency, things like the will just come up the most than and. However, ours got loads of really, really nice text packages for that kind of manipulation where you can do things like that. And you know, this is even itself is interactive in that the word caterpillar appears in that text 21 times, whereas Alice appears only 20, and the word, I don't know, yawned arrived once, which is, you know, really, really cool. And yep, you can also do things like mermaid diagrams. If anybody's done anything in Mermaid, Mermaid's another one of those sort of weird languages which is used for sort of flow diagrams, but allows you to create, you know, from this code. If I want to show a process, you can sort of build that within sort of Mermaid, and you can get into sort of like really quite complex sort of workflows that, if you know, if you're trying to explain quite a challenging thing about how things work and how your code works, you know, having a really good flow diagram is quite often a really good way of showing you things. Another alternative is GraphViz, which again does more sort of publication-y type diagrams of stuff. And if you're doing, if anybody's done any directed acrylic graphs, then digraph is really, really good for building those. And that's probably it for now. So happy to share those. I will ask Kaylee to send me everybody's emails, and I'll do a follow-up email where I make sure that I'll share my code that I've written today and tomorrow. I'll share this resource. I'll send you the links to the R Slack channel and various bits and pieces there where you can sign up to Coffee and Code and various other bits and pieces if you so wish. It will also show you what other sort of workshops and things that are going on there. I'll send you a link to the NHS-R YouTube channel where there are lots of bits and pieces shown there. Obviously, we did have a yearly conference, and there's a fantastic amount of talks and bits and pieces there. Other than that, we've got about 10 minutes for any other questions. Oh, yeah. Let me stop sharing. So yeah, any other questions? I'm happy to have a bit of a free-for-all. Any? Do I do Giraffe? Yes, I have used Giraffe. I mean, to be honest, mostly I do use ggplot and a smattering of Plotly, but mostly ggplot. And also happy to share my GitHub. And if you want to go, something that somebody asked yesterday was, you know, can I see some examples of your code? And hopefully, yeah, I mean, absolutely, I'm all for open coding. So all my code is out there on GitHub and out in the open. I do try to comment it as best as possible. Although, however, if you're looking at some of my older stuff, you know, some of my early stuff, maybe, who knows? But yeah, I think it's really good to see what other people have done, and hopefully you've got enough now where you can at least read a bit of code, even if it contains functions you don't understand or don't know what they mean, but you understand the syntax and kind of understand what it's doing, and yeah, understanding that. And again, you know, by all means, have a look at some of the more advanced charts and stuff that other people have done, and you know, copy them and steal with pride. But yeah, if anybody's got any questions or feedback or anything, do shout. Coffee and Coding, yes, it's open to all. Yeah, generally under sort of normal NHS-R, which is open to sort of health and social care people. But yeah, it's open to all, and yeah, that's not a problem. We do have, you know, it's not necessarily NHS specific, so yeah, we do have non-NHS people there. And we are trying to make the recordings available as well, because I appreciate we got in a real mess around when we were holding it. Yeah, I'll send that out in the response. Hopefully Kaylee will give me a list of emails, or I can send her a forwarding email and she can forward it on. And the next one is, I think the next Coffee and Code is, when are we? Friday? Am I right? Yeah, next one is this Friday at 11 o'clock. So yeah, the NHS-R Coffee and Coding. You can sign up via the website. Pop it in the chat now if you want to have a look. It's just me blurbling on for about another hour. Were you going to show us something about ODB sync or SQL connection? I can show you, but it's not going to, obviously, yeah, let me just fire that up. So give me 2 seconds. I can definitely send out links on how to do it, but obviously it's going to be different in different areas of how you're how you are configured. In my last trust, I just set up my ODB connection and it just pinged straight through. In NHS England, we've got extra layers of security and have to go through a whole bunch of stuff in order for it to work. Let me just fire up my UDAL and I can show you. But the basics for that, the actual principles of how it works will be the same. I've just got to load up my virtual desktop. So in NHS England, most of my R stuff's all on virtual desktops. I'm just loading that up, which is, let's say, I think I've got like code examples where to share the report. So no, you download it as a file, not a link. So it's not hosted anywhere. It literally is a file, a .html file. So you would download that and attach it to an email. So let me see if I can find one I made earlier. And I also need to share my screen as well, don't I? So that would make more sense. Let me see that one. Yeah, okay, so let me just share my screen again. Which is that one over there, isn't it? So here's a report what I did earlier. And again, sort of showing, you know, some nice funky tables. So this was a quick bit of analysis looking at category 2 ambulance response times and handover delays. And again, nice little table with some nice little histogram charts in there, just so we can see the sort of distributions of handover times and response times. And yeah, I'm sure a lot of people are aware down in the southwest we've got some issues with our handovers and our response times. And then created a report which again looked at the correlation between the response times and the decimal hours. Again, built sort of that linear model and then created a little chart to do that. What was more interesting is, you know, and then converting that into text. So what's really nice to say around this model predicts a baseline if there were no mean response times. The average response time would be 22 minutes. However, each additional 100 hours of handover delays means the mean response time increases by 5 minutes and 19 seconds. So each additional amount of handover delay, the impact that has on delays. But if we look here, where's it gone? No, not there, wrong one, this one. This here is the actual, oh, let's get rid of that. And get rid of that. Where's it gone? It's here. So I've got too many screens open at once. So that's my actual report, is this ambulance delays, ambulance report. And literally I would copy that file into an email and it would open up for you and you could do whatever you wanted with it. Yeah, and I'll just show you again, this has got, where are we? If we go back to here, this has got, again, I did tabs here rather than repeat the data for or the report for each of the 7 different regions. I had it so that you could click on each of the different regions and see what that impact was, and it was very clear that Cornwall is where we had the, you know, absolute the biggest problem. And again, a nice little chart, a nice little table there with some charts, etc. Also does things like referencing. So if you want to do add references to your report, you can add those in there. So I don't know where one is. One's up here somewhere, isn't it? Oh yeah, so yeah, we've got a nice little one there, and obviously that references down here. And then obviously these are sort of also live links for sort of contacts that set up emails, etc. So yeah, just click and drag that into your thing. Anyway, I was going to show the what we got. No, not demos, desktop repos. Has got some data that's probably the easiest. That one. So there's a couple of ways that you can do it. You can write your SQL within R and have a little bit of raw SQL, which you paste into SQL and paste into R and tell it to run it, which is what I've done in this instance just because it's all in one place, and ignore update. So if we look here, let's find a bit that's right. Okay, so it's just, so you would have to set up your server address, which obviously is going to be different from place to place. And you can also, you need to tell it obviously which database you're going to work. I could have all these within my connection, but I've done that here. And then you need to initiate your connection. So if I run that bit of code, it is going to give me a little pop-up where it's going to ask me for my details and also my two-factor authentication, because, you know, we care about our data. And verify. Now, as you can see, I've got a new tab has appeared up here, and I've got something called UDAL Warehouse. And I'm sure a lot of people here will probably, or any NHS England people will recognize these. There's a bunch of tables and it's in the same sort of format depending on what you've got. So very much like a traditional the viewer of the warehouse. I can also use this connection string, and here I've got some really simple code here that is, let's just put it down to, I don't know, 2. And I can actually, as you can see, this here is actual just straight normal SQL, and I've just got that within another statement. So if I run that one through, it might not work because I haven't actually loaded the library. So yes, I have. Yeah, okay, that's fine. I've done it now. So that's going to take a little while, but that should just be running that SQL within my R to pull that data through. I can, if I wanted to, have my have my SQL in a separate area. NHS. There we go. Right. So yeah, now when we go to my environment, oh, I didn't clear it, did I? I have got here some data. Also, it hasn't come through with anything because I think my data is really laggy, so that's not very useful. But anyway, that would set up a connection. If I go to NHS Futures, there is a workspace called, and again, I'll send out a link to it, NHS-R community, NHS England R community. Within the resources, I think, no, it's not the resources. Let's go back. Within the code sharing area, there is a bit of script there, which has got a whole load of different ways of connecting to SQL. What's it doing? Oh, it's loading up my R over here. That's why. So here's one I prepared earlier. Ignore update. Yeah, so these are the libraries that you will need. This is how you open up the connection. So you can either run some, you can either run some code directly here. You can tell it to run some external SQL. So if you've got that same query but saved in a query called test SQL, you can just tell it to run your SQL. So if you want to write your SQL in just normal SQL Management Studio, you can get it to do that. Or you can use dbplyr, which is what I talked about earlier. And this is how you could run that same SQL query in dbplyr in order to run that and then close the connection. So that's all on our that script is available wherever I said it was just now on our futures page, which was here. And then again, that's got some interesting areas and resource issues. It's got some of the old recordings for coffee and code, so some of those are really quite interesting. And also, if you're using in UDAL, quite often you get a simple 00 lock error, and there's a nice little tutorial there of how to fix it. And that's an NHS England thing, not a wider thing. but happy to share that. Oh my goodness me, I've got 1 minute left. So somebody's put, I've always had to put self-contained in the YAML to get sharing quarters to work. Is there a better way? No, that works. That's fine. Self-contained, putting self-contained true is best, especially if you are using lots of interactive resources. I should have put in there. Yeah, should have made that note and made that explicit. Any other questions in the last 20 seconds? Dun, dun, dun. Any other shout outs? Okay, I'll wait for Didier to type something. No, he's decided it's not. Oh no, it's coming. Oh, thank you. That's fine. Okay, in that case, I will let you go away. Hopefully the sun doesn't melt your brains any more than I've melted your brains this morning. Please, give us a shout if you get any stuck or get any queries. Happy to sort of do that. Hopefully see some of you again in a couple of weeks for the intermediate course. I will send out a link to that for the course materials if you can't make it, and at least you can go and have a look at it. And it is written in a way that you can sort of follow it. You just haven't got that, person talking through it, and haven't got me blabbering about talk through stuff. So yeah, that'd be good. And yeah, I'll send out all the links and various bits and pieces if I remember what on earth they were. In that case, I will let you go. Thank you ever so much for coming. Do tell everybody about how wonderful it was and how brilliant it was. Obviously, if you know who my manager is, tell them how brilliant I was, because that all goes down really, really well. Obviously, I'm doing this out of the kindness of my heart. So if you, do send a thank you note or whatever, it's really, really helpful. And, it's good to show that, people are really, really interested in this stuff. So please do that. Other than that, send any feedback. Always really hate to say who's my manager, or if you bring it to me and I can forward it on rather than sort of name and shaming here. Although, yeah, that would be good. That would be thank you. So yeah, thank you all so much, and hopefully see some of you in a couple of weeks.
Thank you.
Bye. Cheers all.
Thanks a lot.
Cheers. Thank you.